parallel lines coming from the sun on a globe, because that would make the solar noon the same for everyone.
I didn't say
that was his argument.
What did you say?
Me or George? Who are you asking?
I think you mistook what he said. That's not what he said.
What did he say then?
From my understanding, if the sun was 93 million miles away, every sun ray that hits the Earth would be coming parallel. We would not see diverging, converging angles or anything.
So he was referring to corpuscular rays?
I did at first. That's why this came up.
Well, I'm pretty sure he said the sun wouldn't have a GP. And then you said that made sense. And I'm so far trying to understand what he meant by that.
Okay, so you want to get up on something he was trying to explain, then you're going to have to ask him.
Well, you said you understood it. That's why I'm asking you, because I can't understand George's reasoning.
Well,
he didn't say
it's because you assume that. Let me talk to him, George. Please. You assume the sun is 93 million miles away. Once you're willing to challenge that notion, then you can explore everything else.
Sure, I'm willing to challenge the notion.
Have fun defeating your own purpose of being here.
Make whatever argument you want. I'm all completely open to listen to it. George just made one that I didn't understood. You said it made sense to you, and then I'm asking you.
I'm on the highway,
and now you're talking about something different.
Yeah, I'm on the highway. I'm using shitty headphones, and it's windy. So I don't know if you're gonna hear everything I'm about to try to say, but I'll say it again. If the sun was 93 million miles away, you would see parallel lines. You would not see sun rays coming down at different angles. Like, go outside tonight and take a picture of the fucking sun and then look at it, and you'll see the sun's rays coming out from it from all angles. That's why anytime you ever tried to draw the sun when you were growing up, you drew lines on top of it, to the left, to the right, pointing down. You drew triangles pointing in all directions around this circle. So everybody on the Earth observes the sun's rays shooting in all directions. If the sun was 93 million miles away, you would be seeing only parallel lines shooting straight directly at your face.
How did you determine they're not parallel? How did you determine they're not parallel? How did you determine they're not parallel?
Because you could see that they're not. All you have to do is look at the sun.
Yeah, so what you're saying, we're giving me these pictures.
I'm a crude explainer. I'm new to all this. That's why I'm falling back.
Can I get to the end of my sentence? Right. If you're showing me pictures of the light rays from the sun converging at the picture, right? We know parallel lines can do that. It's just called perspective. So if you're not accounting for that, then you can't just show those pictures and expect your claim that the lines aren't parallel to be.
Lines converge, they're no longer parallel.
Let me ask you a question, Bacon. Let me ask you a question, Bacon.
So perspective doesn't exist in electric.
Does the GP of the sun changes or not?
It does.
So there you go, man. So it cannot become in parallel. If it's changing all the time.
On the globe they can. Why not?
It wouldn't make a difference, would it? It wouldn't make a difference on your angle reading. No, because if it's coming parallel, which one is coming parallel? The one from the left, the one from the right, the one from the middle. They're all coming parallel, aren't they? So it doesn't make a difference, The angle.
It does because your vertical is changing.
Let me say, the thing that's bothering me about your explanation is you just use the word perspective. You don't say anything but it's because perspective. It's because perspective.
Well, we all know that. We all know that parallel.
Explain.
If you do elevation angle to the sun, you'll find out it's a local sun.
Okay, so if I take a picture of with a camera of two parallel lines, even though they're parallel, if you measure the distance between them all the way, it's the same. On the picture, the lines that they form on the picture are converging, right? We all know that happens. Correct? It's what we call perspective, correct? Electric?
Yeah, I'm working right now, bro.
No, was I correct or not? But he asked me to explain it. I'm seeing if we at least agree on basic daily observation.
So you're saying two parallel lines can appear to be intersecting?
No, converging. But what about 10?
I didn't say intersecting.
Oh,
what about 10 or 20?
Whatever, dude.
Well, isn't that what perspective is? You take a picture. There are two parallel lines in your picture. When you look at your picture, at the
how
picture
many parallel
they are
lines?
converging. Correct?
How many parallel lines you would
Like
say is
railroad
coming down
trains,
from
right?
the sun? How many parallel lines from the sun down? How many you think?
I'm not George. I'm trying to follow
I'm trying
reasoning
to
here. You're just
figure out how
interrupting.
many parallel lines are we
I'm in the
taking out?
middle.
Because you're
I'm in the
giving an
middle of
example
something,
with
George.
two.
Stop, George. I'm in the middle of something. You can just ask random
Yeah,
questions.
but you're giving an example with two parallel lines.
George, I'll have to mute you if you keep doing that. I'm trying to follow a
Bacon.
reasoning with electric. You're just asking random questions in the middle of it.
Bacon, can I confront you on this point that you're making about perspective?
Hit me.
So, if you're saying that the sun rays through a hole in the clouds that appear to be expanding all the way to your feet, you know, as they approach the ground, they spread out, it looks. And if you're comparing that to like two vertical train tracks or just two like poles that are going up to that hole in the cloud, and yes, they would look to converge a little bit because the top of it is further away from you than the bottom of it, you know, just because the hypotenuse will always be longer, right? But that means that if you ever took an airplane above those clouds, you're telling us that the crepuscular rays would seem to get well, they would flip upside down, right? Like the way they would converge. So you're saying that they would appear to converge. You're saying that the light rays, the crepuscular rays, would appear to converge closer to the ground if you were at cloud level.
You mean like if the rays are
as high as the
right? Yeah,
as high as the
that's what
hole in the
happens.
cloud, and now the crepuscular rays should converge towards each other the lower they go.
Yeah. So that's what happens if you're at a high mountain, right? And
I've never seen reverse crepuscular ray photographs, so
oh, it's just the opposite. So if you're looking towards the sun and you see the light rays spreading as they get close to you, if you turn 180 degrees and look the other way around, now they start converging. I want to see if I can find a picture like that. I've seen a couple.
You wouldn't have
I'm talking about
things
going
like
downward.
You know,
I'm just talking about going downward.
You know? Yeah, you wouldn't have a hotspot on the clouds, for example. When you see from pictures above the clouds,
there's not a lot
hotspots on the clouds.
There's not a lot of space. There's not a lot of distance to work with when you're talking about seeing such a big expansion. You know, I've seen crepuscular rays at like 80 degrees. You know, like an 80-degree spread. Right, that's a huge amount of convergence by the time they get to the clouds for two lines to be parallel, you know, and then
yep.
I don't get what's
but when you're talking about I'm talking about the angle of spread of crepuscular rays come through a hole in the clouds. They only have the distance from the cloud hole to the surface to work with, right? And when you're saying like you know, light going into the distance, just like horizontally towards the horizon, well, that's a lot more distance to work with, which you know would make it
depends on more
easier
stuff,
to see convergence.
It depends on more stuff. It depends on the size of your field of view, right? Like perspective is calculable. It's not complicated to figure out how much it should look like if it was this way or that way.
As long as you have all the factors, it's easy to calculate.
Sure, yeah, we have an average.
He's assuming one observer from one perspective. Point is, when you have different observers spread it out, pointing at the same object, the sun, and they are pinpointing at the same time on the same location, yeah, the sun triangulation, elevation angles to it. It's when it contradicts everything, because at every 10 minutes you're going to do a different reading to the sun, because it's further up in the sky or lower down in the sky, or it's on its highest point, depends. But everyone is having the same reading. Everyone is having the same reading. That's the point. Yeah. So it's not perspective. It's not perspective.
where you can see the same shadow expanding and then diverging, then converging in the other side. It might not be the best example, but that's one example. Oh, there are other ones. Yeah, you can see the shadow of that. What is that? An airplane that the baby posted, and they're converging, right? So it's the opposite when you're looking to the other direction. They converge as they get away from you. That's what perspective does to things. It shrinks them. It brings them together if they are traveling all in the same direction.
Yeah, but like I said, they don't account for that on celestial navigation, do they?
Because they only care about direction.
The angle, yeah, they only care about the angle.
Yeah,
The elevation angle.
The angle is
at that time, yeah, it needs to be at the precise time, you know, because if you move away, you know, it's a different time. The angle is going to be different.
Sure.
So it needs to be precise with the time. But if you have different observers at the same time, yeah, within the same location, doing the elevation angle, it's not about perspective, is it? They all have a reading to do.
Okay.
So
the perspective doesn't affect the direction of things.
Yeah, but
the directions of things tells you
within minutes.
What gives you perspective.
Listen, the GP of the sun is always moving, meaning it cannot be parallel. It needs to be divergent, like any other light in the sky. The elevation angle already gives you a distance to it. It's local, obviously.
How is that necessarily local?
It's just been answered, man. Inverse square law.
How does inverse square law imply it's local? I didn't get an answer for that.
It's simple trigonometry, isn't it?
No, inverse square law has nothing to do with trigonometry.
Okay.
Yeah, even if like farther in my perspective, parallel lines seem to meet each other, that's cool and all, but you know, I'm seeing a light ray from the sun shoot absolutely to the left and absolutely to the right. That's not convergence. They're like opposite directions. That's different. Sun rays shooting up and sun rays shooting down. Like that's not about my perspective.
Can you show that?
Can I show that? Type in photo of the sun.
Yeah, I've seen a bunch of them.
Or go outside. How about that? And you'll see that.
Yeah, none of them are incompatible with parallel rays diverging because of perspective. You're saying they're opposite. Of course, if you're aiming at the sun, divergent rays are going to be opposite to each other. But like, why isn't that covered by perspective?
Rays. We haven't even addressed the rays, sun rays. I don't know what that is, but whatever that is, you know, the sunlight cannot be coming in parallel. That's against the model. It's against the elevation angles. It's against celestial navigation.
How is it?
It needs to be because it's moving. Otherwise, you cannot shoot the GP of it. The GP would be a ginormous GP.
No.
Yeah. The GP of the look. If the sun was the size that they tell us,
let me answer. Let me answer you, George.
Half of the Earth is
illuminated by it. You made your claim. Let me answer you, George. The GP would be where the light rays reach the surface perpendicularly. On a sphere, that's a single point, George.
No, it's not. On a sphere, on a sphere, you cannot have an elevation angle, man. Yeah, it's a single point. Yeah, you cannot have it on a sphere. You cannot.
I'm gonna draw that.
You need a horizontal plane, not a sphere. You know, you need a horizontal plane. You don't need a sphere. Listen, you need a horizontal plane, like a protractor. Yeah, you need a zero line, a straight line, and then you have elevations above that line. That line is representative of the surface of the Earth, the sea level, the zero line, and then you have elevations above it. So if the sun if the sunlight was coming in parallel and it illuminates half of the Earth all the time, it wouldn't make a difference for you to make a reading on, I don't know, in the morning or at 12 noon or in the afternoon, because the GP, the light is coming in parallel. The angle is going to be the same. You're going to achieve the same thing.
But
You're going
on
to
the
have
sphere, they
different
only.
zenith.
No,
Listen,
George.
the zenith is going to be the same, regardless
No.
where you are.
No,
Yes.
because the zenith, George, the zenith is vertical, right? So on
Yeah,
the
but there's
sphere,
only
they
one zenith
change
to the
with
sun, isn't
position.
it? Yeah, but there's only one
Exactly.
one
That's how
zenith.
it works on the sphere
So
as well, George.
that's what I'm saying. It's against the model. You can only have one zenith.
Oh, George.
Mm.
Okay, I'm drawing. I'm drawing
You're
here.
implying
I
for
hope
the
that clarifies.
you're implying that the sunlight, because it illuminates the half of the Earth, the sun rays are coming in parallel. So it doesn't matter if it's in the morning or 12 noon or the afternoon. They're all coming in parallel, aren't they?
Oh, wow. Wait, I've been stepped away. You mean you agree that sun rays are parallel?
No,
Isn't that what you guys are saying?
he's saying
It
that on
doesn't
the
make a
globe.
difference.
He's saying that on the
Listen,
globe,
you
it
guys are
can't be parallel
saying the
because we
sun
would all
rays,
get the same zenith to the sun.
the sun rays are coming in
Ah.
parallel. So it doesn't matter what time of the day you're going to measure an elevation angle, to the sun. It doesn't matter in the morning or afternoon or 12 noon. They're going to come in parallel, isn't it?
Huh?
Okay, George, I'm gonna send a picture on live stream on text.
Listen, isn't the sun
hope you take a
illuminating
look
half
at
of
it.
the Earth? Isn't the sun illuminating half of the Earth all the time?
Oh,
Yo,
carnivore
If the
no
already did
matter
that.
sun is,
how much,
if the,
no matter
if
how
the
much
sun
light is
rays,
bending through gas, no matter how much light is bending through the gas, no matter how far, no matter where the sun is, or how high or low, if it's 93 million miles away, the rays should be parallel. That's
Correct.
it.
Yeah, they
Like,
are.
what else is there to
Yeah,
debate?
yeah, but no one's arguing it's not parallel. What George is saying is that if they are parallel on the globe, the zenith to the sun would be the same for everyone. Do you understand that? Do you understand his claim?
no, I'm not saying on the globe.
Wow.
It cannot be on the globe, man. Listen, forget about the
Why?
globe. You cannot have
Why
elevation
can't it
angles
be
on
on
the
the globe,
globe, man.
George?
Because you cannot have elevation angles on the globe, man. You need a horizontal plane to do the elevation angles. These things cannot be done on the globe. It's against the model. That's what I'm saying. And the
How is it
model
against
says
the
that the
model?
GP, the model requires a flat plane in stationary for these things to be happening. The elevation angles. Yeah.
George,
So
take a
for
look
you
at
to do
live
the
stream.
elevation angles, listen, for you to do the elevation angles, the sun rays cannot be coming in parallel.
Why?
It's against the model. Because it's
Why?
against the model. It wouldn't
Why
make
is
a
it
difference.
against the model, George?
It wouldn't make a difference to shoot the sun in the morning or afternoon or in the evening because it's coming parallel. The angle will be the same.
Not in a
Thank you.
globe, George.
Have a good one,
That's
man.
Not on a
why a globe
rotating
shows
globe.
it.
On the globe,
Sorry,
listen,
Yeah.
forget about the
Dude, I'm
globe.
killing it today. I have no
Why?
idea why. It's different. Bro, I've been getting nonstop boom, and I'm not even scheduled. They're just throwing me everything. Thanks, man. His name was Melissa?
Electric. I think you're hot mic.
Ah, here I go again with the hot mic. So sorry, guys.
That's okay.
I was trying to understand how that was related to the conversation before I realized wasn't supposed to. Anyway, yeah. If you're complaining about what we believe, George, you have to take into account all of it, not just half of it.
No, there's nothing about believement. I'm talking about celestial navigation. Yeah. Celestial navigation doesn't require a globe. Yeah. It requires for you to
The
count the Earth
fixed
to be
does
flat
require it.
and stationary.
But it
Yeah.
does. But
Now,
it
The
does.
fixed
that part
require
is out of
globe,
the
George.
equation. Listen, there is no globes into account here. I already told you. For celestial
Yes.
navigation, or any type of navigation for that matter, but in specific celestial navigation, you need to account the Earth to be flat and stationary before you even grab a sextant. So we don't
Everyone that
account
says
for any
that.
sphere. For every, what do you mean?
No one that says that, George, know how to make a fix.
Listen, you need to account the Earth to be flat and stationary. That's why you're shooting the stars or the lights in the sky. Yeah, and you wait for them to move so you can shoot again the same light. So the lights are moving, not you. Yeah, and if you're shooting the sun, if you're shooting during the day, so you're using the sun different times. And the reason why the pilots used to have eye patches was because they were looking at the sun with no protection whatsoever. But anyway, if you're shooting the sun and the sun rays are coming in parallel, it wouldn't make a difference at what time of the day you're shooting the sun.
On a flat surface, you wouldn't. Correct.
Yeah.
Yeah, it has to be a flat surface. Already, the disclosure is from the beginning. It only works on the flat surface, man.
But the sun changes in its angular position as the day goes
Correct.
by, George.
Yeah, it's an
Yeah,
angle
and it would do
above
that. It would
horizontal.
do that on a globe too. It would do that on
No,
a
it's an
spherical surface too.
no, it
Yes, it
cannot have
would.
elevation angles. You cannot have elevation angles on a globe, man.
Yeah, you're
You
wrong, man.
need you need to have a horizontal plane to do so. They tell you in the beginning of the book.
George doesn't want to discuss the subject. He wants to monologue on the subject.
Yeah,
Not
he wants to
monologuing, man.
dominate. Yeah.
Yes, you are, George. You're not explaining
George,
why, you're just claiming over and over again.
Yeah,
Well,
it's just not true.
you guys are going against the model, man. You're going against celestial navigation. Not against me. You're going against celestial navigation.
Yeah, only people. Yeah, again, people that say that, George, can't do a fix. So, what is likely going on here?
Fix. Yeah. If you have a fix,
Yeah.
man, welcome to Flat Earth, man.
Except you can't demonstrate it. Why has no one
Yeah, you can't have
demonstrated it, George?
Well,
Why has Oakley not demonstrated how to do it?
Show us how do you get the fix. Go on. Show us how you get the fix. Step one. Go on. Let's go through it.
There's
Once you have the fix,
there's plenty of demonstrations on YouTube. You can go. They're real easy to follow.
Once you have the fix, I only have one thing to say. You already know what's coming, don't you? The problem is to have the fix, isn't it? So what would be the first step to get the fix? An elevation angle from a horizontal plane. I see.
Take an observation, do a dip correction, subtract the elevation angle from your
elevation angle. Yeah, that's the key point, the key word, isn't it? How do you have an elevation from a flat surface?
It's easy. You do the dip correction.
Yeah, dip correction.
Yeah, it's in there. That's the way to do it. Unless you want to argue with the procedure.
I don't think you know what the dip correction is and what you're talking about. It's not even dip correction called.
It erases the area that's below your horizontal plane to the horizon. That's what dip correction does.
Nah, it just lowers. It's another angle you need to deduct from, because you already have the tangent to the horizon. We just need to work out the rest. There's a triangle above your horizontal, and there's another triangle beneath your horizontal. That triangle beneath your horizontal is happening because of your height above the horizontal. The same horizontal.
No, your dip correction gets rid of everything below eye level.
Below eye level.
Yeah. That's your observation point. That's why you use your eye level for your dip correction.
What level? Okay, so let's see. What's level?
It's perpendicular to zenith.
Perpendicular to zenith. So if I want to level something, I need to have a zenith? So if I want to level something, I need to have a zenith? Do I need to have a zenith in order to level something?
No, if you wanted to level your kitchen table or something, you would use a spirit level. But if you wanted to get representative of a horizontal plane beyond your immediate position, you would need to take a vertical angle, and then 90 degrees from that to be your horizontal.
Oh, I see. Yeah. Of course, the horizontal plane is required for your zenith to be at 90 degrees. Yeah, of course. Not a sphere, though.
And because the horizon is below eye level, you have to take that into consideration when doing navigation. You got to get rid of that area below that horizontal plane to get an accurate angle from vertical.
Yeah, your horizontal is not at 90 degrees yet. Yeah, you want your horizontal, your tangent, that goes from you to the GP of the star, you want that tangent to be corrected. You want that to be corrected to a 90-degree angle.
No, that's not your angle. Your angle from you to the
that's your
GP is
angle.
not important.
No,
And only the
it
distance
is
from you to
important.
the GP is important.
No, it's important because you're going to deduct the 90 degrees of the GP from your angle.
So there's a point of contention. There's a point of contention. Okay, so we could get that straightened out. Maybe we could make progress.
Yeah, you need to have that co-altitude angle, isn't it?
Yeah, the co-altitude angle is exactly, which is the angle from your vertical. What you're trying to figure out is the angle from your zenith.
Not my vertical.
To the star.
No,
yeah,
no,
yeah, that's the one you use. Yeah.
It's on the other side. It's the opposite.
No.
Yeah, it's on the opposite
that's not
side.
The 90 at the GP is not important.
No, that's the zenith, you know. The
the zenith of the GP.
The GP.
You know,
the GP.
Okay.
The GP is where the GP is where the 90 degrees happen, you know.
Now, George, you could look at any example of celestial navigation, and they'll tell you that the angle is from your zenith, not the GP zenith, but it's from your zenith.
Your zenith is what you're trying to find out, your position.
George won't read any celestial navigation manual.
Your zenith
really goes to how he thinks it works, how he thinks it works, and stick to that.
It's not how I think it works. You're trying to find your position. You're trying to find your zenith. On
I know how to do
system,
that, George.
You're trying to find your zenith. Yeah. So you're not measuring from your zenith. You're trying to find it. So the angle is from the 90 degree, at the GP.
No. Why did you say GP for? If you're trying to find your zenith, what does the zenith of the GP have to do with that?
Well, you need to find the distance to that GP, how far away you are from that GP. That's why you do your elevation angle to deduct the 90 degree angle, the depression angle from, to give you a distance. Once you have that distance, that's a distance between you and it, your zenith and that zenith. Yeah, you need to have 90 degrees on both sides. You need to have those lines perpendicular to each other. Now, once that you do that, you grab your compass and you draw a circle around the GP, and that is a circle of equal altitude. Point is, we're already here, and every single step requires a flat plane to do it, not a sphere.
So then you once you find your co-altitude angle, then what do?
Then what do I do? Then it gives me the distance to the GP.
Yeah, you multiply that by 60 miles, 60 nautical miles, and that'll give you a distance to the GP. So there's another problem in that relationship with the angular, the angular height of the star, the 1 degree per 60 nautical miles.
Why?
That doesn't work on a flat surface.
You just said that it's an angle, isn't it?
It's an angle, yeah.
So it's still an angle above the horizontal plane.
What do they call that, Bacon, on a flat surface, that change over the flat surface?
The relationship between the angle and distance?
Plane.
Yes.
The angle, but the angle is still above the flat plane, isn't it?
Is it the?
It appears like the angle to the light in the sky has dropped or increased, depending of your movement on the plane.
Well, on a sphere, it's a linear relationship, but on a flat surface, it's a what?
Even if you stop, because if you're trying to do the angle, you can do it in movement. It's better if you stop, isn't it? It's more accurate. Okay, it's the stars that are meant to be moving, not you.
Yeah. Here we get to these dead ends in these arguments. What I would like to see, George, I would like to see Nathan or QE or 10th man. 10th man brought the argument to the table.
Or anyone.
I would like to see him. Yeah, anyone. I would like to see, say, 10th man in particular, demonstrate this on a map.
Why don't you guys do it, man? Why don't you
No,
show us
I did
how
it.
you do it?
We do it.
You
I
done
did
it?
it.
Yeah, no.
Yeah, Bacon has done it.
Take us to.
I can do it
Take
right
us
now,
through the
George.
steps. Take us to the steps. Grab
I
the
can do it
sextant
right now,
and
George.
grab the sextant. Let's do it now. Let's grab the sextant and do the step 1.
No, it's too cold. I'm not gonna make it ready now.
Oh, it's too cold. Because what's
Yeah.
going to be the step 1?
Read the elevation angles. Actually, you don't read the elevation angles. We read the SH, which is the height of sextant, which only becomes an elevation angle after you remove the index error and the dip, and you make the correction.
Becky. Welcome to Finder once again.
Who didn't see that coming?
God. Well, you just said that these elevation angles, isn't it? Elevation from what? What is an elevation angle again? I forgot. You told me yesterday.
It's an
What is
angle.
it again?
It's an angle above horizontal.
Or above a horizontal plane, yeah?
Yeah,
How many horizontal planes does the sphere have?
infinite. How many lines intersect a point, George? How many points do a circle have?
Oh man, you guys are so funny.
You gotta see a horizontal plane and then imagine the ball. That's the fucking problem.
Well, that's the only way it works, electric.
Yeah, they have a tangent to a horizontal.
The only way the heliocentric model works is imagination. Copy.
No,
Yeah.
that's not what it. The only way celestial navigation works is by doing it on a sphere.
Mhm.
No, but first you need to assume a plane, correct?
Sorry?
First you need to assume a plane.
Yeah, I just have to point out, like, when he was making his point, he literally wanted me to imagine this. Okay?
Yeah, but first
Well,
you need
this
to
is
assume
how
a plane,
arguments work.
no?
You
Hold on
want
a
the
second,
other
Beck.
person to understand your point, so you must make
Yeah.
them imagine what you're picturing.
Before you bring
What's
your
the problem
sphere
with
into
that?
this, you need to assume, before you bring your sphere into the equation, you need to assume a plane, correct? For your elevation
No.
angles.
Mm-mm.
What do you mean assume a plane?
You have to. You just said elevation
What do
angle
you
is an angle above
assume
a
a plane?
horizontal plane.
Yeah, I am using a horizontal plane. Yeah, not assuming that's the Earth
So,
though.
what do you mean it's not the Earth?
I'm not
You measure
assuming
the
that
angle from
horizontal
what?
plane to be the.
So you
I'm not
measure from what?
I'm measuring from the horizon. I'm not measuring from that horizontal.
You measure from the horizon.
Yeah.
Are you on the horizon?
No.
What do
But I
you mean
can
measure
point to
from
it.
the horizon?
Because I can point
you
to it.
point at the horizon. So you have
Yeah.
an angle between you and the horizon and the celestial
No.
body, correct?
Yeah.
Yeah.
Yeah,
So
none of those are the
that,
horizontal plane.
listen, that
Right?
angle, that
No,
angle, it's an
George,
angle.
George, stop right there.
Yes.
Stop right there. Is
Yeah.
either of those the horizontal plane?
You are aiming at a horizontal plane.
No, I said I was aiming to the horizon. Right?
Yeah, that's a horizontal plane.
No, if it was a horizontal plane, I would not
So
do deep
the
correction,
horizon is
George.
not a horizontal plane.
No,
So what's the horizon? What's the horizon?
it's where the ground seems to meet the sky,
Okay.
and it drops from
And
horizontal as at a known rate. So I can account for that, and then
where
have
does
an
it
angle
say
from
that?
horizontal.
Where
Sorry?
does it say that in the definition of the horizon?
It doesn't say the definition of the horizon. It says in
Oh, it
deep
doesn't
correction.
say it drops it.
No, it just
doesn't
says
say
what it
celestial
is.
navigation.
It just
Celestial
says what it
navigation
is.
doesn't say deep correction. It says height of eye correction.
Those terms are used interchangeably in celestial
No,
navigation.
it's height of eye correction. If you are in the water, there is no correction to be made. Yeah.
High of eye correction
Your
and deep correction are
tangent
used
line,
interchangeably.
your tangent line still needs to go from you to the GP and to meet the zenith line at the GP at the 90-degree angle. For you to deduct from your angle reading from the 90 degree to give you a distance for your radius, in order for you to draw your circles.
Why are you changing the subject, George?
I'm not changing the subject. I'm just telling
you're
you
trying
the
to explain how you
procedure of it.
understand celestial navigation. That's not even what we're talking about.
What do you mean, man? You're going
We're
against
talking about
celestial navigation like no one is using these things, you know? Like people don't know. This is something new.
George. All we need to have an elevation angle. is
It's a
what we call
horizontal
the
plane.
height of the section, which is the HS. I'm sorry,
A horizontal plane.
no, you
You
don't
need to
have a
establish
horizontal
a
plane.
horizontal plane first in order.
What's the name of the
before
angle you measure? What's the name of the angle you measure? Tell
For
me.
you to
What's
measure
the
the angle, listen.
what's
For
the
you to
name of the
measure
angle you
the
measure
angle,
with a sextant?
a right angle.
No, what's the name of the angle you measure with a sextant?
It's an elevation angle.
No, that's wrong.
Yeah, it's an elevation angle.
No.
It's a right angle. Yeah, it's a right angle triangle.
No,
you
it's
know?
called sextant altitude. That's the angle you measure with the sextant. That's not an elevation angle. It
it's
is
an
only an
elevation
elevation
yeah.
angle. It's only an elevation angle. Once you correct for dip and index error, then it becomes an elevation angle. You don't measure an elevation angle. You measure the sextant altitude, and then
If
you
you
get
are
an
in the
elevation angle
water,
out
you
of
don't
that.
have to do any correction. If you are in the water, you don't need to do any correction.
No, you still have to correct for index error. You're still
No,
not
you
measuring.
don't. And if you are in the submarine, you don't need to do it either.
What's the
It's
index error,
measured from
George?
sea level already.
What is index
Yeah.
error, George?
What?
What is index error?
Index error. There is nothing to correct if you are at sea level already, man. There is
What
nothing to
is
correct.
index error, George?
It has nothing to do with this. If you can observe the celestial body, yeah, you know the GP because
George.
the GP is on the almanac. The
What is index error,
error
George?
it's not applicable if the observation is above 15 degrees. Yeah, between
What is
15
it,
degrees
George?
and 90 degrees, there is no index error.
George, stop monologuing. Answer me the question. What is index error?
That is refraction, but that
No.
is on lower angles.
Yeah, it isn't refraction, George. That's not what index error is. George, you gotta learn the stuff you're talking about before you talk about it. You
So
can't
what's
just.
index error?
It's the error of your instrument.
I was
Say again?
going to say, is it
The error
had to
of
do
the
with the
instrument.
instrument?
Exactly.
Yeah.
It's the error of your instrument. So, for example, if you align both sides of the sextant and that doesn't give you a 0, it gives you, let's say, 10 arc minutes, that's your index error. It's 10 arc minutes off.
Yeah, but you calibrate it before you do
So
the
you
shooting,
have to remove the index error, regardless
Yeah,
of
you
if you're
calibrate it
taking
before
it.
you do the shooting.
No, calibration can't
You have to
eliminate all. No. Calibration doesn't always eliminate all the index error.
Regardless of that, man, the angle is achieved, yeah, and to be achieved, you need a flat plane to do it.
Right. Well,
Let's not
you
dance
said.
around the subject, man. Let's
Well,
not
you said
put
when you're.
flowers around it. For you to achieve the elevation angle, the elevation is above horizontal plane. It's getting late for me. I'm talking too loud.
Yes. Stop. Yeah. So I when I mentioned that you have to remove the index error to get the elevation angle, you said you don't if you're at sea level. It has nothing to do with your level. You have to remove index error anyway. Doesn't matter. Doesn't matter if you're at sea level or higher. The index error is just always gonna be there. That's why I was telling you
to
what.
calibrate it, yeah.
Of course, you need to calibrate it, but the calibration
Yeah.
doesn't always remove index error, George.
Man, when you do the reading, that's the part that you deviating and you're dancing around, yeah?
Don't
The
dance
angle,
around.
it's only achievable from a horizontal plane.
Why? First of all, it's not
Because it's an elevation angle.
Yeah, but we don't have the horizontal plane when you're measuring it.
Yes, we do. We are on it. The plane where the observer is on.
What is the HS?
Elevation. Elevation, yeah. Elevation angle from the plane that the observer is standing on.
What is the HS?
It doesn't matter what it is, man. Why are you dancing
Yes.
around why are you avoiding the problem, man? You need to have a tangent line between you and the GP of the star that you're observing, which you get the GP
I
from
said
the
that
almanac.
10 times, George.
Yeah, you get it from the almanac. Yeah, that tangent
This
line.
shit ain't
Yeah,
that complicated. Y'all are going on and on. This is not complicated.
yeah.
I agree. But if you don't
So
know the
stop.
basics,
So stop trying to disprove. Oh God.
what?
Why are you still saying that this is achievable from a curved surface, man? It's not.
We're not measuring an angle from a horizontal line, George.
I don't understand. Let's say it's flat. All right, we got our baseline, our flat horizontal line. Then let's just say, okay, the Earth is a globe. You're taking an angle from the horizon to the star, right? Is that the angle you're getting?
Yeah. Let's see.
Why can't you do that on a globe? I feel like you'd definitely be able to do that on a globe. Get an angle from the horizon to a star. Why couldn't you?
You cannot, man. You need a flat
I don't see
baseline
why
to
not.
have a. You need to have you understand a protractor, how it works, yeah? You have like half a moon.
Yeah. Protractors, definitely.
Yeah, you have like a half moon, yeah. And one of the sides is a straight line, yeah. That's a zero line. In the middle, yeah, you have the 90 degree, yeah, and you have many degrees between the 0 and the 90 degree. If you continue on from the 90, you go to 180. But if you start on 0 on both ends, both ends are going to end up on the same point, which is the 90 degree. Now imagine you have the sun, for example, yeah, exactly above your head. So it's at the 90 degree position. And anywhere the sun moves, either to the right or to the left, that angle of elevation is going to change. So from 90, going to go to 89, 88. As the sun goes away, the elevation angle decreases, to the point that it will never reach 0. It will disappear somehow in the horizon.
And the elevation angle, just to be clear, the elevation angle is the angle between the horizon and the sun, right?
It's, in this case, yes.
I'm asking. I don't know.
No.
Yes. In this case, is yes.
No.
The elevation angle is an angle above a horizontal plane. The horizontal plane needs to be established first.
Yeah, the angle you measure between the horizon and the celestial body, it's the HS, it's the sextant altitude. It's not an elevation angle yet.
The protractor, on the other hand, it doesn't work on the surface of a sphere. It needs to have that 0 line, needs to be the level line, which is what we call the C, isn't it? The 0 line. Above C, below C. So C is the 0.
So it's impossible for this to work on a globe, you're saying?
Correct. And we measure, for example, heights of anything, heights of hills, peaks, mountains, from sea level. So anything above that horizontal plane. And it's measured with elevation angles, the same method. It's easier because, you measure into something that
let's
it's
get to the bottom
on the
of this. No, let's get to the bottom of this. Bacon, do you take an elevation angle for this sextant measurement?
Yeah, we don't actually take the elevation angle. We calculate the elevation angle. The angle we measure, we call it sextant altitude, and then we subtract the dip, which might not be perfectly accurate. It's just a good estimate on how much the horizon is.
So you
dropping
don't do an elevation angle.
It's corrupting the system, man.
Not directly.
So what's the sextant for then?
To get the sextant altitude, which is used to get an elevation angle.
What's the sextant again? What's that instrument for?
Wait,
yeah.
Are you getting an elevation angle or no? I don't understand.
Yes, just not directly.
He's denying, man. He's denying. He's trolling you, man.
How am I trolling you?
Because you're not spewing the right thing, man. That's not what you were saying a minute ago, is it?
Just Google it, George. It's in the menu.
Oh, just Google it. Oh, man. You cannot use Google as a reference.
I'm going to just say this, guys. I've understood everything George said. So I'm kind of like not the super smartest guy in this field. Why am I comprehending what he's saying? And you're not. Like, I don't get that.
I am. I'm addressing as
He's
well.
saying he's just saying Bacon's saying that he's wrong, and you don't measure an elevation angle.
Not directly. I didn't say you don't.
What does
measure
that
at all.
mean?
When you say
Go,
elevation
explain.
angle, hold on. When you say elevation angle, are you talking about the height of your line of sight or the height of the object that you're observing? What are you talking about?
I'm talking about an angle
Height
above
from what?
horizontal.
Yeah, what is the height? The
There you
height of
go.
your eyeball or the height of the object?
It didn't say height.
You're talking
Said
about
the
an
angle.
elevation angle.
Yeah, it's an angle above horizontal. It didn't say height.
There you go, man.
Okay,
Horizontal.
yeah, okay. The horizontal plane then is the elevation.
No,
Yeah, correct. It's agreeing. He's agreeing with that. Now he says no.
horizontal
Now
plane
it's
is a
changing his
horizontal
mind.
plane. It's not. It has nothing to do with the elevation. It's not the elevation angle. The elevation angle is the angle above that plane.
Oh, Bacon, man. It's
It's
late,
not
man,
the
and you're
elevation
tired.
of the plane. That is not what the elevation
Which one
angle
is it, Bacon? Which one is it?
Which one is what?
So is the elevation angle above the horizontal plane or not? Because you're saying two different
Yep.
things.
No,
So it is then.
I didn't say different things.
So it is above a horizontal plane then.
Yes.
Okay, so ask a question again. Let's go.
So we do measure an elevation angle with a sextant. Yes.
Indirectly, yes.
What do you mean indirectly?
Yeah, what does that mean?
Right. So when you measure an angle from horizon to the celestial body, when you're pointing to the horizon, that direction isn't necessarily horizontal. So the angle you're reading isn't necessarily horizontal, an elevation angle, because the baseline might not be horizontal. So
Okay, so how do you indirectly get it then?
right. So
It doesn't make
you
sense what you
estimate
say,
how
man.
much that line is below horizontal, and then you subtract that. Now you have an
So you're
elevation
getting
angle.
an elevation.
Hold on a second.
So
Bacon,
you are
Bacon, hold on.
measuring an elevation angle essentially. You're
Yeah.
just subtracting the dip.
Exactly. So
What the fuck, bro? What?
Yeah, before I subtract the dip, that is
Yes,
not an elevation angle.
So yes,
Yeah, but
elevation angle.
Yeah, but that's a problem, because if I just say yes and you pick that as the angle you're measuring is the elevation angle, that would be wrong. That would imply that the baseline is a horizontal plane, which it isn't. That's why I'm being specific with my answer. Do you understand that?
So you have an
Did that make
elevation
sense?
angle which you define. So you define an
I
elevation
want to
angle
know
as
if
being the angle.
I want to know if my answer
You
was
define
followed.
Bacon. You're saying
And I
that
want to speak to the walls, George.
elevation angle is an angle above horizontal plane, but then you say you don't need the horizontal plane to do the angle reading. Are you kidding me?
It's not that I don't need. I don't have one. I have the
What do you mean you
horizon.
don't have? You just said it's required for this elevation angle.
I didn't say
And you are
it's
doing the
required.
elevation angle.
I say
You
say it's.
okay? What's the definition again of elevation angle?
I already answered that like 5 times, George.
What
Just
did
move
Okay,
on.
real quick. Hold on, George. Real quick. What do you do when you can't see the horizon?
That's a good question. I don't know.
I do know. You don't know?
You don't do it.
You don't know what
No.
they do when you don't?
I think they try to like I think Kool-Aid said it once that you can just try to guess where horizontal is, but it's a very bad, very less accurate than if you could see it. Obviously, it's just it's the only thing you have.
It depends which instrument you're using.
Is that what you were gonna say?
Yeah,
you
you get a
use
horizontal. Yeah, so you get a horizontal, and then you take your angle to the star from that, right?
Yeah.
It's just
you-
like just guess. You're
Shit
just guessing
sound-
where the horizontal is. Yeah.
You're
If
guessing
using
where
the
they don't have any tools to see where horizontal is.
If you're on a boat, I don't know. I don't know of any.
They need to start.
Well,
let's
so
say,
you get a horizontal. Hold on, George. One more second. I'm sorry. One more second. So you're getting a horizontal, and then you're taking the angle to the star, right? That's it sounds like an elevation angle.
Yeah, if you're based on a horizontal, yeah, that would be an elevation angle.
So they're directly measuring elevation angles sometimes.
Assuming a horizontal is actually horizontal, sure.
There you go, George. Now, why can't we have a? Why can't we do this on a globe?
Hold on. No, go ahead. But seriously, can I say something? You have to assume that the horizon is actually horizontal to use a sets. Is that right?
No, no one does that. That's why deep correction exists.
Okay. We got our sextant. We can't see the horizon.
Oh, that's not
We
correct.
just made an elevation angle.
I was
Now
far
what,
away
George?
from my button.
Oh
Now,
God, George! I just got him to admit that he's taking an elevation angle. Now what?
Yeah, I would like to point out, depending on the instrument that we're using. I just posted that in the chat, the astrolabe, for example. You hold the astrolabe on a piece of string, so you are doing the 90 degree of your zenith to the horizontal. So
Listen,
you already
George, I just got him to admit that sometimes we make an elevation angle. Now tell us why we can't have this elevation angle if it's a globe.
You cannot have elevation angles from a globe.
Why?
He just said the elevation angle, it needs to be from a horizontal plane. That's the definition of it. If the required for the elevation angle is a horizontal plane, you cannot come and say we don't use one, because it's a requirement. It's the antecedent.
I mean, you can make a horizontal line.
Yeah, they just make up a line. They just make up an imaginary line. Well, they think it's imaginary, but
you need to use a protractor, man, to measure the angle. This is geometry.
We should all assume.
I mean, they're still using
the horizontal line that is the horizon. Assume that it's imaginary. That's what we need to do, guys.
Well, they're actually just using a horizontal. The part they're assuming is the curved sphere. They're using the actual horizontal.
That's correct. They have a tangent line
to find your position.
They have a tangent line to a horizontal line. So a straight line to another straight line. That is if they don't invoke refraction, because if they invoke refraction, then they don't have straight lines anymore. That makes even more difficult the geometry.
Yeah, but the refraction correction is there. Even if you're on flat surface, you're still correcting for refraction.
But the refraction for celestial navigation is within 0 and 15 degrees only. If you're above 15 degrees,
not true, George.
If it's above 15 degrees, you have more accurate readings. But
yeah,
again,
it's still there. It's just less significant.
If you're doing this during the day and you're using the sun, because it's going to be the only light in the sky you're going to see during the day, or the moon, for that matter. But if you're using the sun, which is what they normally use, it needs to be visible in order for you to do the elevation angle. And within 10 or 15 minutes apart, your reading is not going to be that different. So there's nothing much to account for. If you can see it, you measure the angle for. Obviously, you need to have good conditions as well, You need to be as still as you can be, On the boat is not easy.
So, George, from your perspective, if the Earth was a sphere, could you use a sextant to navigate upon it?
No, of course not. Because it tells you at the beginning, they disclose this right at the beginning. Even NASA says the same thing to pilots, anyone who is a navigator, who uses, navigation systems, maps, and so on. They need to account the Earth to be flat and stationary for these things to work. You need to travel from point A to point B. You cannot travel to point B and reach A. It doesn't exist, something like that,
Right, but I wasn't really talking about the idea of this place being a sphere. I'm just saying if you were on a sphere of land, could you use a sextant to navigate?
No, you could. It's elevation angles, isn't it? the problem. The definition, the requirement for the elevation angle is the flat plane.
I still don't get it. You make an imaginary flat plane out to the horizontally, right? You make this horizontal plane, and then you take a angle to the star. So then what? I don't see why that couldn't happen on a globe.
Yeah, it could. It can.
Yeah.
Doesn't mean the Earth's a sphere. It just means you could use a sextant to navigate celestially if it was a sphere.
It needed to be a globe big enough. Listen, it needs to be a globe big enough for you to have a straight line from you to the GP, whatever thousands of miles away can be from you. A straight line for you to have an elevation angle from at the 90 degree.
You don't have to see the GP, George.
You have to, yeah.
No, the angle is above.
The elevation angle is from the horizontal that they're creating. It's not from the curve. It's not from the curve of the Earth.
Correct. But it's from the surface of the Earth, though. It's from the surface of the Earth.
And it's not from the line between you and the GP.
Listen, if you are on the water, there is no deep correction to be made. The angle is still the same because you are on the water, you are on the level plane. So it's all level from you to the GP. And you have an elevation from it. And that elevation angle, you're going to have to deduct from the 90 degree, the same 90 degree that you deny, yeah, in order to give you a distance between you and the GP. So you'll know how far away that GP is from you. In order for you to pinpoint your location where you are, I'm this X amount of miles from this place. Because that's what you're trying to find out, where you are. The almanac gives you the GPs. If you observe the stars, you know where the GPs are. You just need right angles to them, nothing else. It wouldn't work on the sphere.
I don't know, George.
How you doing, man?
What do you think, Extremis?
George, whatever George says, reality is actually the opposite.
Oh my goodness, Extremis.
If George says something, you can be sure the truth is the opposite of what he says.
Asking Extremis is anything is a waste of time, man. He might actually ask you something, and by the time you answer back, he's deafened himself already.
He's a hard Extremis is the hardcore flat Earth denier. Wait, what do they call it? Not a globe or a
anti-flat earther? Am I an anti-flat earther?
That's it.
He's kind of on the fence, actually.
He's cool though. I don't mind Extremis sometimes.
Yeah, he just shoots himself in the foot every now and again.
Jace went off the deep end, man. He got gangster on us. He's been getting gangster on us lately.
I think he spends enough time at a server that is rather toxic, and so he's just kind of built into his personality now.
Fucking Jace Hood.
It's like you are what you eat. Well, you also are who you hang out with and what you do in your life.
Fade NASA showing house. He came in here, got everyone stirred up yesterday. They're trying to say, listen to this. They were trying to say a plane to the shape. Right, what do you think about that?
Yeah.
Which shape? Plane shape?
Yeah, which plane? Which shape is a plane? Good question.
I don't know. I don't think it is because I mean a plane extends. You know, according to geometry, a plane extends indefinitely. So how do you have a shape out of something that just Where do you see? You can't even see the end of it. How would you even know?
Yeah, it's like they were conflating that with a planar shape, like a square that is planar.
Yeah. Oh, you heard that? Yeah, yeah. Like, yeah, you can have a circle on a plane. On a plane, you know, a square is in a plane or on a plane, or however you want to phrase that. But the plane itself,
the pizza model, isn't it?
what's it? Yeah, we never make. I mean, I don't think I've ever heard anyone make a shape plane. Maybe some people might say it's. I don't know.
Well, I've talked about a planisphere where you have a plane within a sphere.
Yeah.
Yeah, that's actually the model. That's the celestial sphere. That's a plane in the center of a sphere. Yeah, that's the model with elevation angles. Yeah, and you have different rings, which is different dials.
Wow, so we're both. So everybody's right.
Yeah, armillary sphere. You guys need to do.
And some people do talk about like the four corners of the earth, like a square structure, or also like a circle.
Yeah, rarely though. Rarely I hear people talk about it.
Yeah, north, south, east, and west.
A circle within a sphere, or a plane within a sphere, and then a circle within a square.
But that's the thing. They don't have a sphere. They have circles on the plane. They don't have sphere. They have radius for the circles. They don't have sphere.
I feel like one day they're going to come out and tell everybody, sorry, it's not a sphere. It's actually interdimensional donut.
Well, I guess they like the sphere because they think it can form itself. When you're thinking about something flat, you're thinking about something pressing against something else. That normally goes all the way back to a hand, like the hand of the creator pressing and forming the earth.
Actually, it's pear shaped.
It's either self-forming or it's formed and pressed by something else. And normally when something's pressed by something else, you think of a planar sort of layout.
Due to the manifestation of the electrical universe and the unicorn part.
I think the electrical universe got some merit to it. I don't know. Grim be coming in with this wacky shit all the time, talking about plasma can contain gas pressure. You guys ever see that?
Oh, you're gonna need at least 3 containers to contain gas for a demonstration.
I think anytime you're talking about whatever the force is, be it electrical, gravity, or whatever unifying force you're trying to invoke to make everything, you reach a real crossroads when you have to ask yourself, okay, did the electricity form itself, or did something else channel the force and use it as a tool or as a means to an end? I think that's what you get with even the electric universe. They're trying to get these electrical fields to just happen and fluctuate, as opposed to having them be channeled by the creator or formed by something else. So I think you get into La La Land when you have to have the force be self-sustaining with nothing else to appeal to.
Yeah, the problem is when they come with demonstrations, for no container in a vacuum chamber. So a vacuum chamber is not a container.
Real quick, is the air coming as off near your skin, right? There's air near your skin. Is that more dense or less dense than the other air?
I guess more, since it's under pressure.
And if you fart, what happens? Is it less dense or more dense?
It depends on whether you take the pressure that's in your body as part of the calculation of what's going on in the room.
I would say it's less dense. That's why you
No,
smell
outside. Outside my body, not inside. Is the air just like near my thumb? Like, would that be like more dense or less?
If it's not part of the calculation, then it would be more dense, yes. But if the pressure inside of your body is calculated for what's going on in the room itself as well, then it's just moving one thing to another place from inside to outside the body, but no real change. It would be like isometric or isotropic or whatever.
Because I got your icon right above Bob Dole's, and I can make the black part by putting my thumb in between, like right under your thing. I can make the black part stretch into his icon. Can you guys do that?
This format's very frustrating because like the last two people get covered over by the volume controls.
Jeremy, quit squishing me, it hurts.
I'm squishing Bob right now, like I'm squishing the shit out of him. Because if you put your thumb in between your eye and right under Lemon's thing, you can make the black part. Like, am I the only one that can do that, or can you guys do that too?
Black Swan, Black Swan, Black Swan. I don't like this format for the phone because the last two names get covered over by the volume controls. It's very annoying.
Maybe not.
But even if we do go electric universe, it would make a whole lot more sense if we had a dome or some sort of structure to help channel and form the electromagnetic fields. I think we get a tall order of possible, nonsense when we try to have the electrical field Z pinch and just form itself by some sort of random fluctuation.
I don't know. Grim was talking that shit like you could have a plasmoid or something, or plasma contain the gas pressure.
Maybe. But he is a little atheistic in his focus. So
how do you have plasma without the container?
Well, a dome or a firmament or anything like that just smacks of too much, Bible or whatever, theist or not. So he's not going to go with that sort of stuff with his atheistic bent. He's going to go for something that's a different cosmology, a different principle for how everything was formed.
We're still forgetting that a container is required for the sky to be a vacuum.
Maybe, but it could be a plasma. It could be a plasma container.
Listen, we don't see a container, do we? The sky is not a vacuum, that's for sure. Whatever it is,
the pressure gets lower.
A vacuum is not.
Well, the things that make me comfortable invoking a container are meteorites. They look like chips off of something that's falling from above. We also have meteorites, which are the same as ringwoodite. According to Southern Israelite, you get these sorts of ringwoodite minerals and meteorites from mineral rock next to water under great pressure. We're finding it below us in the form of ringwoodite and above us in the form of meteorites. So by logical extension, there's a structure above and below juxtaposed next to water under huge amounts of pressure. If that's not, a firmament, I don't know what is, but I'm going to go with it. So based off of that, I'm pretty comfortable invoking a dome.
All right, so now, how do we fit this firmament into a sphere?
I would go with a hemispheric dinner plate over flat land. But who knows? It could be spherical, hemispherical. Who knows? It's kind of hard to believe.
It's funny because you'll break down all these facts and like observations, and then it'll just be like, all right, but how does it work on a sphere?
You can't.
I go with the flat land covered by a dinner plate. I don't feel the need for it to be a sphere.
It's not just about
Listen, I haven't.
Sphere. It's being a sphere with a radius of 3959 miles. This is the problem.
I haven't seen anything that the Globers can't talk their way out of. Have you guys? They literally talk their way out of everything, no matter what.
Globers are just buying time for their elites to react.
You think they're going to do like a reset and then, fix some issues?
They're not going to move unless their elites tell them to. Till then, they'll just stall.
I mean, the elites, think the elites are going to do like a great reset kind of thing? Shut it down.
Either the old paradigm has to go or it has to absorb the new information and try to preserve its globe focus somehow. They'll probably just say it's a simulation or something.
When we talk about the Great Reset, when you say reset, I'm thinking I'm going to wake up one morning and all my money's going to be gone out of my bank account and there's going to be a new world order in place. But to me, we see these changes over time. And, change is going to lead to something. And is it just going to be a gradual...
Listen, are you guys sure that the air... My bad, left lane, go ahead.
No, go ahead. No, I'm just saying, I just don't see the word reset is a good word to use in talking about a change moving towards something.
You know you're going to be out of a job soon, right?
Yeah, that's what I expect.
Is it?
Yeah, on
What are you
a
gonna
great
do?
reset. All my money's going to be
not
gone.
Even a reset. Not even a reset. If we just keep going as per usual, you'd be out of a job in like 5-10 years, right? With the automatic truck, self-autonomous trucking.
Yeah, I don't see in my lifetime an automated truck doing what I do.
What do you unload the stuff or?
Well, I mean, pulling into the dock, loading the truck, pulling out of the dock, transversing 1,700 miles across country, pulling up to a dock. It's just the infrastructure is not there for an automated truck to do that.
As long as the truck driver doesn't have to load or unload the stuff, I mean, totally feasible for that to be done. No.
I could see them loading my truck, I guess, but backing into the dock.
You don't think they can make it autonomous?
It would just about have to be. It'd have to be like on rails or something, You
don't think they could just like GPS it or put some things in the ground under the blacktop or something?
I don't know. Maybe.
I feel like, I don't know. The amount of money they pay truck drivers for, if you have, I mean, let's face it, if you have a computer doing it, they drive 24/7. What do you get? 12 hours? How many hours can you drive a day? 8, 10?
No, I'll drive a minimum 11.
So what's the max? 12?
No, 11's the max, but I'm still on paper logs, so I get to fudge a little bit.
Oh, yeah. So 11 hours. I mean, they get rid of you guys. Now we're driving 24 hours. That's more than double. Right? I mean, you're getting your goods there faster. I mean, this just seems like a no-brainer. They're gonna be pushing for this.
See, that's a whole other thing talking about electric trucks. I think the maximum range on a big truck is like 400 miles, and then an extended period of recharge. I don't know. I don't know.
You will own nothing and you will be unhappy. Yes.
How would you gas a truck up if it was How would you gas a truck up if it was autonomous?
Yeah, that's a good question.
That's a tough one. That's a tough one right there.
It is all about central control, gentlemen. Too much freedom is confining for human nature, and we don't like it because we can't control the cogs in the wheel. You will take your electric cars and you will like it. Let us worry about the ways to plan and control your life. Yes, Klaus Schwab, yes.
Sounds like Biden.
Lemon, are you sure that the air coming off my thumb is more dense?
When we think of density, we think of more stuff per unit area. So if it's confined, the same amount of air confined in less area, people will tend to think of that as more dense, not less. But who knows? Maybe I'm thinking about it wrong.
Because if you put your thumb in between your eyeball and the screen of these squares, you can literally make people's colors jump into another square by putting your thumb. If you get your thumb just right, like I can do it a lot with some of them.
Most of the densest air
forms a
layers, even
pyramid.
in the globe model, are toward the Earth because there's
It forms
more
like
air down there.
The color will form like a pyramid into the other person's color. You know what I'm saying? Kind of. Sometimes it does a reverse. If it goes down, it does a reverse pyramid. If it goes up, it does an actual pyramid shape. Fucking weird. You guys can't do this? Am I a weirdo? Is it could because my eyeball? Close one eye. Close one eye and try it. That might be throwing you guys off. The 2 eyeball thing.
I think they're saying now neutrinos do slightly interact with matter. And when it goes through a watery surface like your eyeball or whatever, it does a flash before it keeps going or something. Maybe this image of color that you're talking about is formed in the eye or something, like a neutrino slowing down or something. Who knows? It's interesting to go back to some of the stuff from the other centuries when they were saying, how does the eye see stuff? There's perception in the eye, in the world, in the mind, a little bit of both, a little bit of neither. Especially when you're looking up at these stars. Are these stars actual images, effigies off the dome, made in the mind? Is that why when you get up higher, it's black and there's no star up there sometimes? Who knows?
Now, wouldn't the air be warmer that's coming off my finger? I mean, my internal body temperature is 98 degrees, right? You guys hear me?
Mm-hmm.
I hear you,
Yeah,
bro.
so the air coming off my thumb should be hotter. Hot air is what? Less dense, right? I don't know. I don't think they got this bending light thing exactly correct.
I gotta be honest, Jeremy. I haven't been able to tell if you're a flat earther or a globe earther yet.
I'm a soldier in the war on nonsense.
So that makes sense.
Don't matter what side you're on.
Well, why don't you tell me what you think it is?
I'm a realist. I think the Earth is flat personally.
Okay. I never would have
There's a
assumed
high
that, by the
chance.
way.
High
I
chance.
really, yeah. I never would have assumed that, so keep that shit up, bro.
Oh, you ain't been around, bro. I've been killing them for years. I got graveyards.
Jeremy's a top 3 flat earther.
Top 10 at least. Now, there's some good motherfuckers out there, but I do what I can do.
Yeah.
Feel you, bro.
Yeah, I'd say on hanging on a point and milking it down to the end of the argument, I think Jeremy's probably one of the better.
You might as well just stay right on it. We've been doing this shit for years. Like, let's get down to the bottom of something once in a while.
Yeah, it's a rough business out there trying to keep a glober focus on the topic at hand rather than throwing out crap to try and shift you to something else.
Yeah, when I
Expect from someone that thinks they're flying around at 1,000 miles an hour.
I'm all fucked up on this time dilation thing. Yesterday, Rumpus was telling me the clock's going to swing faster at the top of the Eiffel Tower. Today, they're telling me it's slower because of gravity. Like, I don't know what to even think anymore. They got scared when I started talking about what's the force making the clock swing faster. If you're just looking at it, you know, if you're a mile out from the Eiffel Tower and you're looking at both the clocks on the top and the bottom, I could see them both. One's swinging faster. You got to have a force for that, right?
Doesn't it slow down with altitude?
Yeah, that's what they were saying. You know, Rumpus was telling me yesterday it was going to be faster at the top. I don't know.
Yeah, Jeremy, let me ask you a question then.
What's up?
What do you think is the most difficult thing to argue that is like kind of like a prevailing point that Glober's making?
For me personally, the sextant.
Oh,
maybe.
shit.
I never really got into the sextant argument.
Wow. Yeah, that's what they're just talking about for like 2 hours, right?
I know. Yeah, no. No, they go deep on that shit for days. I mean, I've heard a lot about it and shit, but I still know. I don't know.
I mean, until you take a sextant like 200,000 feet into the air, and how are you supposed to know how far the horizon is, right?
It's actually not. I probably could find an argument against it because I mean, yeah, these things might make it look like it's a globe, but is that if the stars and all the shit, the horizon, the stars, all this stuff, if that's the actual position, get out of there, Kitty. If that stuff is the actual position of the things, and they got the distances right, there's a lot of ifs, right? You know what I mean? They have to be the actual positions, and they have to get the distances right in between the GPs, your position and the GP and shit. But if everything they say is right, it's probably a globe. I don't know. They can't prove anything about anything I just said, though, about the distances or the actual positions of these, celestial bodies or whatever. So
I hear you.
there's really no argument that I would think I don't know.
I just don't see how a sextant proves any curve. What are they observing? They observe a curve?
It's not the sextant. It's the fact that when you're trying to figure out your position, you have to treat the Earth as a sphere. There's simply no other way to do it so far that anyone have demonstrated. That's why I think it's a strong point towards the globe. Even if we can't demonstrate all the assumptions, that's still the only way we can do it. That no one's offering any different way that is doable.
But we agree there's assumptions built into it that can't be proven one way or the other, right? Yeah.
I'm not sure if they can't be proven, but yeah, I wouldn't say I have proof of that.
I mean, could you prove the actual position of a star from my observer point?
But that's what I'm telling you. I'm not saying I have proof of those. I'm not sure if it's provable or not.
Nah, that's what I mean. It's not even. Nobody could.
Hey, you got me thinking pretty hard. Now I got a question. How do I even say this? Let me think for a second.
Bacon, what's the argument you think you could get me on?
Close question?
Yeah, we're assuming that we're on a sphere when we use a sextant because we have to make adjustments when we think we've pinpointed the distance of something. We have to say, oh, well, it's wrong because there's a curve. Like, I don't understand how, like, where's the curve being detected when you're using a sextant? I don't get it.
It's how you find your position. So it's not about just getting the angle. Like the angle in celestial navigation, we use the angle as a distance. So, for example, if you measure an angle to a celestial body to be, say, 62 degrees, right? And as let's say that's your elevation angle. So the elevation angle is 62 degrees. That means your zenith angle is 28 degrees, right? Which is the co-altitude. It's just how much you need to add to get 90. That is used as a distance to the GP of the celestial body. And then when you go to an almanac, given the time of your measurement, it tells you on Earth where the GP was when you make the reading. So now it gives you a circle with that distance as a radius, right? So you know you're somewhere on the edge of that circle. Now, if you do it with a different celestial body,
because you're just fitting a radius to the angle.
Yeah, the angle is giving a distance, and you're going to use
that. So you could do the same thing with a square. Fit a square to the angle.
So far, yes.
Okay.
But that's not the whole story.
Right.
Yeah, but that okay. So you do that to a different celestial body, you get a different circle, right? Now those circles are going to intersect. They're going to have common points, and because you have to be in both circles, you can only be at the intersections. So if you put those circles on a sphere, the intersections actually match your coordinates. If you put them anywhere else, they can't match it. You can't work both on a sphere and on a different shape. So when we do it, we do on a sphere, and it's what the method we use that works. Does that make sense to you? Did you understand what I said?
If you're going to determine the distance of something, hold on, let me get out these shitty headphones.
I don't mind repeating myself.
I'll be 100% real with you, bro. I like to think that I understand reality, but these new like aspects that y'all talk about in here, sextants, I'm gonna say it's new to me. Okay, so let me
That's
build
fine.
my foundation with you, right? Let's do that.
Sure.
I want to truly understand. So when I look into a sextant, I'm to believe that it's not actually my line of sight. There's something inside of it that's reflecting my line of sight, and it's making it go farther, right?
I'm not sure what you're talking about, actually.
The sextant allows me to see farther because there's lenses and mirrors or whatever is inside this thing.
No.
So what's making me see farther?
No, you're not seeing further with the sextant. You're just measuring an angle.
I'm just measuring. Okay, so this is not for seeing far distance. This is just for measuring angles.
Exactly.
Okay, that's cool. So that's one assumption that I had incorrect about this thing.
Right.
I mean, when it comes down to it, oh, go ahead, Vic.
Yeah, go on.
No, I was gonna say when it comes down to it, like, they have to have these positions of the celestial bodies that they're aiming at. They would have to be the actual positions, right, which is unprovable, and also they'd have to have all the distances correct, which is also unprovable. Some think you can, some think you can't. I've ran through it with a lot of them, and
yeah, that was going to be my next question. How do you when you're saying you're making celestial navigation and you look at a star with a sextant, like if you don't know the distance between you and the star, how is that star helping you navigate?
No, not the distance. Not the distance from you to the star. The distance that they have in the books from you to the GP or whatever. What are the distances in the books, Bacon?
Oh, so we have to literally refer to an index for measurements to determine these angles.
Bacon, are there distances in the almanac?
No.
So there's literally like a glossary of measurements that I have to refer to when using a sextant?
No. The almanac gives you the latitude and longitude of the GPs, and it helps you calculate the distances using side reduction tables.
So they'd have to say that the distances were correct between the longitude and latitude points at that.
Yeah.
Yeah.
So no matter what, you're referencing a measurement that was previously made.
Those are the distances that they would have to be able to prove.
Yeah, the position of the GPs can be empirically verified. Like you can do it as well. Anyone can do it. I don't think that's very much disputed.
Yeah, no, we can go to them, but getting the distance from one GP to another GP is not verifiable. Yeah, that's not verifiable.
Well, I'm not sure if it's impossible to verify. I just wouldn't claim I have verified them, or it's easy to verify them.
You want to run through it? I'm busy right now.
No, I haven't verified them, and I don't think it would be easy to verify them. Not too easy, at least. But I wouldn't say it's impossible to verify them.
I got to mute up for like 5 minutes, but I'm listening, guys.
Okay, so we reference a book to know where the GPs are at the moment we are making the readings. This is the provable part of it. This is the verifiable part of it. And then what is not that easy to verify is how far you are from the GP. We on Celestial Navigation assume that that distance is directly proportional to your zenith angle to that celestial body. That's why we turn the zenith angle into distance. And if you do that, you actually can figure out your location on Earth very accurately. So because that works, then I think that's a good evidence for the assumptions that we're taking.
That would just change the side of the radius. That would change the size of the radius, not the positions of it.
What do you mean?
Like, you're just assuming that things are super duper far away. It doesn't mean anything. You calculate the distance, bro. Okay, no, you know, I'm gonna just.
Right. So we're not using the distance to the celestial body. Do you know what the GP is? You understand what that means?
Ground positioning.
Yes. So like we understand what's the GP of a star, for example. If I ask you, what does it mean for a person to be at the GP of the moon? What does that mean?
It means that 90 degrees above their head would be the moon.
Oh, your mic's very, very bad now.
It means that 90 degrees above their head will be the moon.
Yeah, exactly above their heads. 90 degrees
So the
from
ground
the horizon.
positioning. Okay, I got it. I caught that.
Right.
Thanks for that.
All right. Yeah. So with the almanac, it tells you what's the ground position of any celestial body at any given time. Right. And the distance is your calculator.
Wait a second. You wouldn't need the distance of the stars at all. You would just need to know where on. You would just need to know where on the plane you would be standing for something to be directly above your head.
Exactly.
So that's got nothing to do with accurately measuring the distance of the stars.
Exactly.
So why are we calling something celestial navigation?
Because we're using the celestial bodies to navigate.
Technically, you're using the positions that you determine based on the stars, not the actual stars' positions.
Yeah, I'm still looking to the sky when I'm doing so. That's why we call celestial.
All of this is based on the horizon, the horizontal plane, your line of sight, and the positions of things that your sextant is looking at. And the stars are kind of just like, you know, you don't need to know anything about them. They're just a reference point.
Yeah, they're treated as very far. So we treat them as not having parallax.
But they don't need to be treated as very far. Because their position, no matter how far away they are, is always going to be in accordance to the ground positioning you made for it. That doesn't mean it's very far. It just means that whatever ground position you found with the star directly above you, yeah, it's going to be accurate. I mean, am I missing something? Keep going, bro. I'll mute up for another time.
Right. So, I mean, we are using the angle to that celestial body to get the distance to its GP, right? And our assumptions that make it work is that the Earth is a sphere and that the light from the celestial body comes in parallel. Those are the two assumptions. We can be a bit more accurate and say that not exactly parallel because we're also accounting for refraction. So we add a little bit of arc minutes just to account for how much that light would be bending when it goes through the atmosphere. But just to simplify, we treat those rays of light as coming in parallel, and Earth being a globe. And that actually...
Okay, but do you understand what I'm saying? Is that you didn't actually determine the distance of the stars.
Sure. Yeah, we're
Like,
not
you admit
determining that.
Okay.
We're
So a
we're
sextant
requiring
cannot
that.
tell you. The sextant cannot tell you the positions of the stars.
It
Right?
tells you the position in your field of view, right? Not its
But it
position in
doesn't
space.
tell you the position of the stars. You
And
know,
not
a
in
lot of
space,
globers were
sure.
here today defending that a sextant is accurately like determining curvature and where the stars are, and I just found out that it's not. So what's that?
I think you misunderstood the claim. I don't recall anyone saying you can get where the stars are using a sextant. Like
Sure,
you can't use that for the
I'm glad I yeah maybe I was wrong when I heard that before. Sure.
right. All right. So anyway,
Like I said, this is new to me, man. So we're building my foundation of understanding for it right here, right now. So I'm gonna listen to you, man.
okay. So yeah, the reason why I say the distance matters is because if we assume that the star was close, we wouldn't get a linear relationship between the angle and the distance. So we put them very far in such a way that the light come in parallel, and then it gives you a linear relationship between distance and angle. That's why I wouldn't say it doesn't matter how far they are, because it matters that the relationship is linear, and that only makes sense like geometrically if they're close, given that we are using light to be traveling straight paths. Did that make sense?
I heard you say that the lines are linear.
No, the relationship. So, for example,
Okay.
the angle you're right below the moon, for example. Moon straight above your head. The zenith angle is 0. If you walk 60 nautical miles away from the moon is going to drop by 1 degree. If you walk another 60 nautical miles, it's going to drop by another degree. So every 60 nautical miles you get away from the moon, it drops 1 degree. That's called a linear relationship.
Yeah, every time I get closer to this green light, it's slowly rising into the air, and then it's going to be directly over my head.
Well, not just
thing,
that.
Right?
No, it's a bit more specific than that. Of course, if you go, let's say, if you're looking at a building and you get away from the building, the top of the building starts to get lower and lower in your field of view, right? But that doesn't happen at a linear rate. So the amount of distance you have to cover.
Wait, you said, hold on. You said the top of the building gets lower and lower the closer I get to it?
No, the further.
Right. The closer I get to the building, the farther away the top seems, right?
Yeah. So when you're very close to the building, you have to look straight up.
Right now.
Right. Let's say you're very close to the building. You're basically facing the wall of the building. To see it stop, you have to look straight up, right? As you move back, that direction starts to drop. As you get further and further, it drops more and more, right? Correct? Hello?
Just so you know, like, I'm literally like working right now.
Right. That's fine. Yeah, I think I'm gonna grab some dinner. Be right back.
So, Jeremy, did you end up hearing? Anybody hear him break down the sextant before? Am I the only one scratching their head like, damn, what is this glossary index of coordinates that every sextant has to base their fucking angles on? What's that?
It doesn't matter. They're making a geometric claim on an apparent position. Okay, these stars that they're looking at, it's an apparent position. They don't know if it's an actual position. They can't prove it. If they could, I don't even think we'd be sitting here right now.
This is new to me, man, so I'm like stumped.
Like this whole sextant thing is based on an apparent position. I don't know if you don't understand the significance of that.
Yeah, I can't say I could give any like real. I can't add too much to this conversation, man. I'm just listening.
Yeah, but they're making a geometric claim on an apparent position. They do that all the time with everything. This isn't the first thing they've done it with. Like that alone, that's the end of their argument. They can't prove the position of it. If they could, like I said, if they could prove the position of these stars, I think they'd have to do the distances too. I don't even think the positions would do it, but maybe whatever. If they could prove the position of the stars, the actual position, that'd be a huge step forward. They'll tell you they can't prove things. They don't prove things in science.
You heard how big my misconception of sextants was after sitting here listening to those two dudes discuss it for like 2 hours? And then I had to say, hold on, wait a second, what's a sextant? And then I got my answer. And it turns out it doesn't measure stars. How funny. How funny is that, guys?
Measuring the angles to the stars, yeah. To the apparent position of a star.
I mean, you literally are calling it like a celestial navigation tool, but, you know, it didn't ever measure the stars. So I just find this ridiculous.
They're measuring the stars with it. They are. Who said they weren't? They're measuring the stars with it.
Yeah, just
they're making angle
tell me I'm
measurements
wrong.
to the stars.
I know I'm wrong. Yeah.
Yeah, that's what they're doing with a sextant. They're making angle measurements to an apparent position of a star. They won't even do it under, I think, 15 degrees, maybe 10. I forgot the number, but there's a degree where they say, well, don't even use a star if it's as low on the horizon, because then they know it's not even close to its actual position, and it's worthless to even do it that low. I'm telling you, this position, actual position, and apparent position thing, this is the key to a lot of arguments. Anytime you hear refraction, this is going to be the thing that you're going to, as my go-to thing, like, oh, you said refraction. All right. So you must know the actual position to know if it's higher or lower than its actual position. They can't show you the actual position from your, they'll say, we can go there.
That's
we know
right.
its actual position. They'll tell you,
that
they'll
was
say,
my
well,
problem with a lot of other things about refraction.
Yeah. They'll tell you, well, we can go there. So we do know its actual position. But from where I'm standing, miles away, you don't know its actual position.
Yeah, that's the whole argument, is that you can never truly know the position. Yet they know everything, like the position, the shape, how fast it's moving, but we can't detect it or observe it. I'm a noob, clearly. So if I sound impatient, it's not because of anybody else. It's because of me.
And no doubt, just keep an open mind on things, you know.
You know what really helps with my impatience? I just realized I ain't smoke at all today.
You know what really burns my ass? Fire about this high.
What up, Grim?
Hey, what's up, guys?
What's up, Grim?
You guys doing?
There was some dude in here the other day that sounded just like, I was like, yo, are you Grim? I had to ask him.
Was he having mic troubles? That's a sure sign it's me.
Yo, Grim, you said something the other day, maybe it was a day or two ago, about plasmoids and how, you know, light has to travel through this. Did I get that right the other day? Am I right or wrong? Tell me what you were saying about it.
They emit a particular red shifted or blue shifted light depending on the direction of the charge you're looking at the plasmoid. So I mean, they can
right into the plasmoids. Grim just got a boner off of this.
A plasmoner. So and there's a laboratory experiment that, you know, it's relatively recent too. So it's weird that they keep ignoring it and marginalizing it, sweeping it under the rug and everything. But it demonstrates how the plasma itself puts off a shifted light, and it's not expanding or going away from you at all, and it's giving you the red shift as if it's moving away from you, yet it's still sitting right there. And that's what, if they now know that that can happen, and that's an intrinsic property of the light coming off of different types of plasmas, then they have to incorporate that into their theory. It could be that they're looking at these plasmas, which they know they're looking at. See, that they don't even deny that they're looking at these plasmas. They're just not applying what they know about the plasma light to their old theory. It's like they're trying to protect the neck.
Yeah, thank you. Have a nice day. Thank you.
Yeah.
Sorry, talking to someone else. I keep forgetting to mute up.
Like that Wu-Tang reference. Can you hear me? I am Grim, and I have done this. Has it gone silent in here? What just happened? Did I break something again?
You broke it, Grim.
I heard that.
I kind of wanted to get more details on Grimm's theories on plasma, because maybe there's like one or two things I might agree that he said. Like, do you believe that it's like a layer of plasma that is the dome? Is that what you're saying?
Well, I mean, I'm saying what you could consider the dome as a flat earther, or what we could all consider a container as human beings, is that, right? I'm not making any claims to suggest the nature of the shape of the earth itself for the sake of, you know, keeping a positive momentum going in the conversation. But I am kind of giving factual data that can be, you know, used any way you'd like. It's just data. It's up
Can
for
you
your
summarize? Can
interpretation.
you summarize that significant data about plasma I keep asking about?
Well, the way you asked it, it was like a precept question where I would have to,
Definitely. You could just tell me what I don't know.
I don't know what you don't know. It's just plasma physics. It's not my theory.
Just assume I'm a kindergartner.
No, that's what I want to tell you. It's not my theory, and I'm probably as much a kindergartner in it as you when it comes to the logistics. The layman's terms, I can kind of spit some some lightweight mechanisms and stuff. But this is an actual physics that has real world implications and stuff. Is for me to try and explain it to you would be doing it a great injustice since you really don't have the fundamental. I could explain to somebody who has the fundamentals and the basics in layman's terms, and they can then connect things, more easily. But to walk you through it, piece by piece.
Assume I have the fundamentals then.
Yeah. Okay. Well, all right. So there's a plasma shell around the Earth. There's an induced magnetic field from the circuitry of the sun, the solar wind. That's they say it's a net charge. It's net zero, but it's actually not. There's a definite current, and it's an ion species current. There's a lot of dust in that, which hides the ions. Anyway, make a long story short, negatively charged bodies, which are bodies that are outside of the heliopause, that enter the heliopause, discharge slowly. That's what you'll see, like the coma of comets, different things like that. They discharge slowly as they move, towards the more positive region or whatever, and that electrons stripped out of their atoms and all that kind of stuff. So that creates like what they call double walled layers in plasma, and that would be like field aligned currents that would actually counter rotate and shell each other, right? And then, like for Earth as an example, the magnetic field of Earth, either it be induced by being immersed in the plasma, kind of like Venus has an induced magnetic field in their own model. It doesn't have its own magnetic field. The same thing could be that Earth also has an induced magnetic field, but it's a double, like a transistor type situation where the currents go in and out of the poles of both poles, not just in one pole and out the other, but in and out of both poles, right? In concentric cylinders, like one wrapped around the other, going in the other direction, like a coaxial cable that has electric charge going in both directions. That creates that that through the left hand rule, right hand rule, whatever, you've got the magnetic what do you call it, inclination perpendicular to the direction of the current, and an overall magnetic inclination draws in unionized materials from the surrounding area, can cause the matter to spin in one direction, flip the magnetic field, and you can spin it in the other direction. It might give some credence to that biblical thing where the sun rose from the
And really, okay, you kind of, all right. I'm just saying, I don't want to. No, wait,
big electric.
Please let me interrupt you, bro. I understood like a lot of that, but now we have to like refresh it. Like, so we put in better. I'm gonna mute up again and let you keep going, but don't move forward. Make that better. Right?
Yeah. So a lot of those ideas were proposed back in the late 18 and early 1900s, but they were poo-pooed on because the more favoristic, more valued theories were gravitationally centric and were lacking in electric circuits, because since they said they can't see any electrical currents, therefore there aren't any, so it must be gravity, and gravity alone did all the heavy lifting and organizing of matter, star formations, all that fun stuff, when in fact, now that we're in the space age and none of their supercomputer models can have even dust bunnies come together with gravity alone, you're going back to the drawing board in a lot of different ways, but just not out loud, so that they admit that they've been completely wrong. They do it in ways where they start looking for, ad hocery magical materials like dark matter and dark energy and things that just, WIMPs and supersymmetry. Remember, WIMPs need supersymmetry, and supersymmetry is a goof off, and so the whole thing's a goof off in reality. And but all they're doing is still assuming that there's no electric charge that's helping organize and structuring all this matter, because they're assuming that there's not a medium for which that electric that can act as a conductor for these interactions that take place. But they know the medium's there now. I don't get it why it's still like a big mystery or
What do
whatever.
you think is the origin of the conduction?
Well, it's so far outside of farther than we can see that the origins won't even matter. We can see that they're so far away that it would take more than a zillion lifetimes to get to us at but it's coming in from that far away. That's all you gotta know, because you don't have to know, it. Let's say, for the sake of argument, there's it could be another 10 billion years or so before there's even enough movement to even be concerned with if the stuff as far away as we can see is going to get to us yet. You know what I mean? There's not even, it's so far away that it doesn't matter where it's coming from. It's coming from far away, but it's coming from outside. It's an external source. So it's not like you burning up all your fuel from the inside and then it's gone.
Hey, can I ask you then? Did I hear you say the word plasma field before?
Electric fields. Plasma is just the ionized gas that can induce electric or magnetic fields upon movement, just with its own motion.
So if I understand this correctly, you're saying that there's plasma in the universe billions of miles away conducting the electromagnetism of Earth?
Absolutely. It's there are no islands in space.
Can I just say I'm glad I'm not I'm wrong. Damn, I'm really trying to listen, bro.
No, yeah, I'm saying absolutely. There are no islands in space in the electric universe. Like, every system is connected, and it's a crazy phenomenon that they just discovered in the standard model about the cosmic web connecting all of the galaxies. First, there was a spooky alignment of quasars and galaxies where you could see how they were all lined up in the same magnetic orientation, and there was for gravity alone centric theories, that is impossible. That is not even feasible at all in any way whatsoever. It's a phenomenon it should have heaved the gravitationally centric theories on its head the minute it was discovered. But somehow they keep trying to go with it. But it's funny. But it was a prediction of the electric universe that you would see these alignments and that magnetic fields would be organizing matter and stuff in a much more structured way than gravity could ever do. And this was all predicted, by electric universe proponents. And obviously a phenomenon of unexpected intrigue, for the standard model proponents. and then it goes on and on. But there's an actual rotation in the galactic web. They can see this, this red shifting and blue shifting in a particularly strong way, overriding the net red and blue shifts of just plasma light. And this rotation that they're seeing is actually just demonstrating the fractal nature of a giant Birkeland current, which is, the filament in plasma wrapped with his own magnetic field wrapped around it, constraining it into like a long, slender filament. And a twisting filament, by the way. And that's why I like to post that Spencer ball from Spencer's, those plasma balls. The one with here, let me see if I can just find it. I'll post it.
Oh, yeah, I know what you're talking about. I had one of those. You put the penny on top and shock your finger. Yep.
Yeah, that's it. So that thing right there is a demonstration, because plasma is scalable, 10 to the 39th order or something like that. So that means like what you can do the size of smaller than an atom, you can do the size of the cosmic web. Like if you can make a filament in a Spencer ball, then a cosmic web filament can also be made from plasma because of its scalable nature.
Okay. You said filament. What's the difference between a filament and a firmament?
Oh, a filament is like when you look at it, it's like a long hair, but it's made of and a plasma filament is made of plasma, and it's it consists of like two magnetic fields wrapping around each other, two currents melding into one current wrapping around each other and twisting. It creates a spinning effect. A firmament is just like some sort of a solid thing, or it could be, a force of some sort. I mean, just in the word firm, some sort of backdrop of force. I would imagine for the flat earthers, I would say magnetism, but not just magnetism, but electromagnetism with plasma behavior, could be your firmament because it holds in gas pressure.
Is that image in chat what you're talking about, Grim?
Shit, let me check.
Kind of looks like a DNA strand.
Yeah, absolutely. That's the one. That's called that was the newest and largest rotating discovery, rotating object in the universe. That's cosmic web. And we're saying that they're all doing that. That's just one you were able to see it. They're all doing that because they're all electric. It's funny how they tried to ad hoc dark matter into the situation and everything, and they know they're looking at an electric current. I mean, who wouldn't know that you're looking at a Birkeland current? If you've ever seen a Birkeland current, you'd go, okay, that's what that is. Got it.
Does it matter that I want to say water conducts electricity? Does that matter?
No, it does matter because water does not conduct electricity. It's an insulator.
Whoa, I never heard this before.
Bullshit.
Water doesn't conduct electricity?
Pure,
No, water is an
100%
insulator.
pure water is an insulator. Grim is right. However, it gets even the tiniest bit of salt in it, becomes a pretty decent conductor, actually.
Wow,
Right,
what
I
a
mean,
misconception I've had all my life about this.
a lot of people have.
Well, see,
I mean,
the
you're
thing
still going
about
to
it
get
is what Grim
electrocuted if the tap water is on the ground because it's full of electrolytes. It's
typical Grim. He'll say something that is right, but is wrong most of the time, but is right in some narrow things. If you just take the purest water you can, open it to the air, enough gas will dissolve in the water.
You
to
could
make
have
it
stopped
conduct.
after the word right. Typical Grim.
No,
You said
you're
something
not
that's
right
right.
though. You're wrong.
Oh, okay. So pure water is not an insulator?
100% pure absolute water. Yes, you'll never find
Okay,
that.
so I'm not right. A pure water is not an insulator.
But you won't
Let me get
find
this straight.
water pure. You will never find water pure enough to be an insulator. Not in the atmosphere.
I didn't ask. That wasn't the question. He asked me about water, and we weren't talking about the atmosphere.
What you're doing isn't wrong, but it's misleading.
What's the difference? What's the difference between water being conducted and an insulator?
An insulator doesn't allow for the electron to flow across it freely.
Gotcha. Thank you, guys. By the way, I'm learning a lot right now.
So basically, when lightning, if you're like in a lake,
Water as a colloid,
and water hits the lake, you may well get electrocuted if it's close enough, because there's enough dissolved minerals in the water to make it conductive enough to zap you.
Yeah, but that's why all the fish don't die when the lake gets zapped, because it's not that great of a conductor, even with the minerals in it.
The fish aren't touching the ground usually; they're like suspended in the water, so it kind of goes around them. Yeah.
But the water's touching the ground.
Some fish
Thank you.
will. Some fish will, if it gets close enough.
If the water was a conductor good enough, it would be grounded to the ground since it's all over the ground, right?
Yeah, you know how it works.
Yeah, I'm right again.
No,
This
you're
sucks
not.
for you.
You're never
Okay, hold my pants
You're rarely
while I
right.
pee.
You're rarely right.
I'm rarely wrong is what you really need to say, dude.
You're rarely right.
You can reshape the argument to make me wrong, but in the context that I've used my statements, I'm absolutely 100% correct, and I stand by that. Now pull up your pants.
But in the meantime, though, use water as an insulator on the Earth.
Dude, you still haven't pulled your pants up.
Yeah. See, the thing about it is, even when you're right, you're misleading, which is kind of amazing.
Oh, yeah, I am amazing. Thank you.
Yeah, amazingly.
So wait, okay, so
I'm
you're
working
saying
you like a
only,
dog
hold
today,
on, can
dude.
I
You
ask
can't take a
then?
shit. Go
Can I
ahead.
ask a question? You said
Absolutely, brother. I
only
appreciate
pure
it.
water, 100. Are you guys listening? I'm sorry. Can I ask
Yeah,
this
I mean,
question?
absolutely.
You said only pure water can conduct electricity, right?
No, backwards. It's backwards.
Okay, go ahead. My bad.
That's okay. Only water with electrolytes in it, or colloids, right? That can hold a charge, or allow for ions like salt, high amount of ions, and you can get a
So
nice
that would, so then
ion
that would
current.
be considered an insulator of these particles.
No, the particles act as the conduit across the substrate of the water, right? But the water
Wow.
itself is an insulator. In other words, if I'm standing in pure water, you can zap the pure water and I won't get electrocuted if I'm just sitting in it.
Yes, unless something is
Is
carrying that.
there an atmosphere?
I got it.
Is there an atmosphere? Is there an atmosphere to the water you're sitting in? Hello, Grim.
I'm sorry, we're not talking about water that we're seeing.
Oh,
We're just
so
talking about
there's
the
not
physical
you're saying you're
properties of
seeing
water
water.
itself.
You're seeing
We're
pure
not talking
water.
about in any conditions or anything like that.
No,
Like
no,
I
no.
said, you
Let me
can
say
water.
something. Wait.
throw
Let
me
me
the
ask him a
argument
question.
again.
There will be
Go ahead,
enough
throw
dissolved
me the
gas
straw man. What would you like
water.
the argument to be about, my man?
Let me ask a different
Say you're
question
seeing
then.
water. If you're seeing water on the Earth in an atmosphere, there's enough dissolved gases in that water to conduct electricity.
No, that's a better understanding of than saying just water alone is a good conductor of electricity now, isn't it? And to get him to that better understanding, I had to first
Even
make him
distilled
understand
water,
that pure water is an insulator. Without the additives, it doesn't
extremely
conduct
pure
anything.
water.
Hey, how about shut
Not
up?
only
How about shut
distilled
up?
water, but degassed water. For fuck's sake.
Wait, guys, I'm not understanding something. Can I please ask a question? You're saying that only pure water is going to electrocute me?
No, will not.
No, that only pure water will not electrocute you, and that there's barely any pure water around anywhere to not worry about it anyway. But in laboratory environments, they use distilled water as insulators for capacitors and different things.
Well, it's
So
not only distilled water, it's degassed. It's like, I mean,
So
it's
the water has to
once
have
it's a gas,
something
it's
in
no
it.
longer a
Yo,
liquid
wait,
anymore, and
please
it can be
please,
ionized.
and then I'll mute up, guys. Please let me ask my questions real quick. So water has to have something in it to fucking be conducted, right?
correct.
And it has to
So
be
then
in liquid
suggesting that,
form.
okay, let me finish. So then suggesting that the waters above are pure and can't conduct electricity, well, isn't that kind of ridiculous? Who's to say the water above us is pure? And that's all I wanted to say. Thank you.
I was wondering if there was any water above us in liquid manner that we're talking about, since we're not actually supposed to be talking about in gaseous form in the first place, right? Because if it was water above in a gaseous form, it wouldn't behave the same. It wouldn't be an insulator. It wouldn't do any of the things that liquid water here does. So it wouldn't be useful or having any utility at all. And nobody was assuming that there was a ocean of liquid water above the atmosphere somewhere over our head in any way. Nobody's denying that there are water vapor and gaseous forms of water which behave entirely different and are not a part of the conversation of being an insulator, which someone keeps trying to invoke as a straw man. How much time do you have in a day to just fuck around and do this dumb shit? Not you, man. NASA, paid shill, or whoever the fuck that is talking to me.
Can I get the embed role? I have it on the 24/7 Discord.
What do you need?
The embed role.
One more time.
The role that makes me able to embed stuff.
Oh, he needs a post roll.
He wants to post thumbnails.
Is that possible?
I don't know the fucking command. Hold on, let me check. I might have
I got him.
Oh, you got it. All right.
Man.
What is it? What is it?
Well, it's LV, live stream verified.
LV. Oh, that's what I was going to try. All right.
Check out
Las
this
Vegas.
wonderful video proving the globe. Click on the link.
Can't prove the globe.
Click on it.
Is this gonna be like? Is this gonna? I'm not doing it. Somebody else do it first.
Dude, this is like 2007 shit. He just just a very basic run of the mill Rickroll.
Yeah, I discovered some exploits and managed to like not show the Rickroll video and give it a different name, so that it seems like it's a different video.
And we keep talking about this supposed electromagnetism in the water above us, please. Like, why are we talking about this dumb shit now?
I don't think we were. At first, we were talking about plasma, which we know is up there, right? I mean, we measure that shit. We've been learning more and more about it, especially in the past 5 years than in over all of this time.
Really?
So, I mean, yeah. They didn't realize that they were like, they call them magnetic ropes, but now they know that magnetic ropes don't exist without their causative electric circuitry. So now they're electric currents, and they still call them plasma tubes. And they connect the northern hemisphere and the southern hemispheres, atmospheres go all the way down. And there's like a whole map of them. It's basically like a bunch of prison bars around the planet, going from the North Pole to the South Pole area, you know? And that's the mapped out.
Oh, wait a second. Okay, red flag. I'm sorry. Are they trying to make people picture that we're in a prison?
No. I'm just using that as an example because it's like those tubes. They're, like lines of longitude, right? But they're plasma and they go above the Earth's surface. Here, I'll show you. Get off YouTube and find on a regular.
Grim, what do you think of the idea that the entire sky field, a dome, if you will, is actually plasma?
That's interesting. I mean, a lot of fixed objects in there though that don't seem to warble. You know what I mean? Like fixtures and shit on certain things. Maybe not the moon not included or something like that. You mean?
No, the moon even more so.
Oh yeah, I don't see that with the
Like
moon.
concentrated plasma.
Yeah, see, that's plasmas move very, very easily with the magnetic fields, and there's nothing moving on the moon in any way that would.
So
for me.
So you think the moon is closer than the plasma or farther?
It's in between it and immersed all in it with us. The solar
So
wind.
we're just completely envelope everything: the sun, the moon, the
Yeah.
stars.
Yeah. The solar wind is a plasma, right? It's ions moving away from the sun, ionized gas.
For me, looking at the moon, as far as like thinking the moon, I've heard it talked about the moon's plasma or something. It just looks like a big spherical rock up there in the sky to me.
Me too, with light reflecting off of it, not
Right.
emitting light in any way. Not to say that there aren't electrical interactions and different plasma interactions and things helping create and reshape and move dust and cause clouds. Because those clouds on the moon, when those popped up, that was all from ion disruption and electrons pouring in. That's an electrical storm causing the reshaping basically the surface of the planet. Not all very quickly or anything. I think a lot of those formations in the past may have happened very quickly due to an unstable electric circuit when it was finding its equilibrium electrically. It maybe discharged a lot until that was all done with or whatever. But now it's like in a much more stable, a balanced current. The current is balanced basically, if you want to put it that way. anybody who does neon or anything knows what I'm talking about. Like you can touch a balanced current right in the middle of it, 60,000, running 20,000 volt transformers and congruent, 3 of them, and you won't even feel the tickle because it's midpoint grounded and you're balanced out in the middle, You got enough load on that current. And the rest is being used. Electricity wants to go through it's more easy, the easiest path.
What were you saying before? What were you saying before? Water and gas not being to conduct electricity yet is.
That's why they call it the fourth state of matter, because it doesn't behave like a gas once it's ionized. It no longer behaves that way. And it can be a plasma and behave like a plasma if only 2% of the gas present is ionized. That's what gets weird about it. So you can have gaseous plasma, which is like plasma. Gaseous plasmas are found in the plasmoids, surrounded by the magnetic field, and in the laboratory, again, surrounded by the vacuum. So there's literally a vacuum, which reads that there's no gas pressure in this vacuum area until you take the needle and you push it into the plasmoid, which is also in the vacuum, and then you read gas pressure. All the gas pressure is protected by the magnetic field, the electric current, and everything that continues to pull and control the pressure inside of the system. So that's why I say you don't need a container per se if you have this, plasma sheath over the entire Earth, no matter what shape you got there, man. I'm not trying to argue for the shape, but that plasma sheath will hold in the, and protect from, higher energy waves wiping all of the atmosphere off the Earth anyway. For in other words, without that plasma sphere, we wouldn't even have an atmosphere. And that's something they don't even deny in the standard model. Like, they tried to at first, and then they realized, oh yeah, Grim is right. Even NASA says.
Are you throwing away gravity?
No, I'm saying no. Gravity in my, reality exists, but the explanation.
So then where does it apply? Yeah.
I don't even know what you're talking about. You're standing there talking to me on the ground, asking about gravity.
Gravity is about like objects being attracted to each other.
Well, all this stuff about plasma and magnetism, wouldn't that, you don't need gravity after that?
Well, here's the thing. We do have this measurable acceleration that we have to explain with something. And they say when you hear the word gravity, all of a sudden you think space-time curvature bullshit, all this stuff. So you want to throw it all away. But the word gravity doesn't mean that. It does to them, but there are other ideas about what gravity could be, other explanations. It's not a settled science. So gravity could be, something external from the ashes of an electric force. It could be that there's an elongation on the electron due to a dipole moment, and and it is because of mass, and it's still the same exact equations as far as how mass would attract certain masses, because obviously certain masses don't attract certain masses, and we know that, right? Because they have different electromagnetic properties to them.
Yeah, so it's something else than gravity that makes it pull it down. It's not gravity, because gravity is something
other than space-time curvature gravity. But I mean, the word gravity, when I'm talking about gravitational acceleration, I'm just talking about the measured acceleration in free fall. I mean, that's
true.
Yeah, that's all I'm talking about. That's measured, and it's an acceleration. I don't understand it, but I know it's there, so I have to use it.
Yeah.
Yeah, I'd like to hear your take on the comparison of Coulomb's law with the universal gravitation.
Colum has a pretty good explanation, actually.
Yeah.
I mean, it's very incomplete and everything, obviously, because they can't unify
But
the
the
theory.
equation's like almost exactly the same as
Yeah, the inverse drop,
Cavendish.
exactly. The the 90-degree, attraction, the stronger, like an electric discharge is always at 90 degrees.
A little
And so is the free
suspicious,
fall.
isn't it?
Yeah, it's that's why I said it might be of the ashes of an electrical system, this gravity.
Did you say ashes?
Yeah, like maybe like we have two, maybe let's say we have 3 complex electrical systems on top of each other and inside of each other, then gravity because of that, right? Inside locally of those, because of those systems, then gravity.
So you mean kind of like the residue?
Right, like how nail becomes magnetized only in the presence of another magnet. You don't even have to touch it. It just becomes magnetized in the presence of the magnetic field. So a daisy chain. Now one nail can pick up a bunch of nails. If you're like, I could hold a magnet in my hand, a nice neodymium, and then hold a nail about 1 finger width apart on the other side of my finger, and that nail can then pick up more nails, even though it's not touching the magnet.
Transferred power, right? The transferred power property of it, yeah.
And I think it's some complex system of that on the subatomic particles, which maybe could be like an elongation of the electron around its orbit, and so that would cause like a dipole moment, which would be like let's say we had every atom would be kind of like a weak magnet at that point, but all of the north are hidden by the souths. The souths are all on the outside, and the norths are all on the inside. So there's a long range attraction, but a short range repulsion. Once they get close enough, they'll repel again in that system, right? I just think we're in a part of that system right now.
That just made me think of like that video you recommended that I uploaded a little clip of with the leaves or whatever it was he was using, the tea leaves with the dipoles in the water. Then wouldn't if you think about the atmosphere as like that water, right?
Exactly.
At the bottom of that water, there'd be a certain pressure just from those dipoles causing that circular motion. It would cause that toroidal field to push down to some degree.
Or anything. Right? Exactly. Yeah. I mean, we would have to be, we have to really be honest in our scientific endeavors to, you know what I mean, to get to those things. Because you got a lot of people that they know that if they present any data outside of the standard narrative that
that's what sucks for them,
maybe falsify predictions of Einstein, then they're going to get laughed at.
Okay, so you're putting a new definition on the word gravity. So that's why a lot of people aren't just going to align with that.
Well, that's the thing is the flat earthers are mistaken to say gravity doesn't exist, because gravity does exist. It's just not in the way that they're explaining it.
Exactly. It's just not space-time curvature with a bunch of dividing by infinity and nonsense that is unconceptual even. You can't even fathom what they're playing with. It's math magics. It has nothing to do with reality.
And the acceleration does exist regardless. There is an acceleration. So that right there is the biggest problem, like you were just saying, I heard.
And what is the acceleration of a helium balloon rising? What is that called?
Well, it could be the opposite. It could be 9.8 meters per second average up instead of down, but regardless, if that acceleration doesn't necessarily have to have a reason. It could just be like some universal number or universal average, like you'd see with a flower of life, like a pattern, like any kind of Fibonacci sequence that's just like a fingerprint of God in a way, But regardless, hey Grim, you're down with there is no pull, there is only push, right? You understand that whole concept, and that's the only force we have is push. There is never a pull.
Lagrange, right? Lagrange has it's called the push theory of gravity.
Yeah.
Right. And where these etheric particles that barely drag any matter, right? But they push all matter from all the directions. And when 2 objects become close enough to each other, it cancels and blocks the other particles from being able to spread them apart, because they're only coming from all around. And now those 2, they're shadowing each other. It causes a column of emptiness between them, and that column of emptiness, lack of particles pushing it. Those other particles are still on the outside, pushing them together. Now there's no particles on the inside because they've become close enough not to keep getting spread apart.
Right. Even with magnetism, it's a push, not a pull, because the field wraps around.
And squeezes a push together.
Yeah.
Dude, okay, so check this out. You want to act like flat Earth has got it all wrong because they say gravity isn't real?
No, he's not saying that.
Okay, I don't want to be interrupted. Just 1 second.
No, oh, I'm sorry. Okay, nobody was saying that.
No, this is what I hear. This is what I hear. I do a lot of listening, bro. Just check me out.
I know. Go ahead.
The mass of an object causing a force to pull an object towards it. This is the general consensus of gravity. You understand that?
Yeah, that's no, wait, no, it's not the general consensus of gravity any longer. That's the thing that a lot of flat earthers don't understand or don't necessarily capitalize on.
Do you have to be a fucking expert in astrophysics? Because no. This is what everybody assumes. So the common, check me out, bro.
Wait, let me explain. Let me explain.
No. I didn't even make my point.
Check me out, man. Come in with a little less heat, all right? Because nobody's against
electric.
Bro, listen. Just listen. I'm literally
okay. Go ahead. Go ahead.
With one hand on my ear so you can hear my mic, and then I gotta mute up because I'm working. So
I got you.
The general consensus, the peddled narrative, you guys are saying the mass of an object causing attraction. This is not correct, right?
It's not correct. It's not even what they say any longer.
Yeah,
it's not the general consensus anymore.
This is why people. So you also don't agree with what? You're not listening to me, bro.
It's just that there's a major thing that I know already that you're missing, which is that there's the whole Einsteinian gravity, which is they have to explain as the bending and warping of space-time, and that Newtonian gravity.
I know about that. I just heard about
so even that.
Gravity
and you'll still hear him say that. You'll still hear him say mass attracts mass, but you got to pounce on him for that because that's not technically what they can say any longer. They still have to describe it as
the mass affects the space-time around it, and it follows the curvature of space-time. Centrifugal and centripetal. I understand all that. Okay, common peddled narratives. Why are they so prevalent? Why are they the prevailing narrative for gravity? This is why people want to throw it out. You can't be mad at people who want to throw out the word because the context and the general consensus behind it. That's the only point I wanted to make. Thank you, guys. Keep destroying this argument.
Yeah, exactly. It's just that they want to hold on to it and explain it the same way because it can still work with their math and their idea of how things work, with regardless if that's technically the way it is working. They can say it still manifests itself as mass attracting mass, even if it's push force. And it just seems so ridiculous when you try to explain the Cavendish that way. But yeah, this other mass over here in this little vacuum chamber is warping space time now. What? Come on.
Yeah, exactly. Get off my nuts. Then I should be able to see a Einstein. Little bit of an Einstein in what do you call it? Gravitational lensing off of that. Since I can measure, since we can measure that it's bending space time by attracting, then we should also be able to measure it with a photon, right?
Right.
Right. You guys are both Globers destroying gravity. I love it.
I'm not a Glober, dude. I'm total flat Earth, old school, bro.
Oh no, I'm sorry. No. I guess I mean Grim, not both of y'all, just Grim.
He's not a Glober.
Well, I am
really
a Glober either. Yeah, I'm not the.
He's a flat earther that just doesn't realize it yet because electric flat Earth is the future.
Whatever, but still, I mean, I like to know, the things that the arguments that the other Globers will come in with, aren't real, and I'm trying to be super honest about it, and. Yeah. Boy, I get a lot of flack from them about it too.
That's what I mean. You're on our side already to a large extent. That's for sure.
Yeah, but I wouldn't call it. I'm on the flat Earth side. I'm on the alternative cosmologies side.
I wouldn't even say I'm on a flat Earth side because I'm a non-believer, and you're a non-believer in a lot of ways too.
Non-believer. Yeah, I'm definitely not a mainstream.
Believer. Yeah.
Believer.
Yeah. And you, like you said earlier, if you found out for sure that it was, not the spinning ball or not a ball, that you would be having a party for our, definitely invite me. I'll come have a toast with you.
I mean, a bunch of you
It
already
just
know.
seems so obvious that I have a hard time understanding how anyone could stick to that if they're super critical like yourself. But
yeah, well, that's why I don't put my feelings behind it so much, because I could be wrong, man, and I don't like, you know.
yeah, I hear you.
Like, I feel like a
Good.
religitard if I start going, no, God damn it, you can't be right. You know what I mean?
Right.
Like,
but some of the space stuff that you say you think is legit, I can't believe. You know, like the missions that they do and stuff with the CGI doesn't even seem like it.
I didn't say I didn't have my set of assumptions that I believe in. You know what I mean? Like, that I
But
don't.
why would you even choose to believe in that set of it, that part of it?
You know, it's almost because it's very fun in a way, and also they don't want me to see it so badly that I want to see it. You know what I mean? Yeah,
I
it's
got
like
you.
they'll spend billions of dollars to shut this shit off, so that they can make billions and billions of dollars to open up this invisible can of worms of mystery. Because I mean, it's like kind of like, if somebody had a channel on YouTube and the whole channel was on the basis of premise of prove this one thing, and if somebody came in and actually proved the one thing, then the channel would be over. So they don't ever really want the guy to prove that thing. They want to yap about it
exactly.
forever and ever
Right.
and ever, and give
They
you
want
money.
the argument to continue. Yeah.
Right. So they can get
I was
research
saying to
funding.
somebody last night that this subject makes us all head cases to some degree, no matter which side you're on.
Yeah, absolutely. Yeah, and it really distracts us from some of the more, I mean, the detrimental, time, sensitive things that are happening. Like, how many of us sat on here and yapped about
Like we could do anything about
Obama
those things anyway.
when we, otherwise would have been, helping other people demonstrate against mandatory vaccines or taking my semi.
But really, are there demonstrations really changing? Well, I mean, maybe informing people, yeah, that does help.
Bro,
But
we're all able to network. Yo, we're all
Definitely.
networking on an international scale. Nobody should take this for granted. Like the type of shit I've been learning in here, bro. I'm so grateful for the time I spend here. Honestly, I'm grateful to be here. You guys are awesome.
Me too.
It's just the opening up to everything being possibly not what we're told, and so there's all these other topics that you can't even broach with people unless they understand that there's actually a real question on the table about the shape of the Earth, and that just opens up the possibilities. Like people that never, like I always said before, like if you haven't figured out 9/11 wasn't what they were telling us, I don't know how you could ever get to flat Earth. But some people do.
Well, and this is such a huge thing because, okay, let's just say for a moment the Earth is a globe. If it's a globe, then all right, the people in power, NASA, okay, it's honest. At least they're honest about that. There might be some other corruptions, but that, they're exploring space. The fact that all these major governments, all of the ones that really are the ones that have the space companies, the space agencies, yeah, you could say something about Elon Musk, but I mean, he's so wrapped in with NASA. Plus, he hasn't even gone any further out. Like the governments are the ones that are the only ones that have claimed to be far out there, meaning beyond low Earth orbit or whatever. They're the ones, the only ones that are claiming that are actually sending probes to outer space and telescopes to outer space and all that stuff is all space agencies, government space agencies. So the fact that that's that whole narrative, like I said, if it's true, it's kind of like, okay, then that's all good. But if it's not, then the whole thing shatters, because at that point, that globe thing is so fundamental to the whole system that we're in of people, their worldview, that if that's false, then the whole thing crumbles. Like, I think they were really bold with this lie to do the globe thing the way that they have. But to be that bold, especially if it's coming from deception, there's always going to be a reaction, which is that whole thing is systemic. And once that globe goes, their whole power structure crumbles.
I thought the same thing. Also about not just that, but also about all these religions, all based upon the same stories, and a lot of them are just basically, accentuations and validations of the other one, even though they pretend to be opposing and all of this stuff. It almost seems like that was easy enough. Like, I don't know how people didn't catch on to that right away. It's right.
But don't you see how the psychology of it works with the boldness included? Because to claim that a man walked on the moon is a bold claim, but so is Jesus walking on water. And it makes people choose to have the faith and it forces them to have faith and get in that mindset of faith. And then once they accept that one thing that's just like beyond belief, and then they've accepted it and then also taken pride in it, it doesn't matter how bold the claim is. In fact, the bolder the better. The bigger the lie, the harder it is to convince someone it's a lie.
Yeah. Well, I've always been under the impression that rockets don't work in space, and they're using other forms of propulsion once they get into those highly ionized regions, because it could just literally turn on an electric circuit and then put an electric shell, like electrify the outside of your vehicle to an opposing charge, right, and draw yourself to or away from any current that you can see out there. So it could be so easily done with giant balloons that are metallic and things like that, and that all of a sudden they pick up these amazing speeds, and you know what I mean? But it's not because they're being propelled by a rocket. It's static magnetic.
If there is a place called space that has that kind of capacity to go to with plasma the way you're talking about, and that's why I suspect, and to be honest, about your electric universe, being a possible controlled operation, just because it could still explain some of these things happening, and that they'd have to, adopt that to keep their space, really. And it could be that there's an electric flat Earth that they're really hiding with free energy, and that's the reason that they have to push the electric out to the universe and explain it all that way.
Exactly. Yeah, Grim, I think that's at the root of it. Any hiding of the truth.
If they were pushing the electric universe, you might have a point there. But that's something they've been suppressing for the past 100 years. They don't want it to go in that direction. That's the direction where you get.
They're suppressing it because they're hiding free energy. They're hiding free energy that they've stolen from us. And they need the ether. The ether is what allows that to happen. So they also went through great lengths to abolish the ether.
You guys know that all you
from
need
the mainstream understanding.
All you need is a very long metal pole with a spark gap and a current inducer on the top, and you can draw electricity all day long from the atmosphere.
Has anybody done that?
You take a steel, absolutely. You take a steel pole.
But if you're doing it in your backyard, they might actually try to come down on you for it.
You cover the steel pole with a PVC pipe, and then you wrap the PVC pipe with a copper wire all the way up the steel pole. You induce the current gap, the gap at the top or you put a gap at the top and a point, and the point will draw in the electrons. Once they're full on one side, the potential difference from the grounded side will spark a gap from Earth to the tip of the pole, and then it'll just draw a current all the way down, and you can just save it in a battery or a big pool of salt water with coal.
You'd be a good person to ask.
Very absurd. Second of all, have anybody here done that? Anyone? Just one person. Have you done it? Okay. Can you show us?
No, I haven't done it. Here, I can show you how it works.
I want to see somebody using it to
I've heard this too.
Power their home or something.
Yeah, I have a friend that's done it. He's worried about them trying to he said he didn't want to go up too high with it because he thinks that they might see it or be able to detect it if it's too high, but so that you can draw energy. I've also heard Grim, I wonder if you know about this, that I've heard that when you go up the pole, actually, that the even with the power lines, they're not actually attaching directly to the unit, that there's a gap, that it's just drawing from the box, that it's actually not attached directly. You know what I'm saying?
Anyone ever hear that it's the friction of the air over the power lines that makes the power?
Right. You don't actually draw electricity from the wall. You actually use that electricity to make another coil spin and cause electrons to flow in that coil. But they can still meter how much you're doing that. So but it is interesting. You're right.
There's no direct.
It's not like you're actually using it. And
you're drawing from it. So you can actually you could run your own line up to it, not directly plug in, and still get the same power from it.
Well, yeah, but the super trick is that electric that hasn't been turned into heat energy goes back into the wires, and you're neutral. They call it dirty.
And they get it back. Yeah,
they get it ground. Yeah, and it's really a dirty neutral. and then they feed it back to you, the next neighbor, and that's got a bunch of signaled electricity, basically, with a bunch of.
So it's all a free energy unit that they're profiting from, basically.
Yeah. We'll see. What's his name from the Los Alamos Plasma Laboratory? Anthony Peratt. He has a lot of classified work, but he does a lot of plasma stuff that he talks about, right? And a lot of his classified stuff is due to a nuclear relationship with low temperature, low pressure plasma discharges, which is cold fusion technology. That's when you're having not these super high transmutation.
I'm wondering one thing.
It's a super low temperature.
When I search up
science fiction.
Sorry, it's a non-thermal exchange. It is not science fiction.
When I search up atmospheric electricity, I get bombarded with what I search for. Why aren't they censoring this if this is something that they worry about?
It's just like, right? There's the opposite.
Free energy is a very, very small amount of current. It's high voltage, but it's low amp. So you can't do a whole lot with it except charge a battery, trickle charge a battery, basically.
Well,
if you could draw more, if you had something moving around in the sky, drawing more current, or you had more drag, more static electricity drag. But the truth is, it's not really economical to like run a business. Maybe to run some small lights in your house or whatever, but yeah, it just doesn't work out like they say.
And it seems like they do have people out there on purpose making false claims. They have people making false claims on purpose so that people can then write it off when they search for free energy as impossible.
That's what I'm going to touch on right now. That's why I said it's not free energy in the sense that there's an overage, like a perpetual energy machine, or there's some sort of an overage. It's a free energy that you can actually just draw from an external system that exists. It isn't a free energy system. That's the misnomenclature right there. It's still free to us as far as cost wise and no mechanical shit to go on and all that. Free money wise, but I mean, it's not like free. Like there's an overage in a system where you're getting out more than you're putting in. It's just that we're not putting anything into this system because it's a natural system. Therefore,
yes, I was watching Peter and Pete, and they were like talking about this. I don't remember what they said everything, but like they kind of, from what I remember, they kind of like debunked what somebody claimed, one of the more popular videos, at least, about it. I don't remember exactly.
Was it like a magnet wheel or something like that?
If you search up atmospheric electricity, I believe it's the first video that comes up, the one that is 6 years
atmospheric.
old.
Okay. Well,
right the hand. If you're still there, what were you saying before? I think you got interrupted, but you were talking about like being able to collect energy from like a vortex around a wire. Is that what you were saying?
Well, I was saying so again, energy is a conceptual term. Like I think friction, right, is an actual thing. So when you rub two things together, that's your static, right? So everybody, I think, hiding the mechanism in plain sight is one of their ways. So they think they're sending the electricity, quote unquote, over the lines, when really the lines, being this huge, long stretch of wires, gets tons and tons of friction from the air moving and things over it, and that
it draws the current automatically.
Yeah, that's where it comes from. To me, it just seems weird that it would be all generated in one place and then sent out. It would be getting weakened. You would want to get it from where, more evenly and just send it from where it's at.
Yo, that's funny you say that. I just watched a video about misconceptions with electricity. My whole life I thought the electricity travels in the copper wires. It turns out that it's just traveling outside and along it, and there's no electricity inside the copper. Or
I learned that in
Exactly.
school, by the way. I learned that in school.
Field that,
All right, well, I went to American shitty schools. Sorry.
Yeah, like it's a field that surrounds the wire, not the wire itself.
Yeah, the wire just guides it. So the energy is there. The wire's just
track, like a train.
track, exactly.
It's the ion.
you just basically complete the circuit, and that's how you end up tapping into it. Yeah.
Yeah, it's just like when you stick electrolysis of water, but it's electrolysis of air. They just have these long things, and they're doing the same thing.
Yeah, exactly. That's why pink.
The water is not H2O, by the way.
Never mind.
There's also a video about the speed of electricity, and it talks about, you know, if you ran a wire all the way, or, you know, let's say 200 miles down a trail and then around a corner and then come all the way back another 200 miles, and then you had a gap, let's say the switch that you were going to connect it with, let's say the space between the wires was 18 inches, how long would it take when you turn the light on for the electricity to travel all the way through the wire and turn the light and light the light bulb up? Well, the answer is it would take the same speed as it would for the distance between where the switch is and the actual light bulb, regardless of the length of the wire, because it's instantaneous. The electricity is already in the wire.
Well, according to mainstream science, it's not instantaneous. It's like it has to travel from the battery to the light, you know, first, which is the distance, you know.
Mainstream gets everything wrong.
Yeah, sure. But
Yeah, it does,
we are talking about mainstream science now, right now, about electricity. That is mainstream science.
Well, regardless of who
You ever get shocked?
identified
Anyone here
it
get
and
shocked?
called it what it is, electricity exists, right? Even though we can't see it. I mean, we
Well,
know
what
that
is
there's
that's the
something
thing.
there and we're using it for something.
Is electricity exist, or is it, I believe, again, just me, it's the wire moving, right? So the
Well, it
wire
could be the same
moves
thing
and
as
they
light and the
harness that
waves of
motion.
light.
What was that?
I don't see the wire moving.
Hold on,
I know. Touch it though. Touch it. It'll feel like it's moving. That's what I was saying. If you've ever been shocked or tased, it feels like something moving incredibly fast and just ripping at you.
No, it just feels like pain in a weird way. It feels like it's moving my muscles because we are electrical, you know.
No, well, it's moving your muscles. Or if somebody's hand is shaking and you grab their hand, what happens? You start shaking. Now picture somebody's hand is shaking so violently. When you grab it, you're going to shake so violently. Yeah, it makes sense to me.
I have people who are shaking and I have not shaken. That sounds
It
ridiculous.
hurt though. If the shaking is, it's moving like not even millimeters, so like fractions of a millimeter back and forth, vibrating just ever so slightly, but at a ridiculously high speed. If you grab that, it would hurt like a motherfucker, and it wouldn't stop moving either.
It's only
have you guys
60
heard?
times the speed of your heart, though.
Have you heard of a character named Azazel or Beelzebub, the god of friction? You ever heard of this?
Huh? What?
No.
So, any proof of like electricity being something that vibrates very quickly in that way? Like I mean, the wire is moving quickly.
I mean, we're talking about the invisible. This is like, remember that somebody was talking about faith, right? Like the landing on the moon was the faith. Like once you accept something on faith, you know, it's electricity. The mechanism you have to accept on faith. Like we can't see how any of this shit works. Like how does plugging the microwave in make the microwave? We don't know. You can't see that.
Actually, you can see it. It's just you don't see it like in a physical way, but you can still see the effects of it, just like you do when light reacts to with the gases and things like that. I mean, you can see what the effects are. You can't necessarily measure it and the thing itself, but you know what I'm saying?
But you're seeing, like, and this is the problem, right? And then a Christian, right? And you go, oh, you see the effect. A Christian will be like, yeah, you see the effect of God. And you're like, no, 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 no. And then a scientist will be like, no, it's not the effect of God. Look, see the rock drops because of gravity. And the Christians go, no, the rock drops because God made it so, right? So
yeah, it's all conflated.
When you're trying to say, hey, we see an effect.
The rock drops.
Okay, but how do you know what caused it? That's the invisible part.
First of all, real scientists don't claim that it's gravity causing it unless you don't. I mean, it's not based on real science. It's just a theory.
Yeah, a convenient one to support a narrative. And the speed of electricity is the same as the speed of light. So that's probably the constant that we should really be using.
That's scientism, just like with religion.
Yeah,
Those are kind of
and the bold claims
interchangeable.
are to create the faith. That's why the claims are bold and
Yeah, the
unprovable.
same with religion.
Yeah, yeah. Hey, Electric, you said, has anyone heard of it? And your audio was really bad, so that's why nobody heard you. But what was the name you brought up?
The character was supposedly he was the person that brought Jesus to Mary, and his name was Azazel or Beelzebub, and he's considered the god of friction. He's like a little troll, but I have no idea what I'm really talking about at the moment. I just heard of this character. It's supposed to be the god of friction.
That's
That
interesting.
sounds
And he brought the light to Mary. Interesting.
Also,
Yeah,
I
it's in,
believe
it's in the lyrics of,
Jesus is like sun worship type figure.
he's in
Right. Go ahead, Gio.
Bohemian
Go ahead, Gio.
Rhapsody.
Oh, okay.
The
Yeah,
lyric,
Beelzebub.
they say, yeah,
Yeah.
right before the opera breakout part, yeah, or the
Yeah.
the
Has the
rock,
devil
the heavy
put
metal,
aside for me?
yeah, the rock opera style thing, yeah, with the headbanging. Right before that, it's in there.
By the way, did you listen to, did you see I posted the kid, that autistic kid that won America, he did win, by the way. I heard you guys talking about that. The autistic kid that won America's Got Talent, or not America's Got Talent, but it was America's Got Talent. And he was singing Bohemian Rhapsody, but it was coronavirus version. And he's talking about basically he's woke about that, so that's cool. What's his name? You know what I'm talking about, Gio. You posted something from him too. Do you know what I'm talking about right now?
Days ago, yeah, a couple days ago. Yeah, I saw that when you posted. I actually clicked on it. I watched like part of it. I didn't actually.
You should watch the whole thing.
But,
He actually kind of reveals that he knows what's going on in that.
yeah, it seems like the lyrics were kind of like a parody on the whole thing, rather than So yeah, it did seem like he was.
Yeah, but at the end, there's a little bit more of the lyrics kind of talk about it in more in a more a challenging way. I'll repost.
But it would be interesting to see what it sounds like in reverse speech if you like reverse it. Sometimes it's like something is being said in reverse. You can usually do this with like presidents and stuff, like Biden and Trump. They'll say weird stuff in reverse.
Cody Lee is his name.
We were talking about electricity before. Yeah, no, thanks for reposting it. Yeah, I probably will watch I would like to see the whole thing. I think at the time I just wasn't in the mood to keep watching it, but
yeah,
because I watched part of it just to get the gist of it. But yeah, I do want to see.
But by the way, he totally did win, and anybody should watch all of his performances because it's just amazing. Not to change the subject, go ahead with electricity.
Well, there's just something before I was going to say about it, which I don't know why it came back in my mind, but it's just that something like a copper wire, in my understanding, it's as if the copper wire allows that electrical field to be concentrated very close to it and in a very concentrated way where it can then use it as a track to follow. Whereas everything else has such a wide, like the field would be so wide that it wouldn't be able to actually move and be held the way that it does. And so like a wire sort of focuses the field through the metal, the way the metal and the electrostatics and the electromagnetics of that metal are within the environment. It then allows for that field to be pulled like very close to the wire. And then we would say that that wire is then conducting that field because it's so close to the metal. That's why you don't get like shocked if you touch the outside of a wire. So it's not like a huge field. It's not like, feet, like multiple feet in size, like at least not the part of it that's the actual what we call electricity, like what we power things off of. It's actually very like close to the wire. And I was just thinking how the wire kind of like concentrates that.
Copper is very interesting. Have you watched this video? Very interesting. You can like rotate magnets from afar with other magnets if you have copper in between.
Nice. I don't know if I've seen that one. Yeah, I'm gonna check it out.
There are several different things demonstrated there, but like the most interesting thing, in my opinion, was like you could, if you like had a copper plate in between two magnets, and you can have them really far away. If you rotate one of them, the other one will rotate the same way.
That's pretty. Yeah, this looks like a cool video.
Yeah, I think I found it once in Eric Dubé's playlist of his favorite videos or something.
Nice. Yeah, this is cool.
Yeah.
So then, do you think that what people call gravity is actually an electrostatic effect, or what do you think? What do you think on that?
I'm not sure. I've seen some cool stuff about that. Yes, you can like use like what's called like a dielectric type thing, and you can like if you put electricity to it, you would levitate stuff. So you can do that actually. That's pretty interesting. You could like make flying cities and stuff with that. And you can also put electricity to the dielectric, but put it on a wheel. So like you put it on all the parts of the wheel. So when you put electricity to it, the wheel will turn, and the wheel will generate more electricity than you put into the wheel actually. So you get more energy than you put in, which is a free energy machine, but you are drawing it from something else. I can share the video about that too if you want to. It's called electrogravitics because it's not a flat earther who made the video.
Cool.
Want the Odyssey link or the YouTube link?
Oh, just post whatever, whatever you got. Yeah, have you seen how if you hook up a Van de Graaff generator to like two metal plates and you put the plates, let's say a couple inches apart, and you hook a Van de Graaff generator up to both sides, and then which essentially is just pulling static field directly from the environment. It's essentially what a Van de Graaff generator does, because it uses like a belt and it creates friction to then just create a charge. And if you hook it up to two metal plates, you can actually essentially have like a little sheet of paper or something, small. And then once you charge it, that little sheet of paper it'll go from sitting on the bottom plate, like two plates that are kind of parallel, one, under the other. And then once you charge it, that little piece of paper will actually rise, and it'll basically become anti-gravity, and it'll cling upwards to the upper plate. So essentially you're just changing the vector between it being on the bottom plate, and then once you charge it, it can go up to the top plate.
Ah, cool. Yeah, I've seen that on Veritasium, I think.
And then if you turn it off, then it just falls back down.
Yeah, I sent the link now on Odyssey.
So it shows that an electrostatic field directly taken from the environment can change the gravitic direction, if we want to call it that. Gravity really means weight, so I guess it would be the opposite of weight in that case.
Yeah. So like if we didn't have a theory about that, it would like be, I mean, it's like it's interesting that everything falls like down instead of like sideways and not floating and stuff. So yeah, it's like it's something like makes it go in that direction, up and down.
What makes you think that that it would go sideways or go any other direction?
Like I mean, it would make more sense if there was no like force or something, that it would like everything would like float. So yeah, so there's something making it going up and down, because like why is it not going sideways? Because I mean, I'm not making a good argument there, but I mean,
if things went sideways, people would just be like, "Oh, I wonder why they don't go up and down," right? Like it's.
Yeah, I'm saying why is the default like I don't know why we don't go sideways or float or whatever. It doesn't seem to logically follow anything other than because we have some sort of force. So like the people automatically come up with like the reverse of that, which doesn't really make a lot of sense when you think about it. Because how can you think about a construct where there are no laws of physics?
Yeah,
Good
so
point.
it's like makes a lot of sense that you could have it be something electric, because
I
there are
mean,
like different
most
types of
things
electricity.
seem to be electric. Our bodies seem to be full of electricity. You know, our brains. So why not? Why not consider that the universe or the world works just as our bodies? You know, it takes in food or minimums or whatever, and it takes a shit however it does it, and it recycles however it does, just like our bodies. It's just it does it in a much bigger plane.
Yeah, just like there are different types of magnetism, there could also be different types of electricity. Maybe it's magnetism, I guess, but yeah, you have like some kind of polar magnetism, and you have like repulsive magnetism, and some type of magnetism that only attracts. There are probably some others too, but there are like different types of them. You can share that video too if you want, if I have it.
I was just thinking how, like, is there a connection between up and down and the fact that up starts with a U, which is like a horseshoe, kind of like an upside down dome, and then the D is kind of like an upside down dome with a line?
I think I think there's like a dualistic nature to most things, right? Like they have to give us like the left, the right, the up, the down, the negative, the positive, the black, the white.
You have like things that are with three things too, though. Let me think of one. Somebody come up with something. I mean, there definitely are some things.
Somebody come up with something.
Yeah, like there's like some, like instead of duality, it's like three things.
Are you talking about the
you
Trinity
have like
or whatever? The God, the
yeah,
Father, and the Holy Spirit, whatever.
No, you have something. Oh, I had it in my mind. Fuck, forgot. It's later.
Like a trifield?
Yeah, okay, you have you have positive and negative, but you also have like in trigonometry you have sine and cosine, and tangent and cotangent, and secant and cosecant, which is 6, but you use only 3 of them. So that's not duality, it's like reality or something.
But that's
Not
also
everything is.
a system though that man has devised. I'm more or less talking about like things in nature, or at least things that we seem to label, right? Like we seem to label things in nature in like a dualistic kind of way.
Yeah, because it is in this nature, a lot of it is that you have man and female, and you have positive and negative, and you have hot and warm.
We have fire,
I mean,
we have
hot,
water, we
I mean,
have the
hot and
sun,
cold.
we have the moon.
Yeah, but you also have Rahu, and the other one. supposedly, because like the eclipses go backwards.
I mean, Rahu Ketu.
Yeah, supposedly. Yeah, the eclipses go backwards. Supposedly, I haven't actually observed it myself.
Anybody have any idea what's actually going on in the sky?
It's probably like chemtrails and harp installations making it such. I don't know.
No, I don't mean our sky. I mean like whatever the stars or whatever the fuck they claim to be, like what they're actually. I want to know if anybody knows their purpose, like what they're actually doing up there other than just moving around.
I mean, in the astrology, I guess it's like some kind of gives you kind of energies and so whatever. I don't know. I like hard proof. I don't like this stuff. It's cool to like think about and stuff, but like,
how would there ever be any proof like in astrology? Like wouldn't it always just reduce down to observation and like some sort of correlation? Because there would never be like physical proof. Like, for example, I don't know if you heard about the thing about the moon, that supposedly when it's a full moon, the people in the asylum tend to act a little crazier.
yeah, you can. That's evidence if it's true, you know. Yeah. Also, in like in the markets and stuff, if you like trading crypto and stuff, you could like predict stuff based on the moon cycles and stuff.
But what kind of, if it's a true, let's just say in this hypothetical, it's true that when there is a full moon, so-called crazy people tend to act crazier. Would that be considered physical proof?
Yeah, if you can like repeat it a lot of times, you know, that would be proof, I guess. Unless you could disprove it, you know.
But it could, all right, it could, but like, remember, in the hypothetical I said is proven or at least shown that it happens in the majority of the case. But still, even though someone could demonstrate this is happening, I still don't see a way for somebody that opposes the argument to just say, oh, well, that isn't evidence, you know, even though it's very much correlative.
Yeah, correlation does not mean causation necessarily, yes. But if you like repeat it like 1,000 times, maybe a million, I mean it's getting kind of proven at that point, you know. You can kind of prove it, you know.
Well, I
Maybe
didn't
not
believe
really.
I didn't believe in a lot of it, right? Or not necessarily believe. I didn't know about it. I didn't understand it. I still don't. But the more I do research, the more I tend to notice a pattern, right? With some people and their birth, whenever they're like born, like if they're like from April or whatever, they seem to have similar character, similar caricatures about them that is very similar to the people from their month. So there has to be something about it. I mean, it can't just all be woo kind of shit, right? There has to be at least something about it, some truth about it, that whatever's going on in the sky maybe is correlative to whatever's going on with us over here.
Yeah, maybe, yeah. Think I'm going to sleep. It's like 3 a.m.
All right,
All
bro.
right, man. Yeah, have a good night.
Good
Thanks
night.
for the combo.
But so Matrix, yeah. So in that concept, like if the positioning of the sun, moon, and the other wandering luminaries, wandering stars, if those are all timed particularly to various like archetypal structures within humanity, and if they are correlated and timed with their geometric relationships, then at that point, would that not be, in a sense, like an ultimate evidence for a creator? Because it not only had to create this whole world, but it had to perfectly time and sync up the sky to all the events happening on the actual Earth itself, with those actual like frequency movements that are all just in their own cycles.
Well, that's what I'm saying. Like, even if this is shown to be evidence, I don't see how the opposition could use this and say that this isn't sufficient evidence. And if they could say that, right, what would be sufficient evidence?
Well, I mean, all we can get is positions in the sky, so like of these things, so we can only get their relationship, and then look at the correlations, as it were, on the Earth, and that can be statistically done, and can be done in a way that is very rigorous. Like, for example, like the Mercury retrograde cycle. Mercury goes retrograde 3 times a year, and each time it lasts for 3 weeks. So it's like a 3-week long process. And since Mercury is connected to like communication, everything having to do with communication, short-term, quick back and forth communication. And so computers and electronics essentially are that on a core level, because it's all these communication interchanges, synapses between the circuits and between everything to make electronics like that work. So during Mercury retrograde cycles, there's a much greater statistical probability of computers going down, hard drives breaking, huge server systems going down, those kinds of issues with computers where it's like, you don't even know why it's happening. It almost seems like it's like just not even explainable in terms of why like your hard drive just dies right at that time or something goes out in that sense. And so under Mercury retrograde cycles, there's a much higher number of that happening. So if you then statistically rigorously did that, like took very detailed tests around the whole world of how many computers and servers and systems are going down during that period, and if you were able to see an exact correlation with it, would that to you prove that it is actually correlated and that it is actually connected?
See, it would be good evidence, right? It would be good evidence, but again, my whole thing is, if somebody asks for like physical proof, right? Like would that be considered physical, like the correlation? Because for somebody to notice a correlation, you would have to study it, right? Observe it for a while in order to be able to confirm the correlation, right? But for the person that's going to accept that data, they will also have to assess the data and possibly recreate the data. And I find it that it's just easier to say, oh no, that's bullshit.
Well, yeah, I mean, it does. The mainstream heliocentric model purposefully ejected astrology out of it. I mean, they literally, because astronomy and astrology were always one, meaning that people were just looking at the stars and the wandering stars, luminaries, all of them, and just observing their positions, and then realizing, oh wow, when those two come into conjunction, this happens. When these are in 180 degrees from each other, that happens. Eclipses, like all of those factors. And so, I mean, they were one science originally for really forever. That's always what they were. And then in this mainstream modern paradigm, this kind of Newtonian Cartesian thing that we're in, my understanding of it is essentially they split the two. They called astrology a pseudoscience and made a whole bunch of fake stuff and fake like news articles and all kinds of stuff to try to discredit it. Like even the newspaper horoscopes are like a psyop designed to discredit it on a mass scale. And then they claim that astronomy is still legit, but then they say that it's, outer space and, stars the light years away. And then they add that whole thing to it. So yeah, they've definitely like eliminated astrology and tried to call it a pseudoscience and try to throw it under the bus as much as they could.
I think they did what you just explained with, between the astrology and astronomy. I think because I've noticed a pattern with these people, right? I call them the invisible enemy, the infiltrators, right? They have a pattern of things that they go in to, let's say, a republic, and they tend to replicate the functions of that republic, but they tend to write, let's say, like the laws, right? Like if the Republic has a constitution, they tend to duplicate that constitution, change a little bit of the words, which would change the connotation of the entire document, right? So while you think that you're reading a document that belongs to this republic, it's a completely new document. So what I think happened between astronomy and astrology, there was already one of them was already established, and they came up with something else simply to usurp it and say your methodology of looking at the sky is bullshit. Here we come with our intellectual bullshit and nonsense that we accept, right? And since they're the most pushed, the people will accept it more.
Yeah, for sure. They've definitely made up a very fanciful story about the sky and called it heliocentrism. And it's kind of funny to think that the entire heliocentric, all of those theories, it's all just a very fancy, kind of clever philosophy about what the sky's doing.
I realized that right away. It wasn't really like, I find it astounding how people are still arguing. Like in like half of the year when this shit really hit off, when this shit started, I realized that this was nothing more than philosophy. That you can't truly prove any of it. Any of it. It is really just hearsay and authority and like following authority.
In that mainstream model, yeah, because they're the ones that are claiming to be in the outer space. Yeah, the rest of us are not. So it's like a party that we're just not even privy to, and they're just convincing us exists. It's weird. On that level, it's very bizarre. It's like, hey, there's this place, and we're exploring it, and we're gonna get you all to believe that it exists.
I find it brilliant. I'm past being offended already, bro. I find it brilliant. I find it like whoever the fuck is doing these tricks, these are very intelligent people, right? Because to come up with a scheme to have half of the population, not half, more than half. I would say like 70-80% of the people believe the fucking globe lie, bro. So to convince more than half of the population, bro, I mean, I don't think any regular person could do that. There has to be highly intelligent, high up people, you know?
Yep, exactly. So these people have been figuring out how to manipulate mankind for thousands of years.
I would say since the beginning of time, these people, whoever they are, right? Whoever these people are, they have been taking notes, right? Every time a civilization falls, Rome and the Greeks, they take notes. Let's not do this anymore because look what happened last time, and they keep improving and improving and improving. Whoever the fuck they are, they're definitely taking notes and fixing, you know, whatever little problems comes around in whatever decade or whatever.
I call that shit the science of fear. They're just taking advantage of our reactions. So
yeah, like Matrix. Yeah, like I was saying before, I used the word clever, and because I mean, it is like the way that like evil is clever. Like there is kind of an intelligence to it in a way, but it's also really not that big of a feat because they use world wars to do it, and who knows what other great resets and all kinds of stuff. So when you use just like mass genocide, it's not really that highly skilled. You know, it's just a dark enough act that you're able to, they've been able to, because once those like world wars happened and all that happened, you know, they're the ones who are then controlling the education. At that point, you're getting children when they're young. So it's kind of a low blow what they're doing, you know, like it's not really that high a level of a thing. Like I understand the idea of like high level criminals doing stuff. And obviously they do have a pretty, you know, they do have a certain level of like criminal intelligence to pull off this stuff, 9/11 and all this stuff. But at the same time, they seem to like trip up a lot, and they don't really seem to be like, they're not amongst the smartest people on earth. That's for sure. Like they're maybe in like the 70th percentile at the top, but
they're not. How would you think they've gotten to the position that they've gotten and maintained that position to the point that some of them rebuild civilizations after they self-destruct? Like, how would you do you know anybody that has ever rebuilt a civilization?
I think that's a lie. I think they've just been killing civilizations, and that nobody truly had to be rebuilt. They just been exterminated.
But would you say that maybe hypothetically speaking, do they think that they're like ordained by God to doing whatever they're doing? Like in our view, we
They're
view them as
ordained by
evil.
El. They're ordained by El and Moloch and Baal. These people worship a serpent.
Okay, but all right, but if that might be true, but is it possible that then the serpent might be the good God and the whatever God we worship might not be the good God because they seem to be winning? We seem to be at the rear end of whatever shaft they decide to throw at us. And I'm gonna tell you the truth. We are the public, right? I doubt very much that anything that we believe or any kind of knowledge that we could find out would be superior than anything they could find out, because they could literally, if they wanted to find out anything about Egypt, they could just go to Egypt, interview literally everyone, document that, and they could do that because they could afford it. We couldn't be able to do that, right? All we could do is research whatever anybody else has done.
You know, according to them, Egypt came up out of the sand. Like they didn't even know it was there.
No, that's not the point. Egypt, it could have been anywhere. The problem, what I'm trying to say, is that they have the resources to find at least more truth than we do. Most of us just have the internet.
Didn't the serpent in the Bible symbolize knowledge?
Yep.
And also
the sine wave.
The serpent never lied. The serpent did not tell a lie. The way they made it seem in the Bible was like he was a liar, but he never lied.
Well, I think like the archetype of the serpent has like certain positive expressions and certain negatives. Like there's definitely a negative of like the, the snake and sort of just deception. There's a connection to that. But yeah, like SC's saying, there's also these very positive, like the idea of like animals having like a spirit animal. So each, like a spirit animal has like, essentially that an animal has a spirit to it and represents certain things like knowledge or wisdom or patience, these different components. So like in that way, the snake does have a lot of positive expressions that come through.
Yeah, like why would God want to keep information from man? Ever ask yourself that?
Either protect man or to protect himself from man.
And why did he punish man as soon as he got this knowledge?
Most likely fear. Because they said, you shall be as one of us.
But what was the fault of man? It wasn't the fault of man. It was given information, right?
The fault of man, or at least Adam, was that he didn't hold frame with Eve, and she did whatever she destroyed paradise essentially because she was bored. So Adam failed in not controlling his house. His house was not in order.
But
in that story, it's not really a fault. It's only a disobedience. That's all in that story they're being punished for.
Exactly.
Right.
Right.
It's not a bad or a good thing. It's just disobeying commands you've been ordered to follow, or else.
Yeah, not to learn stuff. The command was you cannot learn certain stuff. Correct? The snake had knowledge that we were not supposed to be given. Correct? I mean, correct me if I'm wrong. I'm just, the way I see it, I could be wrong.
I don't know. All right, because you say it's knowledge that but we would have got the knowledge eventually over time we evolve and adapt and create technology. We would have been.
Not this knowledge. This knowledge was a God knowledge. Like the serpent was the devil, another angel, right? So this was higher, supposedly, knowledge than we would ever be able to attain on our own, I would imagine. Coming from a God, from an angel. I'm just saying, guys, I don't know, I mean, I'm not an authority. I'm just saying, like, why would God not want you to have certain knowledge? Or this God, anyways, that they believe in? Why?
Well, I'm gonna answer that question in the form of a question. If you had slaves, hypothetically speaking, would you educate them?
Now you're talking. So this God is not benevolent, right? He regards us as something that is below him, and or as a slave, like you're saying, and to not to give us certain knowledge. You think it's because of fear, Matrix?
Possibly it could be fear.
Yeah.
I could even begin to understand whatever this God is supposedly thinking, if he does think, right? One could only assume.
Yeah, I find that part fascinating. Like, why would the Creator, God, in the Bible, why would he not want you to have this certain knowledge? Why? Was the knowledge evil?
This is my way of justifying it, right? This is my way of justifying it. If I was like some sort of Christian apologist, I could say that God didn't want Adam and Eve to ascertain that knowledge at that time because the creation was so early on. That knowledge would have interrupted the natural order of how God most likely planned his creation to go the second time around, because he did say replenish the earth, which means I fucked up the first time, do it again the second time, guys.
Okay, then why did he not prevent the snake from giving this knowledge then? If God is all powerful.
That's a very interesting question.
None of it makes sense, man. None of it makes sense, yeah.
Yeah, that's why I'm convinced the stories in the Bible have nothing to do with God, Jesus, and everything to do with teaching us how to deal with reality, with the system. I don't think we're supposed to focus on Paul, on Christ, on fucking Mary, on Joseph, and whoever the fuck. I think these people are like, they're like stories. They're like allegorical stories. So we can understand whenever we're presented with a situation that we had to interact with, the government or whatever the fuck.
I don't know, it's crazy stuff.
I 100% agree with you, bro. I really do.
If you guys are into a change of topic, the reason I came in because I heard something weird the other day. But if you guys want to continue on this, I'll hold back.
No, go ahead, man. Just whatever flows.
Cool. I heard this the other day, Gio, and I was like, kind of threw me off. I go, what? Somebody said, I can't remember who it was. It wasn't here, though. Somebody said that gravity is geometry. Did I hear that correctly, or was I hallucinating?
Yeah, I was there for that. And then I asked him what mathematical equation in geometry can be created that would equate to a force of gravity. And he just didn't answer.
But you remember who it was, bro, that said it?
Probably Brenda. Brenda's the one that usually says ridiculous shit like that.
No, it wasn't Brenda. No, it wasn't Brenda. I wouldn't even brought it up if it was Brenda. Brenda's useless. So nobody remembers, huh? Okay, it doesn't matter. I just found that weird, and I
don't remember the guy's name, but I do remember what you're talking about. Yeah.
Was it possibly Nate?
It could have been Nate. Yeah, could have been Nate.
Was he describing geodesics?
I'm not sure, Coach. I can't remember who it was, but I found that really first time I heard that.
Kosho's been having to what's the right term for it? Speak for Nate lately a lot, it seems. Like Nate says stuff and then Kosho comes in.
No, he's lawyering for Kosho? I mean, for Nate?
I think Kosho is Nate's lawyer, maybe.
I think this is the same. I think they were talking about this yesterday. He was talking about how we were They were saying this yesterday. I was trying
So
to.
do you remember?
I wasn't
Do you
there when he
remember
said
any?
it. I wasn't there.
Do you remember anything of it?
I wasn't there whenever the original conversation happened. I just tried to, possibly reiterate whatever, maybe what he was actually talking about, because geodesics, like a straight line is a geodesic. You know that? It's just a geodesic in Euclidean geometry, a Euclidean surface. The geodesic is the straightest path between 2 points.
But a geodesic is a curved path on the Earth. Wouldn't a straight line be going straight through the Earth?
No, it's a straight line along the surface of the Earth.
So by straight, you mean going in a direction with as little deviation as possible. I guess the question is, how is your path being deviated? Is it being deviated by the shape of the Earth or by some other force? It's hard to know that without, knowing exactly what shape you're on, isn't it?
Deviation is not the question. Is what is the shortest distance path?
Because a straight path is meaningless unless you talk about what, if anything, is deviating the path from a direct line of travel. And even on a geodesic like the Earth, a straighter path would be straight through the Earth as a chord, wouldn't it?
Straight path, the shortest distance between 2 points on Earth in 3D space would go through the Earth. But the shortest path between 2 points along the surface of the Earth is a great circle around the Earth.
Not a straight line.
Well, yeah, it depends on the shape. If the Earth were flat, it'd be a straight line. If it were a non-Euclidean surface, it would be some sort of curved line. Geodesic.
Well, you could take curved paths even on a flat surface if you're following, say, a jet stream. It looks like when you plant the wind patterns on a flattish AE map conception, they make concentric circles around the North Pole. So you may be going in a curved path because of a jet stream kind of knocking you off of straight or something like that. But that doesn't necessarily mean it's a ball. You're just kind of curving a little, with the jet stream.
Yeah, perhaps. But, so the geodesic on the surface of the Earth would be a great circle, and the flat plane would be a straight line. And in the sense of space-time, Einstein's space-time, he describes objects as traveling along geodesics in space-time, so straight paths. Those straight paths tend to be curved if there's mass sort of space-time.
What about a flat plane?
That's ridiculous, man.
Let's say you had a flat plane on the ball Earth. Then what? Which one is it? So you have a flat plane, but it's on the ball Earth. So you go straight with no deviation. Is that a geodesic because you're going along the surface, or is it a straight because you're not?
Like a plateau on the globe geodesic. How would you deal with that?
Yeah. So you're going along the surface of the Earth, but the surface of the Earth is flat, and that in that area. So is that a geodesic curved, or is that straight?
Plateaus aren't perfectly flat. They follow the curvature of the Earth. It's like a lake would.
So that would be a straight path, right? Without avoiding the question and just redefining terms.
No, I don't call it a straight path. I call geodesics, and I say a straight path is a geodesic, but I don't call great circles straight paths.
Because I'd call that a straight path. It seems like otherwise these terms are meaningless. If you're on a plateau going along the surface and it's perfectly flat, like a flat top on somebody's, curved head or whatever, it would be flat, just like, right the hand appears to be implying. And so otherwise these terms are meaningless, curved path, straight path, or whatever, unless there's a distinction between one and or the other, geodesic or not.
All right,
He just told us that in space, a geodesic is a straight line, but it's actually a curve.
No, what it says a straight line is a geodesic. Path. If you're on a curved surface, the geodesic is actually a curved line. It's still the shortest point, the path between 2 points.
So how about on a flat surface? What's a straight line?
Straight line. Yeah.
Sorry?
On a flat surface, it's a straight line.
But you just said before it's not.
No, I said that a plateau is not a flat surface.
A
It's a level.
plateau is not a flat surface, then a plateau is curved.
It follows the curvature of the Earth.
I think when you're trying to preserve this definition of what's happening on a ball, we might be getting a little ridiculous. If a plateau is effectively curving, how are we going to know that? I think most people intuit and rightly, say that a plateau is flat, not going around the curvature of the Earth.
Yeah, they'll say they'll call it flat, but it's just like water.
Etymologically, plateau is linked to the word flat very intimately. It's a plateau. I mean, it's pretty obvious to see when you look at it.
Could there not be a flat spot on the ball? Is that what you're saying? That even the flat spots on the ball curve with the ball? That's
Well, sure. But let's say like the flat plains, or what are they called? Like the Bolivian flats. They seem to be flat, but really what they mean is it's level. There's very little elevation change, but they follow the curvature of the Earth.
I get that, but let's say there was no, it was flat, like a piece of glass. Could you have, like, in your mind, can you fathom that there could be a part of the Earth, whether it's a ball or whatever shape, that is completely flat, like really flat?
There are some spots. We've constructed them, but they do exist.
Okay, so say you walk one of those. Is that a geodesic or a straight line?
If you walk one of those, you'll be walking a straight path.
But it's the surface of the Earth.
Not geodesic.
But wouldn't it be the surface of the Earth? So it'd be a geodesic.
No, it would have to curve. It would have to cut into the Earth.
Well, there is a flat line even in your geodesic. I mean, to get the radius, the sphericity, and the curved surface area of your geodesic, what did we have to use? A straight line that theoretically went from the center of the object outward. So since we need a straight line anyway, even for this geodesic conception, why don't we preserve that definition intact so that we don't have equivocation with a difference between a straight line on the geodesic versus, say, a curved one? Why don't we preserve the definition instead of trying to marry it and ultimately eradicate the straight line definition that we're used to? Even when you need a radius that is a straight line for your geodesic to even be a thing, I don't understand this attempt to try to get rid of a straight line as a straight line with a mangled definition when you still need a straight line radius for your geodesic. That doesn't make any sense.
Well, what you just said didn't make sense. That's correct. But a geodesic has nothing to do with the radius. The radius is the center point of the circle to the outer part of the circle. But it has nothing to do with the surface. A geodesic
You wouldn't be
along
able to make the geodesic without a straight line radius. So why not preserve the straight line definition?
There's no rules. There's no difference in the definition. The definition for straight line is still a straight line. A straight line is a geodesic. That doesn't mean that a geodesic is always a straight line.
Wow, that's
no stormtrooper.
Brain part.
Definitions.
You can't have A be B, but B not be A, dude. You're totally backwards. You're saying it's straight. A straight is a geodesic, but a geodesic isn't straight. Well, then a straight isn't a geodesic. If it doesn't go one way, they got to go both ways. A straight is a geodesic, and a geodesic is straight, or geodesic is not straight, and geodesics are not straight.
It's like saying squares. Squares are rectangles, but rectangles are not squares.
No, a rectangle is not a rectangle. A rectangle is not a square. They're two completely different things.
No, it's not. A square is a rectangle.
No, it's not a square. It's a square. That's why you say square, not rectangle. If I was like, get me a square, and you came back with a rectangle, I would be like, why did you bring me a rectangle?
Because rectangles aren't squares. Yeah, rectangles aren't squares. I said make a rectangle and make a square. Fine.
Check it out. So C and G are similarly designed letters for a reason. They're closely phonetically linked, and so rect is actually right, and so a rectangle is a right angle shape. And so anything composed of only right angles is a rectangle. Squares happen to only be made out of right angles, so they qualify. Squares are rectangles.
No, you understand they're two completely different shapes. right?
No.
Yeah.
Okay,
Composed
so
of 90-degree angles is the definition of what a rectangle is.
when you have two completely different things, right? A straight line and a curved line, you need two completely different words. You don't just take one word. Hey, we got these two separate things. Yeah, just use straight. But then how do I know which one I'm talking about? Don't worry, we like it confusing. Hey, I got this thing. One's a square, one's a rectangle. What word do I use? Just use square. But then how do I know which one? Doesn't matter. This is you're being just ridiculous, bro. This is just ridiculous.
Well, so I think what he's implying is that there's an overarching definition that includes both squares and rectangles. As long as they have right angles, there's a looser definition that can include both square and rectangles. But when we say square, we're being much more specific, not just for right angles, but all sides are equal. So there appears to be an overarching definition that both of them kind of meet. If you're just saying a rectangle, it's 4 right angles.
Language is made for less confusion. If everybody was pointing and grunting, it would be very confusing. That's why we have language, so we can identify unique objects. You're defeating the whole purpose of
there's
this.
There's different uses. You know, some words are useful in a generic sense, and some words are useful in a specific sense. A square is a specific word. A rectangle is not a specific word, but they both have their uses to make things easy on us.
Well, some words are used for deception. And so we need to see, okay, what deception or equivocation is going here. We're kind of trying to make, geodesic straight paths as long as there's no deviation along the surface. But the question is, how do you know how you're deviating along the surface? You could be going in this curve or that curve. It would have to look straight from space when you're looking at it from profile view, so that looking downward, it looks straight. That appears to be the only way to say that, quote unquote, you're going in a straight line on a curved surface. But how is that possible?
It's not.
It's a very theoretical. I mean, and since it's theoretical, how does this match reality? Without something to ground it, to base it in reality. Show me a geodesic. Show me a straight line that's actually curved on the surface straight from space. Unless you can show me that, what is grounding this theoretical assumption, especially when we're trying to find the shape of the universe?
Maybe obstruction.
They have to curve the straight line in order for their fantasy sphere to work. They have to get rid of the horizontal. The horizontal has to go.
They need to show that the curvature of the Earth is deviating from a straight standard. They have not done that. They look through a theodolite, assume that the horizon was forming as a hump of Earth curve is the only explanation. There's another explanation they need to explore. The ground and the floor meeting, just like looking down a really long extended hallway, and a horizon forming in the foreground over a flat surface with no obstruction in the way, while taller objects disappear to set bottom first optically in the background.
Yeah, so just make up physics.
Just use reason. Now, you may not be willing to use your reason, Lewis, and be ready for heliocentric globe programming, and that's your prerogative. But I did that for years, and I'm not doing it anymore.
Yeah, but you need to demonstrate that. I mean, you can explain it very nicely, Lemon, but you need to show how that works.
Life is Short already
You're not
did
going to
it.
demonstrate
I
orbit.
talked about his video several times. Am I speaking another language? Life is Short's video. I'm sure it hasn't been buried in the YouTube feed yet. Life is Short's video. I'll put it in the chat. Make sure to fast forward to 1 hour and 45 minutes when he explains this very concept as to why things like the sun and other objects disappear bottom first over a flat plane.
If the Earth's a sphere, you don't have to explain it.
Yeah, you do. Because there's nobody looks at a sunset over the horizon and goes, ball, right? Because that's not a ball. This is what you need to explain that. You need to go, first you have to explain why the sun looks like it's moving when it's not, right? That's the first thing you got to start explaining. You're like, hey, I saw the sun move. No. That's not the sun moving. Wait, what do you mean? So don't give me this bullshit you don't need to explain. You definitely need to fucking explain.
If the Earth's a sphere, there's no mystery.
If it's not moving, you got to move the sphere. Okay, remember heliocentrism? You got geocentrism. So you need to start explaining why it's heliocentrism and not geocentrism. That's just giving you the ball, bro. So don't come in with this, heliocentrism needs no explaining, like you have the truth. You don't. You have a personal belief, and that's it.
I put it in the chat. fast forward to an hour and 45 minutes, cake platter, it's all there. If you're not willing to make the interpretation about the implications of what Life is Short is showing you, fine, that's your problem, but it's right there. An hour 30 to hour 45 minutes, he goes over the main explanation.
Hey, by the way, Lemon, just so you know, if you're watching a YouTube video and you right-click on it,
If you right click on it and then you fade it out.
no. What
I
I
can
was going
hear
to
you
say,
now.
so I was going to say you can right-click on it, and then there's an option to copy the link at the time. That way you don't have to actually, it will start the video at the 145 minute, at the 145 mark.
Excellent. Boomer tech skills have improved. Basically, if you're looking out over a surface, things will begin to merge with said surface, whether they're sticking up out of the surface like a tree or hovering above the surface like the 32-mile in diameter sun. It's just a law of perspective. The narrow viewing angle will make a horizon form in the foreground since you're too close to the ground, and anything beyond that will appear to set bottom first. It's just perspective.
Yeah, this is made up.
It's just logic and reason.
No, it's not.
You're waiting for additional programming. This is the bureaucratic fallacy. You don't feel comfortable stepping out on your own and independently thinking, so you're going to stall and waste time until an approved authority tells you what to do. This is the bureaucratic fallacy.
You're saying a two-dimensional plane makes something above it disappear.
Yeah, a horizon forms in the foreground, Lewis, yes.
Yeah, you're making that up.
That's just what happens. You're going to get a horizon forming based off of your height, Lewis.
Or maybe because the Earth's a sphere.
Well, Lewis, when you're driving down the road, at some point when you're really far away, you can't see like a stoplight, like a red light. And then at some point, it's invisible. And then at some point you start to see it on the horizon. And then as you keep driving towards it, it will rise. And then when it's right above you, it's like if you look through the sunroof, it'd be right above you. And then it would then set all the way behind you. Would you agree? By the way, what's up, Lewis? Good. I was sitting here doing some stuff, and I was like, "Is that Lewis?" I hear. So yeah, what's up, man? Just wanted to say hi.
Nice. Yeah. Hey. Well, the stoplight sure does. It's obstructed, and then it's not.
Yeah. And that would happen. I mean, even if you measured it perfectly level all the way along, it would still do that.
No, it wouldn't.
You wouldn't be able to see there's only so much visual area that we can see things. So when you start looking out, even if it's a flat plane, you can't see the entire world. Some shit just won't be into view. Some shit will. And there's going to be a fade between as you get further away where the stuff you can see and the stuff you can't. Like, I don't see why this is such a big, to me, I'm like, okay, that's just,
Yeah, a 6-foot object will disappear due to perspective, just like a 6-foot pole or a 6-foot, person will disappear at a vanishing point. Space that you're looking out through, the air, the space that you're looking through is going to be the same. If you're looking through a 6-foot zone of air or visual space, it will reach a vanishing point. And any part of the object that is in that part of space will appear to disappear. And anything that's taller than 6 feet at that point will still be visible above that vanishing point. But from then on, it will disappear bottom up. The logic is right there in sound. There's no problem with the logic as far as I can see.
Yeah, there is. There's tons of problems with it.
So many that you can't vocalize them? That you can't give a logical, rational refutation, or what?
Yeah, you're just flatly asserting that something that is in your line of sight becomes unresolvable for no particular reason. It's just arbitrarily defined that way.
Because things reach a vanishing point.
Right, you've just
Are you
defined
challenging the notion that 6-foot objects or 6-foot zones of visual space will reach a vanishing point?
No, they'll reach a point where they can no longer be resolved.
Yeah, the vanishing point. So what do you do with the rest of the object that's taller than the 6-foot zone of space? It just disappears automatically, or what?
Something that can't be resolved can be brought back in with higher resolution.
Yeah, but optics are limited in what they can resolve. Basically, when
Yeah.
you're zooming in, you're trying to take an angle of light and make it wide enough so that you can make out the object. But if the angle is too narrow, I'm sorry, the best optic isn't going to bring it back. It just doesn't have the resolving power.
If you have sufficient resolution, you can bring any object into view. What happens at the horizon is not a resolution problem, it's an obstruction problem, and you're making up physics to explain that away.
I got
The
to disagree
angle at
there,
the
man.
horizon is too narrow.
Because you're getting into there is an infinite almost amount of information, like everything that we can see in a finite area that we can see it, right? Like you can't see everything in only a portion of the looking. It's just there's got to be a limit, and that limit is where things just disappear. And just I know you want to believe it's because the Earth is a ball, but it's just because you can't fit the entirety of Earth's stuff that you can see in just your field of view.
Well, we see in 2D, gentlemen, which means we represent objects moving left and right, up and down, whenever they get further away from us, whenever they shift in our view, et cetera, et cetera, et cetera. So how are you going to process an image that is really tall, that needs to go to a further vanishing point than, say, the 6-foot zone of visual space you have in the foreground that vanishes much sooner? As we know, further objects need a vanishing point that's further than what the eye can accommodate. So in the foreground will predominate the vanishing point for 6 feet objects, aka the horizon at 6 feet, and the eye will represent stuff that's taller, seeming to go below what's happening in the foreground, going to its true vanishing point in the distance. It will represent that as the object continuing to descend behind the vanishing points that happen in the foreground to maintain some level of symmetry. That's just the 2D nature of the eye. To represent how a 10,000 foot mountain needs a further vanishing point than what the eye can afford at 6 feet of elevation above the ground, a 6-foot vanishing point forms in the foreground, in the front, and the object appears to continue to set and go to a true vanishing point in the background. It's just that simple.
Yeah, it's just that made up.
So you can do bureaucratic fallacy and say,
I'm so
shut up,
glad
stop
Lewis is
thinking.
here. I've learned so much.
Well, he's doing the bureaucratic fallacy and basically saying shut up and wait for somebody else to think for you. I did that for years of heliocentrism, Lewis. Not anymore.
Yeah, I mean, Lewis, what do you think what are you trying to say is made up in particular? Could you be more detailed? Because could you actually be specific in what you're referring to?
Yeah, he's saying that there is something about the horizon that is following different rules for light, so that as the angle of something approaches the angle to the horizon, it just naturally disappears into a vanishing point. He's just made that up. There's no reason to believe that at all.
Well, there definitely is, because the distance of the object in relation to the distance you can see on the Earth is going to basically determine whether one sinks into the other, because there's a limited angle and there's a convergence point.
Yeah, but why would it actually appear to be obstructed by it at all? Why would that happen?
As those two objects are moving away from you, there's a midpoint, which we could call the horizon, where they're intersecting. So depending on how far you can see each one, there's going to be a ratio as to which one visually is going to start converging and not being visible, because there's a limited space there.
Yeah, they're both just going to converge to the same point. One isn't going to appear to be behind the other.
That's illogical, Lewis, because smaller objects reach a vanishing point sooner than taller objects. So you're saying that they reach the same point as if they're basically the same object. That's not true. Smaller objects like your 6-foot visual zone, based off you being 6 feet off the ground, will reach a vanishing point first. And that vanishing point in the foreground will cover over the vanishing points in the background, just like holding a penny in front of a car. So how do you deal with taller objects that need a further vanishing point than what the foreground can afford, Lewis? You have those objects fade bottom first into the background.
How do I deal with it? It's because the Earth is a sphere. It doesn't need to be dealt with.
A sphere without curvature. A sphere without movement, since you guys also invoke a moving, rotating ball.
Who sent you over here? Somebody had to send you here just to say Earth is sphere. Hey, like, I can't see that thing. Earth is sphere. Hey, look at that thing. Earth is sphere.
With a flat horizon, with nothing but barrel distorted CGI from NASA to prove it.
I can't see the
Hey, you
dollars.
made that up.
The sphere.
Earth is sphere. What did you
Nothing
say?
to
Earth
prove
is
it.
sphere.
So.
Oh, you just made that up. Earth is
So
sphere.
Lewis, the main thing is the vanishing points in the foreground appear to obstruct what's happening in the background, just like holding a penny in front of a car. That's basically it.
Yeah, you know what the penny's doing?
What?
Earth is a sphere.
It's physically
Hiding a
blocking
sphere?
your line of sight.
But it's not really physically blocking it because you put the penny next to the card and you see that the penny is way smaller than the card and is not truly offering real obstruction. It's offering optical obstruction, but truly there's nothing really in front of the car in that sense where it's the same size object and blocking, say, everything coming from the car.
Well, if the penny's blocking the entire line of sight to your eye, then yes, it is.
Okay, then effectively, the vanishing point and the objects of a certain size at the horizon is quote unquote what? Blocking visually the light coming from other objects that are at the same angle. Same principle. Even though there's physically no obstruction, if it's at the right angle, it will seem to obstruct what? The light rays that are coming in at a certain angle.
No, there is literally physical obstruction, Lemon.
No, it's optical. If you use a laser, you cut through this Earth curvature and see that it's not there. It is simply the way that the eye processes the image.
What?
You see that there is no hump of Earth curve in the way with a laser.
That's not true.
There's like a big difference between something not being able to disappear on a horizontal surface, and I believe something can't disappear on a horizontal surface. Those are two separate.
Well, I'm just telling you, one explanation makes sense and the other one is made up.
Well, makes sense, right? Like a floating ball doesn't make sense to me. So that's relative.
Well, a curved surface blocking something does. So there you go.
Yeah, but you're like forgetting Epstein's list, right? Like you got the plane, you got Epstein, but what about the list, right? So like when you say curved surface, it's like Genie in the lamp, right? You got to take everything that goes along with it. So if it was just curved surface, like a hill, I'd be like, yeah, that makes sense. But then you're like, oh yeah, it's like a hill, but the hill just wraps all the way around yourself and you're floating in nothing. I'd be like, okay, you lost me.
Yeah, the truth is a package, and if a lot of baggage comes with this package of this globe Earth movement when I don't feel it with my feet, it's going to tend to be rejected.
Hey, Gio. Are you there? You must have took a break.
So I think we have.
I'm here. What's up, Sean?
I'm getting ready to prove Earth is sphere. Are you ready? I'm getting ready to push the blue arrow to post something in chat. You ready? Here we go.
Is this going to do it?
This will do it.
Well, Lewis, I think the main thing that we can get out of this discussion, globe zealot, flat zealot or not, is the two ways to look at obstruction. It could be physical, like a hump of Earth curve is in the way, or it could be simply optical, where the floor ramps up, the ceiling ramps down, a horizon forms in the foreground, and anything that's too tall in the background just has to set and go to a further vanishing point than what the eye can process in the foreground.
Yeah, it makes no sense, dude.
Yeah, neither do you. Okay, Gio, do you like what I posted?
What is it, Bigfoot, or I can't tell what it is?
All right, I'm in my yard, so this didn't really take much effort. The first one is a red arrow pointing to a signpost. You barely see it. Then I got up out of my chair and took a picture again, and now you can see the diamond shape. And then I took about, I don't know, maybe 10 steps to my right. Well, straight forward, actually. And look at all that shit that came into view. Earth's a sphere.
Nothing disappears bottom up on a flat surface. Okay, what if I'm staring at something and then just start crouching down and then get my head to the bottom of the floor? Yeah, it would do the same thing, right? So
You'd have to get something physically between your eye and the object you're looking at. So if the floor does that, it means the floor isn't actually flat.
I think you're assuming this axiomatically, but you're not looking into other alternatives. It looks like what? A wall of light in the foreground appears to be obstructing this in the background.
I'm going to hold my phone eye level with the taco sign. It says 100% beef tacos. If I duck down, the object is gone. That doesn't mean there's a curve between me and the eye level.
Yeah, you see it with rainbows. Rainbows are hula hoop bands of circle that are held above the ground and appear to be suspended in midair. But if you get close enough to the ground, it takes on the aspect of an arch that's cut off bottom first. It's right there. Unless you're going to say that the curvature of the Earth rises up and obstructs the rainbow, it appears that compressed viewing angle relative to your height above the surface is cutting off the bottom of the rainbow as it goes away over the surface in the distance.
It's pretty much trying to prove that every time you move, the ground moves as well.
Yeah. And the sun, moon, and stars would be no different. So the obvious implications is that possibly the sun, moon, and stars, the rainbow, and other phenomena are circling over a flat surface and merging with the ground due to perspective, not because there's a hump of Earth curve in the way.
Yeah, like there's two things that could cause obstruction. Like you could have elevation that causes obstruction. Like you're at a lower elevation, like let's say than a mountain. And so the mountain could obstruct something, but that even in the globe Earth model, they wouldn't say that's necessarily the curve of the Earth. They would also agree that that's just the mountain, because of elevation. But I'm just saying in reality, there's two main things that can obstruct something. It would be elevation changes and obstruction from that. Or if you're on water that's completely level going out, then you're going to get the effect based on the status of the environment, like how far you can see, the magnification effects. That's going to all determine how far you can see on the ground and how far you can see in the sky. And then that meeting point meets right there. And then that changes throughout the atmospheric conditions, the distance that you can, with which you can see. And that will cut things off due to perspective over long distance at that ratio. It's like the way it does with the sun and the moon and those large ones.
Is this due to this made up physics you're talking about?
No, it's not made up. It's actually reality. It's provable empirical reality.
Oh, well, then we should do that.
It's better theory, Lewis. The rest is just globe cope. It's trying to make there be a curve there when there just isn't a curve there at all. It's just cope.
This Nathan Oakley video, I'm pretty sure the object he's looking at in the other room, the floors they're not even. They're not on the same level.
Oh,
the other room,
always something.
The other floor, the other floor just is literally like an inch below the one he's on. So
yeah, I mean, Lewis, do you know that you can recreate this on multiple scales and it's been done multiple times?
Where the camera's actually above the surface that's causing the obstruction?
Absolutely. There's been all kinds of different ones done. You can do it yourself as well. In terms of this phenomenon, is this what we're talking about in terms of things sort of obscuring from the bottom visually away in distance? Yeah. So are you coming from a position you think that that's just made up, like that doesn't exist?
Yes.
Okay. Yes. So if you did it yourself in an actual physical setup and you saw it, even if you did multiple different sizes and ratios on multiple different scales, and you saw it for your own eyes, at that point, would you then just concede and say, "Yep, that's the case"?
Yeah.
Okay. Well, then, I mean, that's easily. It's not. I wouldn't say it's super easily doable because obviously there's finances involved, especially if you don't want to just trust a video. So you'll have to have the time and set up to do it. But yeah, it can be done on multiple scales.
Yeah, every single example I've ever seen is not actually a flat surface, or the camera is literally below the flat surface.
Well, you have to agree, Lewis, that 6-foot objects will reach a vanishing point, just like a 6-foot zone of visual space, or any part of the object that's 6 feet or below will reach a vanishing point too, right, Lewis?
Yeah, one explanation makes sense and the other one doesn't.
So what happens to the rest of the object that is above 6 feet? Are you saying that it automatically disappears just because the 6-foot portion has reached a vanishing point? Or would you just let that, object set bottom up with the bottom 6-foot portion disappearing first, followed by the rest of the object? I think you would do the latter, not the former, right, Lewis?
Yeah.
So as far as I can tell, this explanation makes sense and is consistent with the way that we logically think about this.
It's not.
Do you agree that taller objects need a further vanishing point than shorter objects which disappear earlier?
I would agree that you have to move further away from a taller object before you can't see it anymore.
Same thing. So what happens when you have two vanishing points that are
I
overlapping?
reject the words you're using. I just reject your entire premise.
What
Like that there's
happens
this
when you have
magical vanishing point over a flat surface. No, there isn't. You made that up.
You're going to get a vanishing point for a 6-foot observer, just like with any 6-foot object. So the next logical question, Lewis, is what happens when one vanishing point covers over another? What happens when you have a 6-foot vanishing point for 6-foot objects in the foreground covering over a 100 or a 10,000 foot vanishing point for the 10,000 foot mountain in the background? Obviously, something is going to have to go behind another thing, since we see in 2D and we represent objects going away, either going left, right, or up and down, above or below other things in the foreground. That's the only logical thing that's left.
Yeah, if the Earth's a sphere.
This would happen even over a flat surface. The sphere would be unnecessary. You'd have vanishing points in the foreground covering over what's happening in the background.
Yeah, it wouldn't.
The horizon at that point is nothing more than infinite vanishing points for objects of a certain height extended left and right and forward and back from the observer. The horizon is the vanishing points in the foreground based off of your height. 6 feet in this case if you're 6 feet tall. Anything that's taller will just have to set in the background. So if you're logical and consistent, Lewis, the explanation is clear.
Yeah, but it's not true.
Lewis, let me ask you this, just on it based alone, if you saw this represented for yourself in a physical, experiment and setup, just knowing that you can do it on a small scale and you've seen it, how would that then change your viewpoint of what the Earth is? Would you then start questioning whether it actually is a sphere, or would you still hold with the sphere?
That would be extraordinarily compelling.
Okay. And you would then look into it more, but you would consider, okay, the Earth actually may not be spherical, because it seems like you're holding on to this in a way, and I'm not trying to say it in a critical way, but it seems like in a way that where if this wasn't the case, somehow the whole globe thing would not be as real for you, maybe?
It would be one of the major pieces that would be absolutely necessary for me to change my mind on the shape of the Earth. One of the major pieces.
The globe will always be the explanation, the reason why they see what they see, right? This is why it's so hard. It's impossible, damn near, to ever prove or debate this, because it's like we're both looking at the same thing. It's now, why do you believe it's happening? That's why I think it's very important to take on the entirety of the beliefs. So taking on the ball, you have to take on the entire solar system just to make a boat disappear. Whereas like just perspective or vanishing, it's not as much.
No, you wouldn't.
Well, we need to reason together and get
for the ball.
But we need a body of sufficient reasons. Once we see how even over a flat surface you can get what appears to be obstruction, we now have another thing to add to our body of sufficient reasons to make the flat Earth viable, as opposed to the ball, the only game in town as to why things disappear when you them up.
If you actually had this, if you actually could demonstrate this, you would be so much further along than you are.
We already have, but people keep on coping with excuses and holding on to their preferred model based off of faith. It is what it is. Some people accept it and some people reject it.
Why is it that in every single example of someone trying to prove this, the surface isn't flat or the camera's literally below the surface?
You haven't shown that the floor isn't flat. Did you use a laser to do more than just cope and say, oh, her floor isn't flat or Nathan Oakley's floor isn't flat? If you haven't
can
done that, then
literally
you're
see
invoking
it.
it, but you haven't really shown it.
You can
Yeah, like
see that
Lewis,
it's not flat.
like if you go on like a basketball court or something or anything that's very level like that and put your eyes down to the surface and look, you're not going to be able to see all of the lines. As you put your eye down, more and more of those lines are going to quote unquote be cut off. They're going to be obscured. Just lowering your eye right down to the flat court.
No, but they're not
Nothing has
obstructed.
changed. Nothing has changed to obstruct those. It's still just level. It's not court curvature that's causing it. It's just the perspective. You're same with like the idea of like a huge chessboard, like black and white squares. As you put your eyeball down, they're going to start to be cut off and obscured visually.
No, they won't be cut off and obscured. They will blend into each other, and the angular size that each square makes up becomes indistinguishable from the next square.
Yeah, so that's in a way a similar thing that's happening to the boats on the horizon. It's a little bit different, but it's actually similar in a foundational way.
It's categorically different.
Categorically, it's similar because our eye sees in 2D, meaning left, right, up, and down. It represents objects in kind of a 2D scale with size. So those squares that you're seeing on the chessboard, for the eye's purposes, are no different than an actual 3D object. It will still represent them the same with some sort of angle and thickness to whatever you're seeing up, down, left, and right as, some sort of 2D kind of even a squarish object. So since the eye sees in the same way 2D with the chessboard or 3D in real life, it will see via the same principles, and everything will just eventually converge into a narrow angle that is too narrow to make out the object if it's an object sticking up out of said surface. It's the same principle.
Yeah, no, it's not. The difference here is a chessboard or checkerboard having the squares blend together in a way that makes them indistinguishable because they're too close together in their angular distribution. And having a piece, like a checker piece, actually disappear into the board. That's the difference here.
Yeah, but it's similar. It just depends on the ratio and the distances and the atmospheric conditions. The sun does it profoundly because of its size. So, the idea of watching it kind of cut off from the bottom up during sunsets and sunrises, that's a very poignant example of it.
The eye will do the same thing in either case. It may do it, faster for a flat checkerboard surface, and maybe it'll take 3 times or 5 times as long for an actual 3D object sticking up out of said surface. But eventually, the same thing will happen. It will blend into the horizon and just become part of the unresolvable line of the horizon that you see. It's the same principle.
Yeah, like instead of having lines on a court, it's just boats on an ocean. The boats are 10 feet up, whatever, but the ocean's huge. And like you said, the difference between a checkerboard and the actual colors on the board versus a checker that is above the board a little bit. But it's a similar concept because essentially all the checker is just a slightly raised portion of elevation of the larger board, which is what like the mass is, slightly larger elevation at that distance, at that vertical to be able to view that.
Yeah. There is no situation where that checker piece disappears into the board.
But at that point, what I would say is that there's a ratio problem. Like you can't do it at 3 feet. You know what I mean? You need to have some distance involved. It's a ratio of the distance, the size of the object that's on the planar surface. And then, of course, when you're dealing with the Earth, there's all the atmospheric conditions, which then bring in all of those factors as well.
Yeah, right. I mean, the thing is, the eye is saying I need symmetry. I need equal room up, down, left, and right from the vanishing point to represent any object symmetrically without it disappearing bottom first. So if you're looking at the 10,000-foot mountain, fine, levitate up into the air where 5,000 feet of the mountain is above you, 5,000 feet of the mountain is below you, and it will tend to disappear down to a pinprick, roughly. But if you're, 6 feet off the ground, the eye has a dilemma. The eye at that point can say, I can represent 6 feet symmetrically up, down, left, and right to make a vanishing point form, sure. But I have the rest of the 10,000-foot mountain because the eye needs, because to represent a 2D object, you need light from all parts of the object to hit your eye symmetrically. That appears to be what we see with perspective. And so now with that,
why would that necessarily mean there's a vanishing point?
That's what we see with art, and that's what we see in practical, experiments. This is just
due to resolvability.
And so now a 6-foot vanishing point can evenly and symmetrically be represented to the eye up, down, left, and right from the level of the eye, sure. But what about the rest of the 10,000 foot object? The eye has a dilemma. It could just say poof object, or say, look, the rest of this object is going to have to disappear bottom first in the background. I can only symmetrically process what is in the foreground. Otherwise, you're going to have a weird funhouse effect where you have a vanishing point for the 6-foot object in the foreground and a vanishing point for a 10,000 foot object, competing with the thing in the foreground. That's crazy.
Yeah, but they're not occupying the same spot in your vision.
For all intents and purposes, they are, because your eye's at a certain level. Where's the vanishing point? It's toward the level of the eyes. So eventually they will overlap. And how do you deal with two objects that overlap visually? The penny in front of the car appears to obstruct it, or the vanishing point in the foreground appears to obstruct the vanishing point in the background.
The penny is literally in front of the car.
With the floor, right? And you see the light trail, how it's bent in one direction. That's indicating that the floor has a hump in it. Just so you know, the dude is fucking with you, talking about it works fine on a flat plane. You see that floor is humped, right? That's clear and evident in the light reflection.
I'll give it to you that the floorboards may have a stylistic hump, but not enough to talk about with this example. P-Brain has demonstrated that there's no hump. Life is Short has demonstrated that there's no hump several times as far as I've seen. I mean, saying that there's enough of a hump in the floor to block what's beyond, at that point it's just cope. You need to say how much of a hump and whether it's a sufficient enough hump to block what's beyond. That doesn't necessarily follow. What is it, a micron hump? A half an inch hump? I mean, get the height of the object and the height of the hump and demonstrate that it's sufficient to block what's beyond or whatever.
Yeah, you can see the light thing, right? But also, where's his focus? Is his focus focused in on where the lady is, or is it focused towards closer? Because that's also very important with using the camera, right? Because I demonstrated that, remember, with the battery and the very flat speaker, and then I slid the speaker box and I slid the battery. Right. As long as I was in a near focus, it looked like the battery was blending in with the flat surface, like from the bottom up. And then I would focus in on the battery, and it appears again. And that's an artifact of the camera. So you got to be careful of these tricksters, man. They give you stuff that you can use, and then you get torn apart with the.
Well, we need to talk about what we mean by obstruction beyond just the normal definition, because some of this is very philosophical, Mr. Grimm. When the penny is in front of my eye, it's not physically blocking the car in that it has the same size, the same dimensions to block everything coming from the car in that sense. So in what sense is this penny really blocking the car if it's smaller than the car?
Right. But I mean, if you're behind it and it's close enough, right? Then it can block everything. You just stuff the penny right in your eye and you won't be able to see a thing. You know what I'm saying?
But this happens even with bigger objects. I can block the skyline with 1,000-foot buildings with a penny just as easily, even though it's absurd to say that the penny is truly physically blocking it by taking on the same size as the object and standing perfectly in front of it. Even that's problematic. So what do we mean that there's a physical obstruction here if a penny can obstruct a city line, a 32-mile in diameter moon, or whatever? What does it mean?
I was talking about your floor here in this example, particularly not a tree or a penny or standing anything. This floor here is said to be flat, and I'm just saying, look at it. It's not.
Let me make a quick point.
All the way down to the floor level, and that little half inch of difference in the grade of the floor, right, is very prominent in the perspective of blocking objects in the distance.
Lemon, give me a shot.
That's hump in the floor.
Go ahead, sir.
Yeah, okay, so here's the thing. So he just said, that the squares of the chessboard, Lewis said the squares of the checkerboard or chessboard blend together and they're indistinguishable. Okay, so that's the same thing. Like if you're talking about the Rayleigh criterion, okay, if you have the angle, you could zoom in and get a better angle. But once you get down so low that your angle is less than 0.02 degrees, zooming in is not going to change that angle at all. It's the same thing as like if you cut a circle out of a piece of plywood, like a 1 foot diameter hole, and you have the camera right up to it, and you start backing up. Once you start backing up, you can zoom all you want but you'll never see as much view as you could with the camera close to that hole, because you'll never get that angle back, no matter how much you zoom in. If you back up say, a couple hundred feet,
I might be confused, but I don't think zooming in or zooming out changes the angle at all. It's the field of view.
Right, but once you've lost the field of view to the ground, then let's say the ground is one light, and then 6 foot above it is the other light, and you back up 3 miles. Okay, you've lost the angle to the ground. Okay, if they're up in the air, you could zoom in and spread your field of view, but if you can't spread the ground, once you've lost the angle to it, zooming in ain't going to help. So you can't see forever on a flat plane. I don't know why y'all don't understand that.
No, you couldn't see anything on the flat plane that's flush with it forever. That's what you couldn't see. Something that's sitting on top of it, you could.
No, I just explained. You
you didn't.
even agree with me, right? That if something gets, if you have less than 0.02 degrees of angle to it, then you're not going to be able to resolve it. You just said that.
That's right.
Okay, so once you have 0.02 between a 6 foot head height and his feet, okay, you've lost the angle because of the ground, from the angle from his ground to his feet. You zooming in is not going to change that angle.
It doesn't work that way.
Yes, it does. Zooming in changes the apparent size of an object that was not previously resolvable. That's what it does.
No,
well,
not if
I
you've
can
lost
see
the light.
dust on my phone right now, and my phone is flat. But if I keep an angle above my phone that is narrow, but still above the phone, and extend it for like 5,000 miles, there's no way in hell that I'm going to see a dust mite the size of anything compared to what I'm seeing in the foreground on my phone right now, 5,000 miles in the distance, assuming that I extend my phone, that far into the distance. There's just no way. The viewing angle is too narrow, and eventually everything just merges with the surface.
Let's pretend that you take your phone out of this picture altogether so that you just have the dust mite. If you can magnify to the point where you can resolve the dust mite, now put the phone back. You will still be able to see the dust mite.
Not if you've lost
be able to magnify the stuff in the foreground. The dust mites in the background are at too narrow of an angle and unresolvable.
All right, one more thing, real quick.
Are they?
Okay, so if you cut a 6 foot
we just literally
board,
defined them to be resolvable.
Not if you've
one more
zoomed in
thing,
on
y'all.
the
One more
dark
thing, and I'll give it all back. But one more thing, real quick. If you take and that piece of plywood and cut out a 6 foot, like a big ass piece of plywood, and cut out a 6 foot section, okay, so it's on the ground, okay, and you start backing up, okay, and you'll lose it because you'll lose the angle because of the ground, right? So you say you zoom in, you'll see it again, okay? No, but that's the same thing as saying if I backed up, if I'm right up against that 6 foot hole with my camera, I could see all kinds of stuff through the hole. But if I back up, let's say half a mile, and I zoom in on that 6 foot hole, I'm not going to see as much as I could see up close because that light's lost to me. I can't get it back because I don't listen. I don't have the angle no more. And the reason I'm explaining it with a hole is because
that's right.
You can't zoom in on the hole. I've lost the angle. Same thing with the ground. Hold on, I'm almost done. I'm comparing the angle to the ground itself. And once you've lost light to the ground or the board, there's no zooming it back, bro. You could zoom in, you might see a tiny bit extra, but
the angle the thing is relative to you does literally change. It takes up less space. But if you were to take that board and just put something on top of it, like a shoe or something, the angle that it takes up in its angular size changes. Its angle relative to you is not changing, and it is literally on top of the board. So it doesn't matter how far away you get.
What do you mean on top of the board?
I'm almost finished. I
want you to keep going.
I let you
finish. Listen, you can keep going as long as you want. But where are you talking about?
I'm not going to fight with you. I'm not going to fight with you.
I just want to understand what you're saying, bro. I just want to understand, where are you putting the shoe?
On top of the board.
Okay, on top of the hole or on top of the whole board?
On top of the board.
Okay, so let's say it's an 8-foot board. Okay, and you got the shoe on top. All right, re-explain.
Right. So you put the shoe on top of the board. It doesn't matter how far away from the board you get. As long as you can resolve an object the size of the shoe, you will always be able to see it.
You realize you can't see a shoe 3 blocks away, right?
If you have
Because you
enough
can't see a brick.
magnification, you can.
You can't see a brick 3 blocks away.
So
If
you
you have
don't
enough
agree that
magnification, you can.
With your naked
you don't
eye.
agree that
arguing.
you don't agree if we
Yeah,
back
I'm
up.
not
with your
arguing
naked
about
eye.
naked eye. I'm arguing about with enough magnification. How many
Yeah,
times
hold
do I
on.
have to say that?
Well,
Right,
we
you
need
don't
to
agree.
talk about this
Stop.
because you're assuming that enough magnification brings anything back, and that may be an incorrect premise. Once something has appeared to merge with the surface, I'm sorry, no amount of resolving ability is going to bring it back. Why? Because it is simply going to fade into the color field of the surrounding surface and be unresolvable. What are you going to pick up instead? The surrounding color field. It's like trying to pick out a mouse on a desert floor or something like that. If you have enough magnification, maybe, but eventually that mouse will simply merge with the surroundings and become indistinguishable, or stuff will merge with the horizon, the surface, and become unresolvable. This idea that you could just magnify anything, Lewis, is a little off. It's not accurate.
Yeah, you're misrepresenting what I said.
I think I'm representing it accurately enough to get to the heart of what we're talking about. And Kosho, the point of the chessboard analogy is showing that the eye sees in 3D, Kosho. So the logic is the eye sees in 3D. Therefore, it doesn't really distinguish in any real way between the 2D squares on the board and the 3D objects sticking up out of said board. Eventually, as the board will merge into an unresolvable line, objects in real life will do similar, especially if they're sticking up out of the surface, Kosho. The logic appears to be sound since the eye sees in 2D.
Especially if they're sticking up.
So
Yeah,
eventually
this is
the
just
same thing will
physics that
happen
you've
with the
made up.
chessboard because of how we are
You
consistently
have
applying the
nothing
logic.
to demonstrate this to be true. Nothing.
We're demonstrating it over and over again, and you're trying to cope saying that the floor isn't flat. So the principle appears to
No,
be
you're
sound.
asserting that it's true, and all of the examples that
You're
you
asserting
have
that it's not
literally
true.
don't show what you say they show.
You're asserting that it's not true. Show me a laser over the flat ground, but I guess you'd have to admit that lasers show a flat and true level and have to accept the flat Earth demonstrations with a laser that appear to not be showing curvature. If you use a laser on the ground in Raichi50's video or Nathan's video to prove the flatness of the ground too. So I guess with all the lies that you're committed to, you're just stuck in a hard place where you can't even prove that the floor is flat without admitting that the same tools that we're using to prove that it's flat are actually showing that the Earth is flat, aren't you?
In other words, hold on, they have to use
I haven't
18%.
seen any. I haven't
Y'all have
seen
to use-
any. I have not seen any laser experiments like what you're talking about.
Wait, you have to use 18%. You have to refract light 18% more than your Earth curves as a standard without looming or special circumstances. And if it's flat and we lose it at 0.02, we just need it to bend just a tiny little bit. Just it doesn't even have to bend. It just has to change angles a smidgen. Over a few miles, you're talking about a horizon that's a function of distance in the first place. And you'd rather stick with a story that mandates bending light 18% more with 7/6R than what's real, than just a little tiny angle change over a flat plane.
Do you have any demonstrations for how refraction works? Because I do.
I'll see if I can find Dr. John D's
18%?
laser test. Dr.
I
John
think-
D used to do laser tests back in the day. Let me see if I can find his. I think he was showing
I made a video with Dr.
Oh, yeah.
Dr. John
I've
D's
seen-
work on it,
I've seen
and I
Dr.
showed like
John D.
lasers. I showed lasers bending the opposite way y'all say they do, bending up.
No, you didn't.
Yeah, I did. I got about 3 or 4 of them. I could post them right now. What are you talking about? No, I didn't.
Yeah, well.
And I've asked every baller I've talked to. I've asked every baller I've talked to show me a laser bending down, and nobody can. But I can show multiple lasers bending up if you look at them off to the side.
Do you mean bending up? You mean they're going over the top of your head?
I mean curving up. You can see them refracting upwards. I'll show you. I'll post them.
Every single video I've seen.
You'll still deny it, though.
Dr.
You'll
John
still
D.
probably deny it, even seeing it. And I'll show you
Every
multiple.
single video,
and you'll
I've
still deny
seen
every
from
one of them.
Dr. John D has been consistent with refraction.
No, John D had the writings about it, but these are different examples, different lasers, different experiments, and all orthogonal views. If you look off to the side a little bit, then you see them
And it's not
curving upward.
orthogonal, is
And
it?
you can't show me a laser curving downward like I'm about to show you a few of them. But what you'll do is your brain will deny what you're seeing with your own eyes multiple times. You'll see it live in a video. I'll show you snapshots, still shots, and videos, and you'll still deny it.
Sure. I have not seen a single laser experiment or really anything. Literally nothing that I have ever seen from Flat Earth has been inconsistent with the Earth being a sphere. Literally nothing.
Not inconsistent, but not consistent also, huh?
No, completely consistent. Everything I have seen is consistent with the Earth being a sphere.
If you look at the Earth curve calculator,
Yes.
it should have some hidden curvature per distance in these observations. Have you matched that to what your globe should be?
Yes.
Can you show us that in live stream? Maybe like an observation or distant observation?
No, if you want to compel
have
me,
nothing?
you can show me something. I'm not interested in convincing you.
So I'm just asking. So you have no observations that show curvature? I'm just asking.
No, I do. Every single observation I have shows curvature.
Matching the 7/6R?
Yeah,
I haven't seen any.
that's fine. You're an idiot.
Very succinctly put.
Well,
I know
you're
it's when
basically
Glober's
doing,
run out of information. They start ad homing.
yeah.
Well, the problem is that you've seen all of the information and you don't understand it.
The
Because
Globers
you're
are
an idiot.
bureaucratic thinkers. They just wait for somebody else to give them the green light to think. Otherwise, they don't tend to think too independently. I
Well,
should know I
you
was a
had to wait for the
Glober.
green light for your made-up physics.
It's just a bureaucratic fallacy. You're just going to stall an insult rather than actually, make a decision or logically make the next step.
Okay.
Yeah, I mean, Lewis, I'm just listening here. So, I mean, let me ask you this, dude. Like, I mean, do you feel like you are on a quest for truth? Would you define yourself that way?
No.
No. Okay, so you're not seeking truth. You're not trying to find truth or engender a greater understanding of the truths you know and more and ones you aren't currently aware of. You wouldn't say that you're connected to that at all?
I think I have a very good understanding of what the Earth is, and I don't think what I am doing could be or should be described as a quest for truth. I don't think that highly of myself. Not in this situation.
Okay, because I guess I thought you were going to say yes, but if you're not, then I guess the next thing I was going to say just fits right in. I was just going to say you seem excessively cynical and overly closed-minded that if you were seeking truth, it seems like that would be your biggest hurdle.
A good follow-up question that you could have asked me, and I'm sure will at some point again in the future, is does the truth matter? And yes, of course the truth matters. But when I think of the question, am I on a quest for the truth? The answer to that is no. But does the truth matter? Absolutely.
Okay, so maybe you wouldn't use the word quest because you think you've already found everything you know is all you have all the truth already. Is that what you're saying?
Exactly. If I was
really,
on a quest
so you have that level of an ego
if I was
position
on a quest,
you just have all the truth.
If I was on a quest for the truth, that would imply that I don't think I know what the truth is. But in this situation, with the shape of the Earth, I do think I know what the truth is. So there isn't a quest for me to go on.
Refraction,
well, not necessarily, because you can know certain truths, but also be on a quest to discover more, discover additional truths. So
if you want to see truth, I just posted 3 snapshots and the video that they came from that I made explaining the celestial navigation, showing other examples of what light's actually doing, real world experiments, not sugar water and fish tanks, over short distance, long distance. So everything y'all say light's doing over long range in the atmosphere is wrong. So if you want to see the truth, or if you care to see it, just look at the shots and take a look at that video later on.
Sure. What is so the green laser? What's this supposed to be?
Every laser that you look at orthogonal, not everyone, but damn near, but or that you can see them curve up over long distances.
Curve up, huh?
Not all of them, but a lot of them. But none of them have we ever seen curve down. But anyway, that's a still shot from a video. So, hold on, that's a still shot from a video. So you'll see the laser moving around, not just that one little angle. You see it curving up, obviously. There's no denying it. You could say what's causing it. You could argue that. That's just a still shot from a video that's in the video I put in between them snapshot. Saying,
have you ever done a test to experiment on how refraction works?
Yeah, over short ranges. That's in there too. Just go look. Just look at the video.
What have you done?
Put hot water or put cold water on a hot ass driveway. Heat it up. It was already hot as shit, and put it torch. So the way y'all describe it is literally exactly backwards. If you cool it down, okay. If you cool it down, you'll get sinking. Okay.
That's exactly right. If you cool it down.
I mean, if you heat it, I mean, when you cool it down, you'll actually see. Wait. Just look at the video, man. Just look at the video. You're confusing me. But
no,
anyway, I've seen a video. Hold on, I've seen a video on
it. You.
No,
you are
I've seen it. Oh, so just forget everything. Forget all the fucking examples I show, and forget it all. Just because you think I'm confused. So forget all the evidence that I have in this packed in this one video. No, I mean I'm getting it backwards, man.
That's fine. You're when you
Lewis,
pass light. Yeah.
I was just gonna ask you. Yeah, go ahead. Say
when
something of value. It just seems like you're just insulting people. It's boring. Did you have just offer something of value?
Everything I say is of value.
I agree, Lewis.
Anyway,
what were you actually saying?
Show me a laser curving downward, then you. Until then,
when you pass light through, when you pass light through a denser medium, it bends towards that medium. So when you pass your light through over the top of your cold water, it's going to cause the light to drop towards the ground. When you pass it over a hot water or something that's making the light hot, the air hotter over the area that it's passing through and less dense, then the light will bend up. It's that simple.
That's wrong, dude. We've showed fucking garage floors. You've seen pebbles on the pond. You've seen Sky Free open the fucking garage door and let the cold air in, and you've seen shit disappear because you had the warmer ground and the colder air above it. But here's my point. My point is this: show me in reality, not in sugar water, not with butane. Show me in reality a laser over long distance curving down the way y'all say light bends. You can't, because I've been asking this for almost a year and a half.
That is fair, Lewis. That is fair. Do you have that, or have you ever seen that?
Every video that you've posted is what you're asking for. I cannot help you with your own understanding.
You say it's curving down, but I'm showing you multiple examples, several.
If the light
There's half a dozen in the video. I mean, I only posted a few.
Passing through a more dense medium. If the light passes through a more dense medium, it will bend down.
What do you mean?
He's asking, do you have an example of that? Any type of recreation, even a video? That's what he's asking. Instead of just the theory, the idea, do you have any actual evidence of this?
If he wants to find out, he will have to look for himself.
A laser shooting off parallel, and then essentially
everything you're saying is wrong.
A laser
and I've
going off
posted
parallel,
several examples of that occurring.
Curving down and hitting the earth. That's what he's asking for. I'm just saying it's what he's asking for.
Gio, I am not going to dance for him. I'm not going to post videos. I'm not going to post evidence. I will tell him what I think.
Spare yourself the time. They're not out there, bro.
If he disagrees with what I think, he is free to disagree.
The
Well,
thing
it's
is that
absurd,
you're
bro.
just
They don't
saying shit.
exist. You can say you're not going to dance, but yeah, save yourself the time. They don't exist because it doesn't happen. Get it through your
Everything
skull,
you
bro.
posted,
You can't
everything you
produce it because
posted is
nobody
consistent
can.
with what I
It
said.
doesn't happen, bro. I don't know what else to say. And so no matter what I show you and show you that you are wrong, okay, I don't know why you're wrong. I don't know the exact reason. Maybe it's because the density of air doesn't change much over the few feet we're observing the shit over, or I don't know what the reason is, but I know what I see, and you could see it too. And I told y'all that I could show him plain as day lasers curving upward, and he'd still deny it. Dude, it's like debating a fucking mule. You don't want to see nothing we have to show him. He's just gonna, no, you're wrong, Spear. You're wrong. I'm not gonna dance for you. You'll never produce it because it doesn't exist. And if you do, it'll surprise the shit out of me. If you could show
Your
me even
videos
one,
don't. Your
you'd be the
videos don't
first.
go against what I think.
Right, Brian, I've already posted a long form explanation as to exactly what you're seeing in those videos where you see the laser appear to be bending upward. I've even given you a two scale reproduction of exactly that same observation.
Where? Okay. Because
That's
okay,
the
you're gonna
Slice
show me
Arcane
a
thing I
laser
posted to
curving
you months
down, right?
ago, and here I've posted
No,
again
you haven't.
today.
That's horse shit, dude. You're gonna show
Right,
me a
understand
laser
that you
curving
believe
downward.
that it's horse shit, Brian, but I did post it
Let me
again for you
respond,
today
bro.
so that you can have a chance to peruse it at your leisure.
Allow me to respond. So you're gonna show me a laser curving downward, right?
Right, he
Why don't
uses,
you watch the
yes, the
video?
laser bends toward a convex surface and causes it to appear to bend upward because the path that it's taking is reflected off of that convex surface.
So you're gonna show me a laser light bending downward, right? Not in a
Right,
fish tank.
he's using
in atmosphere, right? Let's see
right,
it.
he's using a cold surface, cold air at the bottom, warm air at the top, which is a density gradient where the highest density is below. The light bends downward to impact the surface that's in front of the camera, which causes it to appear as though the light is bending upward, but that's not what's actually occurring.
Okay, can you just show me it happening in the normal atmosphere where you say it happens? You say that light bends down because of the denser medium in normal atmosphere. So if you don't mind, I would love to see what you have to offer, but also show me in normal atmosphere, the way you claim light normally does, show me the same thing happening without all the fucking effects like I showed you. But I'm still interested in seeing what you got, though. Can you post it?
Right, it's already posted here in the chat. It's the Sly thing. It's right up there. It says those laser tests in the thumbnail.
So, but after I look at that, can you, any chance you can show me the laser doing that in regular atmosphere, the way you claim it does in regular air in real life? The way you claim it bends down without all the special effects?
Right, using just air alone and inducing a density gradient in a short span requires changing the temperature since that's the strongest effect. You had an objection to that last time, but you didn't explain exactly why that objection was necessary.
I don't want to see a short span. I don't want to see sugar water. I want to see a laser over
not sugar water,
land
Brian.
or water over long distance, bro. The way you say it does over
It's
long
not
distance.
sugar water, Brian.
That's what I want to see. It's not rocket
Right,
science,
but
bro.
it's not sugar
See
water,
what I
Brian.
showed you, right? You see what? All right, I got you.
Brian,
But you see what I showed
listen
you, right?
very carefully. It's not sugar water. The example I gave you before was using air.
I heard you over short distance. Okay. Now, what do you have to say with all the examples I give you with light doing the exact opposite? This laser lights over long distance
That's
without
what
all the
Slice
special
Arcane
effects.
videos for.
Yeah, those laser videos you posted
Or
don't
just
actually
ignore 'em, right?
They don't actually disagree with what we've said. You're just an idiot.
No, I'm just an idiot. You're a fucking donkey, dude. You're denying your own eyes. So that light ain't curving upwards.
Right, that's what the Slice Arcane
Call me an
videos.
idiot and look at the
That's
light curve upwards in
Arcane
normal
videos
air.
specifically here to establish that it can bend downward and appear to you as though it's bending upward.
It could also bend
So
upward.
you're gonna show some fucking bullshit slick Sparkane trickery, as usual, instead of just showing us the laser in that regular air doing what you claim it to do. Dude, I mean, what don't you get about this, bro? You claim it does it, so fucking show it doing it, bro. You claim it does it, show it doing it. What's so hard about that?
Brian, it's not trickery if he's showing you exactly what he's doing.
If he's having to use fucking ice or fucking torches or fucking or manipulate the media, I'm asking, just show me how it normally happens over fucking normal air, the way y'all say it does. You can't.
Yeah,
you got to show some
you'd have to
induce a gradient in order to demonstrate what such a gradient will do. If you don't take the effort to induce a gradient, then you're not doing science, Brian.
But I think what he's asking for
normal
is
air, bro.
Hold on, Brian. Just chill for a
That
second.
is air, Brian.
But so Doofus, I think what he's asking for, like this is like even up to 10 minutes ago, we were talking about this. Do you have any actual documentation of a laser going off parallel that's measured parallel to the Earth and then curving into the Earth?
That's sort of a problem because you're assuming that the Earth is flat to begin with. If the light is bending downward and the Earth is curving downward at a faster rate, it'll appear that the light is gaining altitude from the surface of the Earth, which to you, because you assume the Earth is flat, you assume that the light must be bending. I was almost finished. You assume then that the light must also be bending upward, and that's not the case.
That's why I showed the first one, so the ground wasn't even a factor, because I knew the fucking slick asses would. I need to calm down, but I knew y'all was gonna try to claim it. That's why I showed the one I did first, to show you the ground has nothing to do with it. You see the light curving, bending, angling, whatever the fuck you want to call it, upward. The ground ain't got shit to do with it, and this is in regular atmosphere. No induced shit. This is what y'all claim is the opposite of what y'all claim is happening. And it's right in front of your eyes.
Not
you
always
want to
what
show some
happens.
trickery over an induced curved surface. Trickery.
You know, refraction can cause a laser to go in both directions.
That's also true. But that's what the Sly
Then show
Sparkane
it going
video
down. Then show it going down then, right? It should be
is
easy.
that the effect that you see in that laser video, where you see it and it looks like it's bending upward, you get the precisely same visual effect in Sly Sparkane's reproduction of that same observation. He did it with downward bending light.
So bottom line, you cannot show this in real life.
Thanks for lying, Essie. Thank you for coming in to do that.
I'm not lying. I'm just stating a fact. Can you? He's been asking you now for half an hour. Can you or can you not reproduce this in reality out in the atmosphere? Yes or no?
Right. Sly Sparkane's video shows you that the laser light with downward bending light can give you the appearance that the light is bending upward. And yes, he is using a laser that is in reality. So yes, the demonstration is done in reality. Don't tell me it's not done in reality.
So I can take my green laser right now that I have here, bring it outside, find the field, point it, and it's going to point downwards because I can go and do it right now. Is that what's going to happen?
If you had listened to the rest of the conversation, typically in our atmosphere, in the stable condition, the light bends downward at a slower rate than the curvature, which means that at a farther distance, the altitude the laser light passes over the Earth will be at a higher altitude. If you presume the Earth is flat, you will assume that the light is bending upward, which is not the case.
So if I take my laser right now and go out to a field, right? Take my P900 and make it so I can see this laser, because I can. It's pretty powerful. Which way is the light going to bend?
If you're looking at it from the side, the amount of curvature in your field of view of that laser beam will be too slight for you to be able to identify it.
So we can't see it in reality. Cannot. We cannot reproduce what you're saying in reality, in a field.
Well, yes, you can. You're just doing it wrong.
If you had the right atmosphere and the right gradient, you could.
Yeah.
Ace,
and what would that be, Lewis? What would that atmosphere, the right
Soundly,
atmosphere be?
What does Soundly need to get permissions in here?
Sorry?
Soundly's looking for permissions.
I got it.
Oh, Soundly? Yeah,
Okay.
you should give it to him.
Yeah, you would need denser air towards the bottom of the towards the ground.
So what conditions should I be looking for? Like a hot day, a humid day, a dry day, a wet day? What do you recommend, Lewis? Because I'll do this. I have the laser. I have the camera. I can easily do this.
Well, what you should actually do is just look it up online and then follow those instructions.
Oh, you're pulling a Brenda on us, Lewis. That won't cut it, bro. So you have no clue, right? You're just talking, right?
Well, no, I can tell you, but
you wish not to. You wish not to.
Did I say that, or are you
he
just
didn't read it
interrupting
or
me?
check it out. He just.
Or are you just interrupting me to assume that before I finished?
Oh, it's my apologies. Go ahead.
It's a little bit presumptuous of you, don't you think?
Could be. My apologies. Go ahead, sir.
Yeah, I don't really forgive you.
I don't give a fuck what you believe, bro.
Yeah,
okay, I'm just being polite here, and not because of you. I know what you are. So, can we do this
I don't
experiment or
give a
not?
fuck what you believe. I'm just being polite here. SE 2022.
Yeah.
Yeah, because Lewis, I know what Lewis is. I'm being polite because of one person and one person only, Geo. If we were in another server, I'd be talking to you much different.
Yeah, I know.
Because I know what you are, Lewis.
You're not a good person.
No, I am a very good person, but little people like you that come in just to, stir stuff. Been listening to you for a while.
You mean disagree with you?
Well, Lewis, it does seem like you're just trying to create a shit show. So because you'll be talking about the actual topic and then you'll just dish out and try to insult someone. It does kind of seem like a tactic.
He was rude to me and I responded in kind.
Well, I'm just talking about the last 2 hours or the last hour. You've been doing it a lot because it's like a different mode. Like if you're having an actual intellectual discussion, information's being shared, then it's like the strength of your actual point you're making is what's at play, whereas if it's just insults, it just goes into that, then it's just like, all right, who can just insult each other more? And it's really all kind of meaningless at the end of the day anyways, that part of it. So, but it seems like you're trying to transition it into that and get that all going.
I'm not in control of that. I'm responding to them. Sometimes the point is that they're an idiot. Sometimes that is the point, but we don't have to dwell on that.
No, you're an idiot. Not anybody here. You're the problem, not us.
Okay.
All right. What was the point that you got? That someone was saying before we went into this.
If Montreal, if you want to reproduce this, you want the air above the ground to be cold, and you want the air higher to be hot. Whatever conditions you need
I was simply asking politely, how can I reproduce this in the real world with my camera and my laser?
So whatever you have to do to find cold air towards the ground with warm air above it, that's what you need to do.
Cold air towards the ground, warm air above it. Gotcha.
Just like that.
When a warm front comes in right after a cold snap over a lake, you'll see it.
Okay. Hey, Soundly, I'd like to ask you a question, if I may.
Sure.
You are the Soundly of the Lake Pontchartrain Bridge thing, right?
That's the guy.
All right.
I posted examples, man, of slides supposedly repeating that observation. What a joke, dude. I took, just to make sure, I took a few different ones. I found probably the best one I could find out of his whole little, no video, just pictures. And look, none of them are recreating. It's a joke, dude. This is total dishonesty. So you don't even have to watch the video if y'all don't want to. It's a bunch of rhetoric followed with a few snapshots of something he's claiming to repeat, and he's not repeating it. It's such horseshit. It's dishonesty.
Brian, why am I on the frame that reproduces it?
All right, hold on. This is Brian. You kind of jumped back. I think SC was actually about to ask Soundly something. If you want to say that, I hear you because it was on the previous topic. But
yeah, I'm willing to wait till
I'll back off.
but I would really
Sorry,
like to
SC.
ask Soundly. Yeah.
Sorry about that, SC. Go ahead.
No problem. So, Soundly, first of all, I'd like to thank you for your work because because of your work, I have the skateboard paradox. So I'd like to thank you for that, number one. And number two, I'd like to ask you, because I seen your video, we went through it and all, you actually believe that there is a curve there, right, on the bridge?
Oh, we demonstrated there was a curve there. Yeah.
You're kind of very low, bro. I don't know if it's just me or.
Is this better?
A little bit.
I got my mic right next to my mouth. I don't know how I can make it louder.
I think I can hear you good now.
Yeah, we demonstrated there was a curve there. Jesse did his waypoints, GPS waypoints, recorded it, plotted it back in 3D space, showed it was curving.
Okay, so you also said that there's a 90-foot hump at the center, correct?
There's two big ones, yeah, on both ends, at I think 8 miles from the shore on both sides.
What do you mean? What do you mean? The bridge itself, the structure, or because of the earth?
What?
Because I know there's humps, natural humps on the bridge itself.
Yeah,
for
there's
the boat, right?
there's humps on the bridge that allow marine traffic to go under them. There's two big ones. Both of them are 8 miles from the opposite shores.
Right, but if I understood you correctly, you said that in the middle of the bridge, like there's a hump, a 90-foot hump. In other words, if I'm standing at the shore of one
I don't know
side,
what you're referring to right now.
You don't know what I'm referring to?
The main deck, if you disregard the humps, like if you disregard the marine spans is what they're called, the main deck is the same height above the water all the way across for 24 miles.
Yeah, I know that. Yeah.
Let me translate SC Montrealese into this. What he's saying is that if you take the two edges, the two shorelines, put a straight line between them, that the middle will be 90 feet higher than that line. Is that correct?
Yeah, you see the lasers curving up, and that shows what we see.
Let him answer, bro. Let him answer.
Refraction. It's blurred out refractive garbage.
So Soundly, what of it, bro? How does it work? Let's say now what Paige said. Let's say I'm on one side of the Lake Pontchartrain Bridge, right? I'm standing right at the shore. My feet are on the water. You're on the other side of the lake, right? What's the relationship between our feet? Like if I look straight out, what do I see? How does the water appear?
Straight up?
I don't follow what you're saying right now. It appears exactly like you see in that telescope right there. Like at the.
Well, didn't you say? And I heard.
Minutes after?
Oh, I'm sorry. Go ahead.
The picture posted at 15 minutes after. That's exactly what it looks like.
Okay, so there's a drop there then, right?
Well, it depends on what you mean by drop. It's just curved. It's just the surface of the earth curving. That's all it is.
Is there an elevation change?
No, of course not.
There's not an elevation change.
Like I said, the main deck of the bridge is the same height above the water the whole time.
So what's curving then?
The surface.
What's curving?
The surface.
The surface of the water?
Yes.
Okay, then. Fine. So we established that the surface of the water is curving and that makes the bridge curve as well, correct?
Right, because the bridge is the same height across the water.
Okay. So now
this is amazing. I've never seen this before.
Oh, this is big stuff. This is the Rakia Bridge, the Lake Pontchartrain Bridge. This is famous. And Soundly is the man
that picture,
we measured it.
That picture right there was taken from either the 15th or 16th floor of the Marriott Hotel on like the New Orleans side of the causeway. And that's, you're seeing the opposite shore. You're seeing a big tower. There's a big light tower that's right by the pole center on the opposite shore. You're seeing on the left side there. Yeah. So
that's a 2032 millimeter focal length, correct?
Yes, exactly.
So let me get this straight now. If I was at the other end, you see where that curve goes down there at the end of the bridge?
Mm-hmm.
If I was standing on the shore there and I looked at the bridge, would I see that curve? Would I see it going up? What would I see there?
You'd see basically the same shape you're seeing in this picture.
I would see an upward curve there, like the bridge going upwards.
No, it's not. It's not going up. We've already established it's the same altitude, right? Same elevation.
So okay, so it's you said it's the water that's curving. Gotcha. So if I was at the base of that water there at the end at the shore, would I see this curve?
Yeah, I have pictures from the other side.
So you do?
Yeah, of course. I have like thousands of
I'd
pictures
love to see
and
them.
hundreds of videos, dude.
So it curves. Okay, let me ask this question. So from the other side, if I was to look, I would see this side here curving down. Is that what you're saying?
Mm-hmm. You'd see the almost exact same shape from the other side, except that from the other side, you get to see stuff like the Marriott Hotel that I'm in being obstructed by the horizon.
Okay, so both sides, there's a dip on both sides. So that must mean that the center, how is the center?
Here, let me post something that you'll see from the other side. It's pretty cool.
What we did is we completed the circle of that bridge, and it gave us like planet. I don't think you'll be needing 7/6R in that one, bro.
Wait, how many miles?
That hotel.
How long is that bridge?
About 24 miles. That hotel on the left side of the picture at 19 after the hour, that's the hotel I was in. But you're only seeing like 200 feet of it, and it's a 400-foot tall hotel. There's actually a building in between the two buildings. You see you see the very tip of another building on the right of the tall one on the left.
Mm-hmm.
In between those two buildings is a third building that is completely below the horizon, right there.
So let me ask you something. What do you think is causing? What do you think is causing the obstruction?
Well, the curvature of the Earth.
The curvature of the Earth. So the water is obstructing there, correct?
Yeah, correct. You're actually seeing it. You can see the line of cars going across the causeway on the horizon, right there.
Right. So if I'm at the shore now, right, where that picture is at 19 after the hour. If I'm at the shore, right, I'm seeing now what you're explaining. If I got you right, is I'm seeing the water obstructing that hotel, right?
Yeah, that's right.
Okay, so the water lower? I mean, is the hotel lower?
Here, let me give you
It's lower than.
Let me give you a better visualization so you can see what's actually obstructing it real quick.
Before you do that, there should be almost 500 foot of you should only be able to see about 100. I mean, shit, Earth should be hiding all of that Marriott. Every bit. You're
talking about
about 30 miles away. Plus, New Orleans is about 5 foot under sea level.
He's talking about drop,
Ryan,
not
can you
hidden.
give me a couple of minutes, please, man? I really would appreciate it.
If you actually do the calculation, you're seeing exactly what you expect to see on the globe.
So the water is causing the obstruction, correct?
Yeah, if you look at the picture I posted at 21 after the hour, kind of gives you
that GIF. That's a good looking GIF.
Yeah, it is. So let me get this straight now. So if I'm at the shore and I'm looking out, it's the water that's causing an obstruction, right?
Exactly.
So the water has to be higher than my feet, right?
No.
Then what causes the obstruction? If
the
water,
it's not a higher elevation. It is the same height. It's just fucking Earth curvature, and you know that.
So there's a drop then, not a hump.
No, there's no drop.
So there's a hump. There's a rise of water causing obstruction, but there's no drop there.
Correct. Yeah, it's all the same elevation. Good.
So there's a straight line of sight between me and the hotel, but yet it's obstructed by water.
Correct. Because the shape of the water is curved.
But how if the water is at the same level as my feet? How is it obstructing?
Level isn't horizontal. That's
because
why,
it's
and you know this
curved.
answer. How many times do we have to tell you this answer, SE? You can't think in 3 dimensions.
I'm not talking to you. I'm not interested in talking to you.
Of course you're
How many miles is that?
Let's let Stanley just have it back and forth for a second. Tries to be chaotic.
I was just gonna ask the last one you posted, Soundly. How many miles is that?
The The city, I think it's 28, if I remember correctly. I'd have to measure it again.
And is this like from a drone? Like, did you do altitude levels?
That's a drone. Yeah.
Is this stitched together photographs or an actual video?
It's a video that I stabilized.
Lake Pontchartrain's 33 miles away. I mean, the other side where he's filming from is 33 miles from the Marriott. So even if you take his elevation into account, you should see none of that Marriott, man. They just ignore this shit. And then also Travis went there and
It's not 33 miles, Brian.
and showed the bridge, showed the other power lines that you see from the side that are straight as an arrow. Except, I mean, look, we show the lasers curving up. So that's what happens with light in the distance, man. We've showed it.
We're not talking about lasers, bro. We're not. Give that up for a second, Brian, man.
Yeah,
He's talking about water.
I have to give it up.
Brian, listen, man. Listen what's going on here.
I think
He's
it's around 28 miles because I know the airport where I filmed the plane flying towards me when it went under the horizon. The airport was 28 miles away. And the whole airport, international airport, is under the horizon.
What are your thoughts? What are your thoughts though about similar observations that are further distanced where this doesn't occur, where you don't get this that type of obstruction?
It's 8.2 miles from the causeway. I'll post it real quick. Sorry to interrupt.
8.2 miles from the causeway. What?
No, but
I'm on the north shore. I'm on the north shore, looking across the lake at New Orleans. I think it's about 28 miles. In that drone footage.
Yeah, but how can you have water not rising or dropping, causing an obstruction? How do you square those? How do you square that circle there, Soundly? How do you do that?
The surface is curved.
Yeah, but you said that the water is level, right?
Mm-hmm.
Isn't that what you said?
Right.
So how could level water curve?
Because level isn't flat. That's why,
level
dude.
is
You know that.
So you have level water that's not humping
that?
or dropping that's causing obstruction.
We don't call it a hump or a drop because it's fucking conforming to the surface of the earth. It's not a hill. It's not a depression. It's just following the surface of the earth.
I think you could call it a hump. I think it's best
stupid. It's stupid to call it that.
The reason it's a hump is because if there's water in between, like a curvature of water. Hold on, let me just finish. If there's a curvature of water, if you were to draw a chord line through the water, a straight line, then it would essentially be humping over that chord line.
You'd call it a sagittarius.
To obstruct you. Yeah, it would
And
have
that's what
to.
you're doing by trying to look at
it's
the
actually-
skyline. You're creating a chord with your eyes, essentially.
It is a chord, but it's called a spherical cap. It's a three-dimensional version of what you're trying to say. That's what you're seeing there. Spherical cap.
Okay, sound me a visual experiment. I'm on one side of the causeway, you're on the other, right?
Mm-hmm.
Can we draw a line between me and you?
No. Well, I mean, you could, but it'd go through the water.
It's a chord, right? It would be a chord. So we can make a chord between my feet and your feet. I'm standing on one side of the causeway, you're on the other, right? We have a chord between my feet and your feet, right? Cutting through the water.
If you want to think 3D, yeah, you can call it a chord. That's fine.
I'm thinking reality. I always talk reality.
Well, it's not called a chord then.
What's it called then?
I'd have to look it up again. It's a spherical cap is the actual thing that's obstructing, and I think it's just a plane that's cutting. I guess it would be. It's probably maybe it is a chord plane or something. I don't know what it would be called. Actually.
Okay, call it whatever you want, but we can imagine a line from my feet to your feet straight, cutting right through the water, right?
Sure.
Okay, so then, what if that's the case? The water that we're cutting through, is that above our feet, above our eyes?
No, it's not above your feet.
So it's the same height as my feet, the water, from one end to the other, correct?
The same height from the center of the earth, correct.
I didn't ask you the center of the earth. Didn't ask you that. I said from my feet.
Because that's what it means.
Well, then you'd have to assume that the earth was a sphere, wouldn't you?
The earth is a sphere. It's not an assumption.
But
that's literally the shape we're seeing in these photographs. That's
okay. Call it whatever you want. We drew a line through the water between me and you. I'm on one side, you're on the other.
Okay.
The water, you say the water is causing the obstruction, right?
Right.
So if the water is on my side of the thing, is on my side of the causeway, is at my feet, your side is at your feet, what's causing the obstruction? How could the water possibly that's in our feet be causing the obstruction?
I've told you it's a spherical cap. You can go look it up and see what that means. That's what it is.
No. Spherical cap. What do you mean? Is the water rising between me and you?
No, it's not a change in elevation, SE. It's Earth curve. It's following a gravitational equipotential.
The geometry of the surface is the geometry of the surface is curved and level.
You are too intellectually unable to think in 3 dimensions. Everything is explained if you could think in 3 dimensions.
Look, dude, you said the water is at my feet. Yet somehow, not you don't count, paid. Soundly said that the water is at our feet, but somehow it blocks our view. That makes no sense whatsoever.
Because the Earth is curved.
How is that, Soundly? How is that correct, sir?
Because the Earth is curved. The surface is not a plane. It's a spherical cap. There's 2 different geometries.
So the Earth curving at my feet causes an obstruction?
The Earth curving between your feet and his feet. It is not a straight line as you understand it. It is a curve. It goes up about 80 feet.
You don't get it, dude. Why is it going up? Why isn't it going further down? If I'm standing on a sphere, I'm at the top of the sphere. It would only go down. Why is it rising?
It wouldn't go down.
That's what
It's
he's
not
saying.
rising.
Well, okay, you're right. It's not
But
rising.
you're saying there's an obstruction. It's causing an obstruction.
It's not rising from the center of the Earth.
Right, your eye line is slightly below eye level. You're looking slightly down to look through as a cord to the object in the distance. So since your eye line is slightly tilted downward, the amount of the surface that is above that cord is not rising.
So how is it blocking? If it's not rising to your eyes, how is it causing obstruction, sir?
Things behind
because it's a curved surface SE.
Yeah,
it's
but the
not
curve
really
is going
any more
down.
complicated
Is it
to
not,
say
doofus?
that the reason why it's getting in the way is because it's a curved
I'm standing
surface.
on a curved
There's
surface.
no reason
Anything in
why,
front of me should be lower
through this
than me.
conversation, we
Period.
have to repeat the fact that
Oh my
a
God.
curved surface is the reason why the surface is getting in the way.
You're redefining the geometry. Are we talking about the geometry of the Earth, or are we talking about the geometry of the line between these 2 people's feet and what happens between them? See, that's the problem. You're talking about a hump and a drop, and they're the same thing. Depends on how you describe it. This is your problem with your double nutsack bolt thing.
So soundly, if the curvature is that easily visible from just a drone, what was the altitude you took the drone up to at the top of that? If you had to try to remember.
I stayed under 400 feet because of FAA rules.
You have a double nutsack?
So shouldn't that be really easy to measure? Like, shouldn't that just be like a shot? If you can see it like that with the drone like that, and in the other like photos like that you've got, shouldn't that just be very, very easy to measure, and it should just be a shot and proven case?
Yeah, I mean, pretty much anybody could do it for themselves. It is an open shot case.
Yeah, that's exactly the point, Gio.
So what measurements have you seen or done that you feel like for you is an open shot, or have you done it yourself?
Well, actually, there was a collaboration between Walter Bislin, Jesse Kozlowski, and myself. And Jesse did GPS waypoints across the causeway. And then Walter made a 3D model. And then I took the photograph and the 3D model and the GPS coordinates. And which the GPS coordinates were plotted in the same 3D space as the 3D model. And then my photograph was placed behind them, and they all matched. So that seems pretty open to shut.
So, but I don't understand. I don't think you realize what you're saying. Like, this is like dialetheism. Like, you're believing in 2 truths. In other words, you're saying that the water both curves and humps and is level and at the same time causes obstruction. How do you I don't get that.
Well, how do you not get that? Because that's what our model
because
has
he doesn't
been
understand
this
it,
entire
Stanley.
time. So I mean,
He
you don't
refuses
understand our
to
model by this
try
point?
to understand it.
No, I'm calling your model out. Calling it out in the lane. Your model is ridiculous, bro. Makes absolutely no sense.
You say the model's ridiculous, but then everything, all the observations match it for some reason.
No, sir, I just proved you wrong. Just now, by your own admittance. You said that the water is level between me and you, and you said we drew a cord. There's a 90-foot hump. You're saying it's not there, and then you're saying it causes obstruction. And then I ask you why, and you're telling me it dropped. The complete opposite of what obstruction should be. It should be a hump, sir.
Let me
All the
clarify
same
for you.
thing. If SE, for fuck's sake, it depends how you describe it.
Yeah,
You
let me clarify for you.
You want either you are purposely misunderstanding this, or you are the. I'm trying to be nice here. You have a lack of intellectual capability to think in 3 dimensions. Or both.
We're not interested in what you think. I want to hear what Soundly thinks.
Yeah, let me clarify this for you. Do you think a basketball has a hump on it, or a billiard ball? Does it have a hump on it?
A billiard ball?
Yeah,
it's continuously round. I mean, it's a
okay,
continuous curve.
There you go. Now you understand. Now you understand the.
What do you mean now? Okay, hold on. Let's put you on a billiard ball, right? You're on top of the billiard ball, right?
Okay.
Okay. I'm on a little bit down towards you, right?
Okay.
What's causing obstruction between me? Is there anything causing obstruction between me and you?
Yes, the surface of the ball.
The surface of the ball.
Exactly.
Right? So the same way with the surface of your water, right? You should be able, I can see the curve of the ball clearly, plainly. I can't see no curve of your water.
Sure you can.
Where's the curve?
I just showed you a bunch of pictures showing it to you.
Yeah, you showed me what a drop is, right? And I asked you if that's the cause of the obstruction. And if you would have said yes, I would have understood. I would have said, okay, he thinks there's a hump of water between him and the hotel causing obstruction. But you're telling me no, the water is not doing that.
Hold on. Let's clarify again. Does the billiard ball have humps on it?
What does that have to do with what we're talking about?
I'm trying to get you to understand. You just said that the billiard ball has a continuous curve. So does the Earth. There are no humps. There's no humps on the water.
Okay,
but continuous curve. Now you understand that about the billiard ball.
Really?
So you have to understand that about a bigger ball.
There was 2 people standing in 2 spots on any sphere, bro. There'd be a hump between the 2 of you, regardless of what you want to think there is. If you were to look straight at each other, eye to eye, and your feet.
Stupid to call it a hump when it's a continuous
It's not
curve.
a hump. It's not a hump. It's just a continuous curve, like he himself described it on a billiard ball.
It'd be stupid to call it a hump because it doesn't exist. If it was like a billiard ball, we wouldn't see around it.
Well, it's like if you had 2 ants on a billiard ball and they were looking at each other and the curvature is cutting off half of the visual field of one ant from the other, vice versa, then
I guess
you
that's how
could
it
call
would have to
whatever
be.
you want.
Yeah.
In their model, though, it's just a curved surface.
Right.
And your problem
Thank
is
God I don't live on a model.
Why is that
and
so
the
hard to
problem
understand?
Is what?
It's a curve in light curves too, like everything else curves with it to make it look flat.
Hold on a second.
They have to bend it by 18%.
We're not talking about light right now. We're talking about the bridge. So what's the problem here, SE? Why can't you go from the ball to the proof of the Earth is a curve like a ball? What's your problem here?
Listen. I want to do a thing with Soundly. Soundly, you know what a lock system is, right? Water locks.
Yep.
Okay. Can you envision one, let's say 5 miles long?
Sure.
Okay. I'm on one side of the lock. You're on the other side of the lock. First of all, how do you envision the water in the lock to be? Can you envision that water being horizontal, level?
It's curved.
It's curved. Okay, fine. We established that. So now I'm on one side of the lock and you're on the other. We're 5 miles apart, right? I'm looking at the water now. I'm on a dinghy and you're on the dinghy on the other side, a small little dinghy. We're looking at the water. How does the water appear to you?
How does the water appear to me?
Yeah.
Wet.
Yeah. Is it dropping? Is it level? What's the water?
It's level and curved. Yes, that's what it appears to be every time I've looked at it.
It's level and
I did
curved?
also. Yeah, there's actually another observation point that's 7 miles long There's a boat ramp at one end. Also my channel, and it's clearly curved over that distance.
No, but okay, I got you. So the water is curving now. Is it curving from my end? What? It's dropping from my end? Let's say
No,
from my end of the
It's
canal.
not dropping. See, the thing, I don't understand why you keep thinking dropping. If you're standing on a billiard ball, right? Does the ball drop, or is it just curved?
Yeah, if I'm on the far end, if I'm on top of the billiard ball, and you're on let's say the 3 o'clock or 9 o'clock, I can clearly see a drop there, right?
Okay, so
there's no question about that, right?
The thing that you're calling drop, the reason you're calling it drop is because you have a perceived direction of down, and so from your perspective, the billiard ball is in like some type of environment where there's a down direction, so you can say that there's a drop. But if there was no down direction, there wouldn't be a drop, right?
Yeah, if there wasn't no down, yeah. So what, you're saying there's just up?
I'm saying that up and down is not based on the surface curvature. It's based on how far you are from the center of the earth. Same thing for the ball. If I'm standing on the billiard ball, is there a drop? No, there's not a drop because I haven't gone any closer to the center of the billiard ball.
Okay, if I was to look, we're on the canal now, right? You say it's curving, right? If I was to look at one end, or let's put it this way, let's say we start in the center. We're in the center, we're shaking hands in the canal, right?
Mm-hmm.
We're on the dinghy.
Yep.
Now, we start going back. We put it on reverse, right?
Right. Got it.
Now, this is a long canal, right? What happens? How do we, when we break apart from each other, we reach a certain distance, right? Are we going to see each other all the way through the canal, through the length of the canal?
No.
Okay. So at one point, we're going to lose vision of each other, right?
Of course.
Okay. What's going to cause that loss of vision?
Well, I mean, if you're using a camera where you can, assuming you're using a camera so you can see that far, it's going to be the curvature.
Yeah. We got P900s, yeah.
Okay, yeah. It's going to be the curvature of the earth, yeah.
So the water in the canal is going to cause an obstruction, and we're not going to be able to see each other because of the water in the canal causing an obstruction, correct?
Correct.
So does that water, how does that happen? Do we lower, like are we going down the billiard ball in your vision? Like what happened? How does that happen? Please explain that to me.
Okay. This picture I'm posting here is, basically a canal. It's underneath the bridge,
I
actually.
don't like the word hump, Montreal. You got to use like bulge or something else besides hump. They don't like it.
Yeah, I'm trying to not trigger. Yeah.
So, but you can clearly see the bridge is like actually wrapping over the horizon and going below the horizon in that picture at 41 past.
Right.
So that's what would happen. You would imagine people on that bridge surface right now. Once they get past that horizon, you won't see that car anymore. So
you're saying yeah, but okay, that's on one side of the canal. You're going to see a drop there, right? How about me on the other side? What do I see?
You'll see the same. You'll see the same exact thing. Yeah. So
we're going to see two drops, and those two drops of water are somehow going to block our vision. They're going to turn into I'm not going to say hump, but a bulge of water.
There's a spherical cap of water between you and them. Yes.
Yeah, but it doesn't. I'm trying to understand. If I have a drop,
the way you said cap, it's like a spherical cap. Like think of a little cap on your head, like a little dome.
Or like a dome. So like a bulge.
Yeah, I guess you could call it that. But I mean, it's just the continuous geometry of the sphere.
Is that what you think, Soundly?
They don't like to say bulge.
That's what you think.
If you dug in the ground,
no, that's not what I think. I think that
it is what you think, because that's what you said earlier about the billiard ball. It's a continuous curvature.
Well, if you dug in the ground over
hold on. I said that about the billiard ball, but about the canal, let me tell you what I think about the canal. I think it's perfectly horizontal and level all the way through.
Okay, you can think
measurable,
but everything that we've measured and photographed has shown that it curves.
Everything you've measured over long distance, you can get that effect. But any accurate short range
No.
measurement, you're not going to get that. How are you going to distinguish between the drop of the terrain and the earth curve? You're going to have to calculate it or something, right? How can you distinguish? If I'm surveying my way across Florida, how do I distinguish? How do I distinguish drop and earth curve, please?
Okay, those are photographs over water. We've already measured the surface of the bridge. It's the same consistent height all the way across.
Yeah, but they don't survey across water, bro. You know that.
I'm not talking about
I'm
surveying
sure you know
across water. I'm talking about GPS coordinates.
Well, we're talking about measurements. I'm not talking about GPS calculations. I'm asking a simple
GPS
question. If I'm measuring my way across Florida, 100 foot at a pop, like our forefathers did across their, states, their respected states, pretty much, and then some of them all the way across the plain. But how did they distinguish earth curve from terrain drop?
Again, we're talking about this particular case over water, and the causeway is easily measurable to be the same height across the water the whole time.
And anyway, I showed the wrong Marriott. Marriott you shot to was almost 40 miles, man. It was 47 miles to the Superdome, and I remember Mardi Gras, the parade in Endymion ended in the Superdome. It's only a few miles from the Marriott because that's where I stayed when your dad he was in Endymion.
That's either a gross.
I used to live there.
Or that's either gross incompetence or a straight up lie. It's not 47 miles.
Maybe it isn't. Okay, so the shot I just showed that said the Superdome is 23 miles from Lake Pontchartrain Causeway. Was that wrong? If it was, let me know. I know that Canal Street, which the Marriott's on, I posted the wrong Marriott, which said 9 miles away. That was the Metairie Marriott, which is right.
Dude, this is
9 miles.
This is not hard. You can literally just go drop a pin on Google Maps and measure the distance line of sight.
But tell me, was that wrong?
Why do I need to do it?
Because you're claiming I'm wrong. I posted that the Superdome is 23 miles.
You're making a claim.
Google made the claim, bro.
No, it did.
Why are you trying to change the distance of it? You're not even telling me a distance. You're just saying it ain't that. All I did is post the Superdome, which is 23 miles away from the Lake Pontchartrain Causeway.
Brian, I don't know why Google is telling you that distance to the lake, but I've been there. I've slept in that hotel.
There. I lived there for years, but I forgot. It's a long time ago.
Brian, it is on the water's edge. It's on the water's edge. It's right next to the
So it's not the downtown Marriott, then. It's not the New Orleans downtown
Brian,
Marriott.
whatever you're trying to claim,
I'm just asking. I'm asking a question, bro. For fuck's sake, dude. I'm just asking a question.
For fuck's sake, me? Are you serious?
I'm asking. So y'all are not talking about the downtown Marriott, then? Apparently, and I'm wrong. If you're talking about a different Marriott,
one in the picture. It's the one.
Is it the Metairie Marriott or is it the Canal Street Marriott? Or can you at least boil it down so I get the right information?
Go to Google Earth and find the Marriott literally right next to the causeway.
Okay.
It's actually a little absurd that you're being so confident about something you're so wrong about.
How far? I'm asking questions, man. I'm trying to figure out which one I'm going to do the calculation.
A canal can have drop on both sides,
I'm going
but yet block a boat.
I'm going to go ahead and do the legwork for this guy since this is completely ridiculous. But
I'll do it
Forget
now.
About Brian. Forget about that.
There's the Superdome to my where I took the photograph. 28 miles. There you go.
Okay, got you. Okay,
so
I got
what?
you now.
So what? So that means nothing.
No, it don't mean nothing.
Well, then why are we
I'm trying to make a point. I'm trying to figure out the supposed earth curve and the angle. According to them, if I take one side of the causeway, if I dig in the ground at just a little less than a half a degree angle into the ground, I'll pop up and hit the first floor. I'll hit the lobby of the Marriott if I dig into the ground under the canal at 1/2 a degree. And underwater, I'll pop straight out in the lobby of the Marriott, basically. That's their claim. They don't like to say bulge or they don't like to say hump or any of that. But
now you're talking exactly.
So, Sonley, let me ask you this. So what are your thoughts on observations over the Earth that are not this particular Pontchartrain situation, for example, where we see very, very far distances. In many cases, city skylines at 70, 80, 90, even 100 miles away, which is more than 4 times, the one you're referring to here. And the fact that we see an extended planar geometry, meaning that this curvature that you're showing here, or that you're calling curvature, why isn't this consistent all around the Earth? Because if the Earth was a sphere, that's what I would expect, and that would lean much more to it being a sphere if this actual physical geometry was everywhere, but it isn't. So I'm wondering what your thoughts are on that, and how you make sense of those observations where we see much, much further than a curvature that you're describing would allow for.
All the ones I've seen that people claim to be what you're saying have not been that. So like they've matched what we expect to see. There have been some people like Mick West that have done some like refraction calculators and showed what different levels of refraction could do to an image. That's part of it, obviously, for some of the long range shots. But I would say that probably more than likely it's due to some type of atmospheric conditions at the time.
Yeah, light bend.
That's the only way they get curvature, dude, is if they shoot over like 20 miles, 30 miles or further. They can't get it doing accurate close range. And I still ain't answered my question. The point of me asking that question. Hold on. The point of me asking that question is how am I? We don't survey over water for one. Okay, not even a quarter mile. We go around. Now, how? Like I said, it's very important. You said that it's measured, and I'm telling you that it's not, because the way we survey is up close and accurate. Okay, and I'm asking if I did across Florida, how do I distinguish between earth curve and terrain drop? The reason I asked that is so you'd realize. I shouldn't have to say much more than for you to realize. Hey, I guess you wouldn't know unless you calculated it. So the point is, we measure it level. If it's down lower, then water flows that way. We call it drop. If you want to calculate an earth curve, then feel free. That's what they've done, but we don't measure it. So don't try and say we measure it, because we don't measure it. They calculate it.
It's almost like all of your concerns don't matter if it's on a body of water.
Yeah,
I mean,
like,
I would suggest
sometimes.
you talk to Jesse Kozlowski.
Well, you have to bend it 18%, right?
We'd love to talk to him. Tell him to pass by soundly. We'd love to talk to him, brother.
Geodesy is a thing. I mean, there's actually
it is. It's a thing. They turn in their calculations. They plot it.
You're just interrupting people, man. Please.
Sorry, man.
I think Stanley, what were you saying? I think he interrupted you.
I mean, obviously, I'm not an expert I'm not a surveyor, so I mean, I take photographs. But Jesse Kozlowski is a surveyor. He's done geodesy work, and I mean, you can talk to him, look at his work. A lot of his work is posted on his channel. It's also like part of that image that I posted that shows, like, I'll post it again real quick. That shows all of the his measurements mapped in 3D space. Then the 3D space is showing a curved bridge, curvature of the Earth, and his GPS coordinates mapped directly to that. I mean, it's
I was gonna
pretty ironclad. I'm not real sure.
Yeah, I was gonna mention something on that earlier, because we brought that up. So when you say ironclad, however, that does depend on you depending on the GPS system that you can't verify, right?
Well, we know the GPS system works
to a certain degree, but I mean, in terms of being able to measure something like curvature like this, you're over a fairly short distance. You're basically just completely depending on those signals that you don't have a way to verify exactly where those devices are or what is actually being sent, whether it's an authentic actual system.
Well, yeah, if you want to claim GPS doesn't work, I guess that's a whole nother thing you'll have to convince yourself of.
No, we ain't claiming it don't work. We're claiming that the measurements we're getting are not from satellites curving over our head. They're either from.
It doesn't really matter.
They're either
measurements are.
If they're above our head, they're level with each other, and that's the same math. If they're level from each other and the ground's level, or if you want to curve them and curve the ground, it's the same mathematics.
Okay, so let's forget about how GPS is actually implemented for the moment, and just ask the question: are the coordinates accurate?
Right, that's the question. But in terms of the actual curvature, as it were, or non-curvature of the actual surface, because that is different than just having a system that'll work within certain grid points that match close enough on either type surface. I didn't really explain that very well, but what I'm saying is that
they say the horizontal datum is pretty accurate.
This is like 3 centimeter precision right here.
No, it ain't. No, it ain't. And in fact, I'll show you the president of geodesy, the current president of geodesy, saying that anybody who tells you that doesn't know that the best horizontal is like 4 centimeters, and that's the best unless you're using local towers. Hold on. Unless you're using local towers for like what they're doing with some nowadays construction and shit. And here's the thing: the vertical datum, as far as GPS, is grossly inaccurate. It's nothing like the horizontal datum, which is accurate. Okay, so right, left, straight forward. Okay, but the up and down is not nearly as accurate.
When you say
as
grossly
more inaccurate than the horizontal datum.
What are we talking about?
Yeah, just hold on, Brian. I want to hear you answer that. What kind of error? However, what you just said right there, like perfectly aligns with what I was, in a sense, trying to say before. The difference between because the vertical datum has to be different, the 8 inches per mile square, which is very minor, compared to like you were saying, the actual horizontal, the up, forward, left, right, straight forward, and backwards. In terms of that, it's like the two different planes of the geometry, and so. That's what has to be accurate. That the vertical one of the 8 inches per mile squared is what has to be accurate for what he's referring to be the case. But Brian,
I would say that again, this is Jesse Kozlowski's domain, and the coordinate system is Earth-centered, Earth-fixed, which is basically just a 3D Cartesian coordinate system. I mean, he's just mapping X, Y, and Z coordinates onto a 3D space, and it is exactly what we expected to see if the Earth is a globe. So, I mean, if you don't like the data, then I guess you could do it yourself, figure it out.
Like I said, no, you can map it however you want, and if you map it as a ball, and you have the signals curving instead of flat and the ground flat, if you have the satellites curving and the ground curving, then it better match that. Then it better match that, right?
You didn't hear what I said. Earth-centered, Earth-fixed coordinates are just X, Y, and Z coordinates. They're not polar coordinates. He's just mapping coordinates in a 3D space.
So you don't claim the 2D ball, the 2D surface of Earth? You ain't one of them type?
What the heck are you talking about?
What does that have to do with it, Brian?
Because it has a lot to do with it. Because half the arguments we get into, I got to restructure my whole argument with the 2D surfacers or the 3D surfacers.
It has nothing to do with that. The coordinates in question are Cartesian coordinates. 3 of them. And they're all, Brian, they're all linear progression coordinates. All 3 of them.
What's the most accurate vertical datum we have?
Jesus Christ. What does that have to do with the Cartesian coordinates, Brian?
I'm just seeing what you know, bro. Do you know which datum we have? They're all different. They're all different. That's why I asked, because they're all different.
Right. I know that Cartesian coordinates have nothing to do with datums.
If you don't have a clue of what you're talking about, why don't you stay out of it then? If you don't even know, you can't even name a datum. Can you even name a datum?
Yeah, NAD 88 is a datum. Brian, Cartesian coordinates do not have anything to do with datums.
No shit. And yeah, they do.
So then hold on. You guys are going to. When I said the Cartesian coordinates have nothing to do with datums.
This is called veering off course.
What's the most accurate datum?
Bullshit, Brian.
Yeah, I actually hold on, you guys. I have another question for Sonley, real quick. Sonley, I was going to ask you, in terms of the GPS coordinates that you're referring to, and the bridge. What ideas would you have, if there was funding and so on available, as a way to verify that not using GPS?
I would suggest creating like a 4-kilometer long vacuum tube, shooting a laser down it, seeing if it requires us to take into account any curvature of the Earth.
Yeah,
kind of like LIGO.
Real quick. He already tried it, though. He already hung lights. Yeah. He tried a different test. He tried to hang lights. It was one of my last videos. And he was getting the reverse effect, and then finally it showed a little bit of curvature, like right after the sun was about to rise. It showed the lights bending up, bending down. It showed them straight. So he set them like a few miles apart, or however far apart they were. But
That's why you have to do it in a
did-
vacuum.
I'll give you props for making the effort, though, Stanley. I'll give you that.
You
for going
take
out
a
and
break
doing
for a
it.
second, Brian. Could I ask him a question about this vacuum tube of yours? How do you see the light going in that vacuum tube? You think it's going to follow the curve of the Earth or something like that? Is that what you're thinking, Soundly?
No, I'm thinking it's going to go straight, and then you'll be able to tell that the surface underneath it didn't.
Sorry?
I said I'm thinking that it would have to go straight, and then you could be able to tell from that the surface beneath it did not.
Right, the surface starts deviating away from it, essentially.
Okay, that's what you're thinking. All right. I thought you thought the beam itself would curve because that's what they were saying before.
Remember, to them, a
That's in the
a
atmosphere.
4 mile
That's why I
flat line is
suggested
going to be
using a vacuum
slightly
tube.
concave.
Hey guys, I have to go. I have family trying to go to sleep.
One more question before you go, Soundly, please. You brought up LIGO. So you envision the
Actually, somebody else brought up LIGO.
Okay, since we're on the topic, one more question, if I may. You said that the arm of LIGO, the beam of LIGO is straight, and therefore the Earth curves beneath it, right?
Right.
Okay. Then you also said about the bridge and the water that it's actually the water curving, correct?
Right.
Okay. Now there's
Well, the bridge is curving too. I mean, it's
yeah, with the water. Now there's a canal next to the arm, all the way down to 4 kilometers. How do you envision that water next to the arm?
Are you talking about LIGO again?
Yeah, LIGO. Yeah, there's a canal right next to it. It used to be full of water. Now it's kind of murky and stuff, but it used to be solid, like no obstruction, all water. How would you envision that water?
Which LIGO has a canal next to it? I mean,
The one in Livingston.
I'd envision it curving.
You envision that water curving.
Right.
Okay. All right. Fair enough. Thank you, sir.
Very quickly, 10 seconds. Shout out to Soundly. Soundly, good to hear you, man. Hopefully everything is well. Check on your DM, man. Join my server. Let's talk one day, man. It's Jose.
Hey, Jose. What's up, man?
Good to hear you,
Good
man.
to hear from you.
Yeah. Join my server, and one day maybe you'll catch me live, and let's have a chat.
Sounds good. Send me a DM.
Catch up.
All
We'll do, man. Take care.
Later.
Don't be a stranger, Soundly. Come back, bro. We can have more talks. And if you can bring Jesse, that would be really good.
Yeah, thanks, Soundly. I think you're pretty sharp. I think I agree with almost everything you said.
Thanks, guys. I'll try and get Jesse in here, but I don't know. I don't have high hopes.
Try. That's the best you can do, bro.
Well, the only problem I have with this Earth-centered, reference frame is: did we send a signal to the center of the Earth and bounce it back to justify these XYZ coordinate systems and their distance? No, it appears to be assumed from the GS84 model, and so for the purposes of finding out the shape of the Earth, it's assuming what must first be proved. Therefore, It's inadmissible. You need a straight line standard like a laser, going straight and true over the land and showing deviation of the land relative to the laser. And
Are you in a closet, Lemon?
Something like that, yes.
Yes, I agree with Lemon. The purpose of GPS is to give accurate information. It was never to prove that the Earth is a globe. That was not the purpose of GPS.
Right, and so using it it's inadmissible because it assumes what must first be proved. It's modeled off of a globe. Therefore, using something that assumes a globe to prove a globe is begging the question.
Sure, but we can use GPS and say that it's at least internally consistent with the globe.
Yeah, but that wouldn't be a surprise because the same people telling us it's a globe, government agencies, et cetera, are also the ones behind GPS, the military and so on. So, of course, they would have that synced up to the best of their capacities.
Well, they did a pretty good job.
Right. The question is the accuracy of it and the actual legitimacy of the signals, because the signals are completely dependent upon how it's used and how it's interpreted. Hence the distance of those satellites and all of the different factors involved.
So you think GPS is fake then?
I don't know. I don't think the word fake is necessarily the best word. I think the word spoofed, like an electronical spoof, like SPOOF, where essentially they are sending signals. Those signals are correlated to a particular set of coordinates within certain sections of the Earth. But that doesn't mean that the signals they're giving are actually legitimate in terms of what they're actually claiming they're sending, which means it's like spoofed essentially. It's almost like catfishing in a way. Like they're giving certain coordinate system. And there's actually a thing called GPS spoofing where like they do it like military, where they like attack another military and they basically set up signals that send different information to the person's GPS to like lead them into a different area of the Earth, things like that. So it's actually a thing in that way. But I'm actually referring to the entire GPS system having a foundational level of that illegitimacy in terms of the signals being spoofed to show a certain layout.
Right.
Not to mention, Joe, they don't even claim to be that accurate with the vertical datum. They don't even claim. I mean, look at even Google Earth. You know, I mean, it's not that bad, but still you're going to get variations in vertical. They don't even claim that the vertical is that accurate with GPS. There is a different kind of GPS, local GPS systems that come from local towers where you can get greater accuracy. But the general GPS system that we use, yeah, like I said, they don't even claim to be that accurate vertically, but they claim to be pretty horizontal.
Brian, it's the complete opposite direction. If you have ground-based towers, you have an ambiguous region at which your altitude could be. In order to disambiguate that, you could get a better GPS signal from the sky. That'll give you a better altitude. You've got it backwards, Brian.
Okay, well, speak on something you don't know about. Okay, there is a system that zeroes in on local towers. Okay, if you're doing local projects, that is very, very high precision accuracy. Okay, if you don't know about it, look it up.
Just claiming
I don't know. You taught me that. Blue Marble Science taught me that.
Right,
Argue
Brian,
with Blue Marble Science.
just claiming I don't know does not address what I actually said. What I actually
Blue
said
Marble
was
taught it to me. Okay, so take it up with him, pal.
Have a very wide, ambiguous range at ground-based altitudes. That's not me saying something I don't know about, Brian.
Take it up with Blue Marble Science because he's the one who pointed it out before I went and looked it up. Okay? You have no fucking clue, obviously. I didn't either until Blue told me and I went and looked it up. And there's a more accurate GPS, okay, with local total stations that use local towers and it zeroes in, okay? So he's who taught me. So if you don't believe me, then take it up with him and take it up with the
You're
research.
remembering it incorrectly, Brian. What you're talking about is RTK, and RTK requires 2 GPS receivers. Those are locally connected to each other. We're not talking about a GPS anymore at that case.
Bro, the vertical datum, they don't even claim is that accurate, okay? The normal GPS system.
Yeah, that's the important part. What he's saying because if you have a horizontal datum, if you have a horizontal datum and a vertical,
but it's a lie, Geo.
Hold on, man. Hold on.
Geo, Brian is actually lying, though.
Doofus, I think
he's full of shit, dude. You're full of shit. Calling me a liar. Prove that the horizontal datum is more accurate. I mean, it's less accurate than the vertical datum. The vertical datum, admittedly, is less accurate.
Right.
Brian,
so what I was saying,
when you're using GPS, the tower-based GPS service. What the fuck?
He doesn't even know the most accurate datum we have here in America. He doesn't even know that, and he's just talking shit.
All right, so
NAD88, I already mentioned it in this very conversation. Thank you, Brian.
Keep interrupting me, Doofus. Let me just finish what I was saying before. So if the vertical data, you need a horizontal and vertical datum to both be at a level of accuracy that you could decipher something like the curve of the Earth's surface. You would agree, right?
You use both the horizontal and vertical datums, yes.
Right. So it sounds like what Brian's saying is a difference in the accuracy of the two. So can that just be looked at first? Like what is, I mean, do you agree, disagree? And then Brian, what is your evidence of the the difference in the vertical versus the horizontal?
I'll post a video real quick of of the president of Geodesy, or he was it when he made this video, saying that anybody who says they can get within 4 centimeters doesn't know what they're talking about. It's straight from the head honcho, one of the head honchos. I don't know if there's one exact head honcho, and it's a miracle I haven't put this video out yet. But I've looked all into this thing, and like I said, they admit, and he did get it right after he went and looked it up. The North American datum, is the most accurate. But they're all different.
After I looked it up, Brian, I said it immediately.
Yelling right in the middle of me talking, bro.
Yeah, I didn't. It wasn't after I looked it up. I said it immediately. The moment you asked me, I didn't have any delay whatsoever.
All right, hold on, Doofus. This is like a really aggressive interruption. Brian, you want to finish what you're saying, and then Doofus, you can respond.
Yeah, okay. And when I said just tell me any datum, you said that one. But anyway, I'll retract that. But the thing is, you just threw me off, man. But the thing is this, is there's different datums, okay, that GPS could use, okay, more recent ones that would give different results with the vertical datum, right? So which one is accurate? Okay, some of them have rivers flowing uphill in certain regions. They're all different. So you're going to say they can claim that this one's the most accurate and all that, but there's several. There are a couple dozen different datums. There's a worldwide, there's the local. I mean, they don't shoot over water, so even Puerto Rico is going to have its own datum, or the Florida Keys is going to have its own datum. Any island, they don't survey over water.
No swearing.
But my point is they don't even claim that the vertical datum is as accurate as the horizontal. They really don't. They don't claim that. Admittingly, it's not as accurate because there are different datums. Period. So who's to claim which one is technically the most accurate, and for what region is it the most accurate? It's all just systems. It's all mathematics. It's all calculations. Okay, so it better match a ball if it's calculated to have curvature, and it didn't match a ball if we used it. Then I'd ask questions. It's mathematics.
Could you meander any more?
Right, and is the statement that you're referring to considering RTK? Or is it excluding that technology? Do you know, Brian?
He's Googling RTK right now.
No, I'm not.
Yep.
Hold on. Hey, RTK is the local with the total stations. I ain't Googling shit, dude. I'm on my phone. RTK. Are you talking about the latest? The very latest? Or are you talking about the older shit?
It's the latest or the older shit. I'm talking about RTK specifically, Brian.
I'm talking. All right. Well, are you aware of the ones that link up with the total stations, the Wi-Fi, the new equipment?
The Wi-Fi. It's not Wi-Fi.
With each other, they link up with towers, with local towers. You're aware of that?
They communicate with each other. They're not communicating.
I'm not talking about them.
Towers.
I'm talking about total stations that communicate with every local tower in range.
RTK proper, just RTK itself, is just the total station and the remote unit. They're communicating with each other.
That's been out, bro. That's been out. I'm talking about the GPS. I'm talking about the latest GPS. The local, the most accurate they have.
What?
Let me find something to post, man. Let me find something to post for you.
I wonder what Soundly and his buddies used. He made a video on it. They probably talk about it in the video.
Well, I'm wondering how GPS works at all in the middle of the ocean, hundreds of miles from any balloon or ground station or anything. It must be satellites.
You'd think so. Yep. It's regardless of how it works, I think it's really incredible that it is perfectly consistent with the Earth being a sphere. And the only way to explain that away is to assume that whoever has made it has perfectly redesigned it, which would be akin to mapping a sphere onto a flat map with no distortion.
Well, it's vice versa. They're taking the actual planar geometry and then putting that into a spherical coordinate system that partially fits and partially doesn't, but it fits enough that they have been able to pull the wool over the eyes of the civilian population.
Well, and even geostationary TV satellites, how do they stay up there for all that time? You know, remember in the 1980s when they had those huge parabolic antennas pointing straight in the sky and never moving?
Yeah, I mean, you can have communication signals that are either being relayed or sent from devices up in the sky, for sure.
But not in a consistent way that would, I mean, you'd have to have a satellite. A geostationary satellite is the only way to do that.
Hey, Brian, if you're picking cherries, make sure they're ripe, all right? Boom.
What's up, Jose?
Good, good. Just telling Brian if he's picking up cherries, make sure they're ripe at least.
Matthew, you're forgetting that flat earthers believe in magic.
Let's find some
Roger
pictures
that.
of a C-band dish. Here we go.
What's your definition of magic in that case?
Technology that's mysterious and unknown, but you claim just exists.
I got one. Some magic happening from in the atmosphere, like a big ass lens, magically making things appear like the same size like the sun and stuff as it goes down in the horizon.
Yep.
Yeah, like an adjustable lens that creates a field between you and that object.
My favorite example is that the full moon appears the same size all night because it's really easy to see the apparent size of a full moon.
There's many.
Amazing. I guess I'll have to take the opportunity, Gio. But yeah, the people that can't trust their eyes claim that you believe in magic. Boy, that's a good one.
I trust my eyes, for instance. I see the surface of the Earth gets in the way of things in the distance.
I trust my eyes, but not quite 100% because I use glasses and a lot of people.
Yeah,
so
yeah, you don't have a
cannot
claim.
trust our
Yeah,
eyes.
you don't even have a claim. That's okay if you don't trust your eyes. Some people live in reality, so that's okay if there's a little group of people on the internet called Glober atheists that don't trust their eyes. That's okay. The world won't notice.
Even
A little group is all professionals that operate working on things that have to work with the way that the surface of the Earth is.
Flat. Yeah, it's flat and stationary. 1988 Dryden Flight Research Center, NASA. Yeah, that's real difficult for you to understand. Yeah, I'm not even a flat earther. They are. Actually, NASA's flat earthers. I'm not. That's what's hilarious about this.
The aircraft model built for linearization, that model is designed for a piece of equipment.
Have you used the model?
That model is designed for a piece of equipment.
Have you used the model?
Hold on, man.
Designed for a piece of equipment.
Hold on,
that
bro.
model is designed for a piece of equipment that had to be installed on a mobile aircraft that has a very limited amount of computational power.
what's the
The reason
equipment?
why they had to do that
Okay, what's the
linearization.
Let me know when you have a.
The reason why they had to do that linearization is because of that limited processing power. So they linearized the fuck out of it and made the things that had the least amount of potential for causing a difference in results. They minimized those.
Right. What was the piece of equipment called? Was it a joint direct attack munition? Was it a drop tank? What was it, doofus?
Were you talking about the linearized aircraft model?
You said it's a piece of equipment. What is it?
Okay, so let's try this again.
Yeah, that was easy. Yeah, thanks for
we'll,
playing.
We'll try this again until you allow me to finish talking without
no answer,
interrupting.
no claim.
Just keep doing this
No
until
answer,
you
no
allow
claim.
me to talk
Gio.
without being interrupted. We'll just keep doing this until you allow me to talk without being interrupted.
Yeah. All right. Yeah. XO, bro. Let's not do just the barrage of shit show stuff. So
The model you're asking about.
Can I get an
that's the
answer?
linearized aircraft model, correct?
No, what's the piece? You said equipment. Now you're hiding from your own claim. So this is way too easy. You're scared to death of your own words. There's nothing you can do about
For
it.
fuck's sake, dude. The model that you are talking about
What's the piece
is
of
the
equipment?
linearized aircraft model, correct?
Yep. Scared to death. What's the equipment you mentioned? Is it a joint direct attack munition? Is it a drop tank?
You have no brains.
It's like shooting dead
brains
fish in
in
a
your
barrel.
head, dude.
Okay, okay, I'm
You
done.
gotta let him
Have a
answer,
nice
though,
night, guys.
XO.
He already committed suicide. That was easy. Thanks for playing.
You didn't even let him speak.
Have a good.
I think he's been drinking.
That's par for the course for him. He just goes in and rumpuses everybody, claims victory, then leaves.
We just got a drunken hit and run right there. But Doofus, all right, go on with what you're saying. I was following it, but yeah, you weren't able to. I don't know what you were getting at.
Right, it's a piece of avionics equipment. It didn't have a whole lot of processing power available to it. So what they had to do is just remove as many variables as they could, and they removed the ones that had the least change in the operation of the aircraft as possible. The aircraft, in any given point of time, doesn't really care about the curvature of the Earth. It cares about what air it's currently flying in. And that one point of time is all that it needs to make calculations for. And so that's why they did it that way.
Okay. So this is why what? I guess
yeah, he brought up a thing about an aircraft model, and he didn't even know what he was talking about.
All right. Well, so if you think GPS could plot coordinates that are around a curvature of the Earth, what ideas do you think you would have around ways to verify that and actually see if it's curving along the actual Earth or whether it's level? What ideas could you have to verify that?
Perhaps travel times from one location to another and see if it's accurate based on the speed.
Distance and speed verifications.
You can get more specific, more targeted than that. The signals themselves, they embed ephemeris and time, and you can find out from those signals and the incoming frequency that they're at, how fast they're going by you, what the time relative to the various sources. You can get a software-defined radio to give you all of that information. Excuse me. And there are postings online of software-defined radio kits and builds that you can do to actually find out how GPS works. It turns out the signals are Doppler shifted as something passes you overhead on the order of thousands of miles per hour. So it kind of ruins the whole towers idea.
For example, if we created a straight level wall, 6 feet tall, boom, perfectly level, with water levels and so on. Now that already would show whether there's curvature or not. However, let's just say that we have that.
No, well, no, it wouldn't. If you're using water, which you say is level, to build your wall, you haven't confirmed whether or not level is flat or curved.
Well, right. I mean, it gets into verifying. That's what I'm talking about, though. Like if you have water levels, but I'm just saying for a moment, let's just say we have a 6 foot tall a 6 foot tall wall that is level. And when I say level, I mean horizontal, like not on a sphere, but actually horizontal. And there is even horizontal on a sphere if you want to call it, tangent to the radius and all that stuff. But I'm just saying that actual horizontal. If you have a wall that is that thing, that absolute level, flat, horizontal, planar, whatever word you want to use, and then match the GPS coordinates to that. Now, if you know you have a physically level wall and those coordinates are telling you it's on a sphere, then that has been falsified. Meaning that it's not actually showing you that the Earth is curved, but is actually just giving you that in their model and asserting it that that's what it actually matches up to on the ground when it doesn't actually match up to that curved surface.
So how did you confirm that the wall was straight or horizontal, as you would say?
Right. That's therein lies the key for doing this.
Very easy. Use a water level. Plumb bob. Not hard.
You understand that on a spherical Earth, that would just make a curved wall.
What are you? A curved
But
wall?
you wouldn't solve anything because your wall would be at the same difference from a water reference.
Well, you have to find a way to level up the water yourself. Like, yeah, if you can create some kind of a reference of showing what the water level is, what the line is that touches the top of all the water levels, and that being a horizontal line, if it was a sphere, would eventually start deviating from the sphere. Like it would start shooting off into space as the sphere curved away. If that doesn't happen and it's just consistently parallel the whole way to that actual level line, and you're verifying that it is actually level and that water is making that straight line, then there's no way that there's curvature.
Right. But if on a spherical Earth, the water wouldn't be making a horizontal. See this picture here? You have the top option and the bottom option are the two to choose from, not the middle option. The middle option is not one of the choices.
Are you saying a water level cannot make a horizontal plane of reference?
2 points on a water level can make one horizontal reference.
In between, and how about in between those 2 points?
Right. That horizontal is only perfectly horizontal for the middle between those 2 points.
You see how they think? See how they think? Yeah, only 1 point they can establish level. It's incredible.
No, it's just because
if the Earth were spherical, that's what would be the case.
If Santa Claus was real, I'd get presents, all the time.
It's not helping, SE. How would we actually go about confirming that the top of this wall follows a straight line?
Yeah, a straight line. A water level makes a horizontal plane reference. Yes or no?
You can make one reference with the water level. That horizontal reference that it creates is only horizontal for the midpoint between those 2 points.
Yeah, I know how you think. It's ridiculous, bro. So in other words, if we take a spirit level, right?
Just saying it's ridiculous is only your opinion, SE.
It's not an opinion. I'm going to show you how ridiculous you are. If we take a spirit level and make it a mile long, and we have bubbles all across that every 2 inches, you're telling me, or what are you telling me? How do you envision that? If we have a mile-long spirit level, perfectly straight and level, horizontal, how do you envision it?
How did you confirm that it was straight? That's the purpose of the conversation, SE.
You're kidding me right now. A level, a spirit level, like 6 feet. You don't think that's straight?
6 feet, we can probably make it pretty darn straight. Can we do it over a mile?
Double, triple that. Let's make it 100 yards. You're telling me that it's only going to be level in the center of that spirit level? Either end is not going to be level?
If you have the manufacturing needs or the manufacturing means by which to produce it, but you haven't come up with that yet, SE.
You see how they think? They cannot say that it's going to be level at their model dictates that level is only at 1 point.
Right. It changes every different point. That's because the Earth is spherical.
That's ridiculous. So I can't make a basketball court?
Right. You're just saying it's ridiculous. That's your opinion.
Okay, how about a basketball court? How do you envision that? It's only level in the center?
Right, you're using the word level here. We've been trying to create a horizontal.
Can we create a perfectly horizontal and level basketball court? Yes or no?
By what means?
What do you mean by what means?
Can it be
by what means?
Done? Can it physically be done in your mind to create a perfectly planar, something like the size of a basketball court?
Right, to make a perfect plane, we can use the 2 points of reference, right, from one end to the other.
What?
You have to consider, of course, optics in this scenario, but
what tool would you use?
Right, if you only have 2 points of reference, you are free to use a water level. However, you have to keep in mind that while you're looking from one end of the water level to the other end, optics must be considered.
Negative. That's the whole thing of a water level. It's specifically designed so you don't have to check it like that. You don't have to eyeball it. It could be around. It could be on a different room. I can be in one room, go around the corner, right, where it's not visible, and I can establish the horizontal plane of reference, sir.
Okay, yes, you can make more horizontals. You're allowed to do that. However, if the Earth is actually spherical, those horizontals are not necessarily parallel with one another.
Right.
This is the thing you guys have to say to support your model. You have to go against physics, against reality, man, against water.
That's your opinion, SE.
Well, maybe it is my opinion, but, you know, you're not making a very strong case for yourself, I'll tell you that.
Just
All right,
because
try
it's
it this way,
complicated
SE.
doesn't mean it's
Take
false.
that one water level and put 6 risers in it. All of those will have the same elevation above a reference surface. Now, we still don't know whether or not that reference surface, the thing that water level is giving you a reference above, is flat or curved yet. Do you see the problem?
No, I don't see the problem at all. Because I know that a water level...
Problematic.
No, the problem is you, bro. Because you have to envision
Because I'm not assuming the
sphere.
Earth
You have
is
to
flat.
put everything... Sorry?
Right. The problem is I'm not assuming the Earth is flat and you are.
No, the opposite. The problem is you always assume you're on a sphere. That's how you start all your thoughts and all your explanations, bro. That is the problem.
No, the presumption I made is that the Earth could be 2 different shapes. Here we're competing in this specific scenario that the Earth could either be spherical or flat. I'm not assuming either one. I'm assuming that it could be one of those 2 choices. Given those 2 choices, we don't have sufficient information to determine whether or not a level surface is curved or flat.
Okay, on your model, right? On your model, can we make a basketball court level and horizontal? Yes or no?
Not simultaneously.
I agree.
Not
The answer is no.
simultaneously.
Right, level.
What would differ? What would differ
we can do
between
level,
the
or
level
we
and the
can do
horizontal?
horizontal.
Excuse me?
We can either do level or we can do horizontal. On a smaller scale like a basketball court, it probably doesn't matter, but something on a larger scale, it would.
Why?
Because the difference between level and horizontal becomes more significant the more distance. It's a geometry thing, SE.
And the reason is this globe,
the curved
right?
surface is curving farther
There
and
you
farther
go.
away from a
You
horizontal
can't-
reference.
My point is proven. Everything you do, you put through the globe filter. And I just proved it right now.
Yes, if you ask us how it works on a globe, then we assume a globe and give you an answer about how it works on a globe.
Yeah, I don't see the problem so far, SE.
Okay, so in reality, forget globes and forget flats, whatever. In reality, where we are right now, in reality, can we make a basketball court level and horizontal? Yes or no?
The answer depends on what your preconceived notion is of the shape of the Earth.
Right, we have 2 choices again, still, SE.
You see, right away you go to a shape. I didn't ask you a shape.
Because there's a difference to your answer based on the preconceived notion.
See, that's where you guys are. You have
Is there though? Because he's just saying making a planar court, a planar. Why would
the method by which to do so?
Planar is planar.
The method by which to do so depends upon the shape of the level surface that you're referencing.
Yeah, let me try to answer his question in detail. Let's say that you do succeed in making a basketball court that has straight lines on the surface. In other words, it's a perfect plane. In fact, you get those telescope grinding equipment out, and you make sure that it's perfectly straight. I'm using straight, not flat or level on purpose. The perfect straight lines across the whole basketball court down to the nanometer scale. And furthermore, let's say the very center of the basketball court is straight down. It's perfect. Like the basketball court is exactly 90 degrees from straight down. Now,
but let me interrupt you just briefly.
Okay.
By straight, do you mean that court is not higher or lower at any point?
Well, that's coming up. By perfectly straight, I mean that it goes in a perfectly straight line. Like that's all I mean, just straight line. Now the question is, at the edge of the basketball court, is straight at the edge of basketball court is the straight down at a 90 degrees to that basketball court. And on the globe Earth, the answer is no. On a flat Earth, the answer is yes.
You mean perpendicular?
Perpendicular, I meant, yes.
Right. That still doesn't answer the question. You see, right away, you're going to a model. Right away in your head. You must. You're brainwashed, bro, but you don't realize it. I don't mean that like derogatory. It's just a fact.
Oh, I'm
Think
sorry.
about it, and you're going to see everything you answer me from here on in, you're going to imagine a globe in your head. You can't help it. I didn't ask you for a globe. I asked you if we can build a basketball court level and horizontal here where we live. Yes or no?
My answer is that it depends on your preconceived notions. You cannot answer that question unless you first decide which of those two things you're assuming.
I rest my case. I have nothing further to say.
Your case is not very good, but okay.
But what else can I tell you? I mean,
right, you're
upset
you're upset that we haven't chosen specifically that the Earth must be flat as our preconception. We're not going to do that. We're going to give you what would necessarily be the answers are generalized so that you know that there's a difference between the two. You can't just assume the Earth is flat and say, well, this is what it would be. That's not going to work, SE.
Doofus, you don't realize that you're proving my point. That's not my point. My point is that you can't give an answer without bringing Big E into the picture, your model. And every time you talk, you're just proving my point, bro.
Well, neither can you. I'm saying that neither of us can answer your question without first assuming one or the other models.
But I didn't assume it. I didn't assume a model.
Right. Yeah, you're saying level is equivalent to horizontal. That's assuming a model, SE.
I didn't say that either. I said, can we make a basketball court with the NBA
level
standards,
and horizontal?
Whatever?
Did you use the word and?
Did I use the word and? Maybe
yes,
I did.
Level
Yeah, is that
and
against
horizontal.
the law or what?
Yeah, the problem is, if you assume level and horizontal can be a simultaneous achieved goal, you're saying level and horizontal are equivalent. That only can happen if the Earth has no curvature.
You see, again, you're going to a shape.
No, that's you, SE. You're assuming that level and horizontal are equivalent. That requires you to assume the Earth has no curvature. That's you doing that, not us.
In other words,
I'm not assuming anything. I'm simply asking you a question.
In other words, there's shape built into the structure of your question. But if you change the question to say, if you build the Platonic ideal of a perfectly straight-lined basketball court, like I said, down to the nanometer scale, the answer would be, okay, yes, we can do that. But now the question is that Platonic ideal of the basketball court with straight lines, is that everywhere level or is it not? That's the question. And we say no and you say yes.
But you don't see your model afflicted, bro. And I don't say that with any prejudice. I was also. Everybody is in a certain
you
degree.
Currently are, SE.
No, I'm not. You are. I'm not. I never mentioned the model. I never mentioned the shape. I just mentioned
you did
a basketball court.
Well, yeah. When you ask, is it possible to make it level and horizontal? That's you assuming something.
No, I'm asking a question. So you're saying that there's a difference between level and horizontal, correct?
If the Earth has curvature, then yes, they have to have a difference between the two.
Again, your answer evolves if the Earth has curvature, bro. Why can't you see it?
Right. You're assuming ahead of time that there isn't any.
Not assuming anything. I'm just trying to show you
every single time I say you're assuming there's no curvature, you take issue because every single question that you pose presumes curvature does not exist.
I'm not presuming anything, bro. I'm really not.
If you say level and horizontal are synonymous or are equal in if they are equal in meaning, that level and horizontal can be done simultaneously, you're saying that the curvature does not exist. You're specifically saying the curvature does not exist. That's an assumption on your part.
No, it's not, bro. You just triggered. I'm sorry.
It can't be this. Can you be this dumb? I guess he could be.
What if we change your question, to say something like this? If we build a perfectly flat basketball court, then the question is that basketball court also level everywhere? And that's how you can distinguish between the two models.
If it's level, okay.
If it's perfectly flat, like I said, it's like straight lines all the way across the basketball court down to the nanometer scale. Now the question, and like I said, the very middle points straight down. The question is, at the edge of that basketball court, are the edges perfectly horizontal or not? And that's how you can distinguish between the two models. And then you have to assume one of the models to say if it's curved, then the answer is no. If it's flat, the answer is yes.
Okay, let me ask you a very poignant question here now. I'm going to get right down to the nitty-gritty. You can build, because you keep wanting to do two models, right? Okay. I don't believe in either model, but let's just say we take these two models, right? You make a basketball court on a sphere, level and horizontal, and you make one on a flat earth, level and horizontal. Okay, we got two scenarios here, right? Think about them in your head.
You've already messed it up, man.
What? What did I do?
If you say on a sphere, it is both level and horizontal. That's the problem, SC.
Yeah, what if you said the entire basketball court is at the same elevation? Would that be...
Okay, take whatever words you want, right? Build. Okay. Forget I said those words.
Elevation.
Okay. Build a court on your model, on your sphere model, and build one on the flat earth model, okay?
Okay.
No presumptions, you build those, okay? Now we take some water, we take a nice big little swimming pool of water, and we dump it in the middle of both courts. What happens to the water on either of these model of yours?
The same thing, it just sort of spreads out evenly in all directions on both models.
Right, with the same amount of separation between the floor surface and the surface of the water.
So there's nowhere on either model where the water is higher or lower at any point, correct?
It's not a different elevation on either model.
Right. The reference surfaces are different shape, but the distance to the reference surface is the same in both cases.
Yeah, but one surface is curved according to you.
Right.
And the other surface is not, correct?
Right.
You said it before, correct?
Right, that's correct.
So how is the water spread evenly on a curved surface and on a level surface?
Right, that's the reason why I posted this earlier. You have two choices, the top one or the bottom one. The middle one is not one of the available choices.
It's not what I asked you. You said there's one curved surface, basketball court, and one level surface. And we spread the same amount of water, and you said that water behaves the same, both on the flat surface and on the curved surface. How is that?
Right, because as I'm showing you here, on a flat Earth, that water would have the same separation between that reference surface. You can call that black line there the basketball court. On a spherical Earth, in an exaggerated case here, that black line is also the basketball court. That water is the same distance away from that reference surface.
That doesn't answer the question. You have
it does.
Basketball court on Earth, on a spherical Earth, and one on a flat Earth.
Yep, that's the top and the bottom option in my graphic.
One surface is curved and one surface is level.
Right.
Now you're telling me that the water on the curved surface would behave the same, would not be higher or lower at any part than on the flat surface, on the level surface.
Exactly. Now
you are serious. You're not kidding, right?
Yes. In the graphic that I posted, those are the two options.
I'm not talking about graphics. I'm not talking about your fantasy crayon drawing.
You
I'm talking
in reality. And that's what the bottom option is, SE.
You're serious now, right? You're telling me if I have a curved surface
the
and I
bottom option in the graphic is exactly what you're asking for.
If I have a plate now and it's flat and I turn it upside down and I pour water on one side and one on the other plate that's level, the water's going to behave the same, you're saying?
For fuck's sake, SE.
Yeah, for fuck's sake, SE, yeah. That's right.
Yeah, this is pretty simple. I could probably ask, I know Jeremy would understand this. Jeremy's called you out on this before, that you can't figure this out.
Insults now and third persons, got it. Mm-hmm.
Well, yeah, because Jeremy has an understanding of how it should be described on a spherical Earth.
Well, I don't think Jeremy's here to bail you out, bro.
Yeah. Geo, you get it, right? You got the top option and the bottom option. That's what SE's asking for.
Nope, I asked you a specific question on a basketball court.
And
didn't ask you about no
basketball court on a flat surface, on a flat Earth, and then you build a basketball court on a spherical Earth, and you're going to use a water reference for both scenarios, a flat Earth and a spherical Earth. What you would end up with, a cross-section of that, the top option on a flat Earth and the bottom option on a spherical Earth. Those are the two things you're asking for.
I'm talking about
they're very clearly shown here in the chat what those two options are.
Right. Nice try. I'm talking about a specific scenario, the basketball courts. Don't show me graphics.
That's what the black line represents, SE.
No, we're talking about, and I asked you specifically, is one curving and one level? And you said yes. You both said yes.
Yes, that's right. One's curving and one's level.
Right. And then I asked you, if you place that water in the center, what would happen to the water? And you said, both of you agreed that it would spread out and be distributed evenly, no point higher or lower.
Right.
Correct?
Right. Yep.
So how is that possible on a plate that's flat on one side and curved on the other?
Okay, wait. So you
on a tennis court, one is curved and one is flat, level.
Okay, so you asked two different questions. First, you said, what would happen? And we answered that saying the same thing. And then now your second question is, oh, well, how is that possible? And the answer is a proper understanding of gravitational equipotential, level and that type of stuff. So what do you want to know? You said we didn't answer your question. The answer was yes, the same thing would happen in both things. Now,
right, and I told you that's ridiculous because everybody knows if we had a curved surface, a basketball court with a curved surface,
everybody does,
and one with a level surface. Don't interrupt me. And one with a level surface, if we pour the water in the humped one, it would just flow all the way to the edges. It would not spread out evenly, sir. You know that, and everybody else here listening knows that as well.
Right, that's why I drew the third option, the one in the middle of my graphic. That's the version of Earth that you think the spherical Earth should be. That's incorrect.
You can draw whatever you want, sir.
I know you're not even looking at it because you're a dishonest fuck. But the middle option shows what's going on in SE's brain right now. Right now, the middle option is showing what's going on in SE's brain. That middle option is not one of the two choices that are available. I've told you several times that that's not one of the choices available.
First he insults me, then he tries to tell me what's in my brain. Amazing.
Well, that's pretty good. You literally described the water running off the middle of the hump, which I said is not one of the available options.
Well, I think everybody listening has had enough of this, and
now you're assuming what's in everybody's brain.
Yeah.
We can go on if you like, but I mean, I don't want to bore people going around in circles.
So what is the crux of this? I mean, Doofus, in your little thing there, you have a straight blue line. I'm assuming that's supposed to be straight, which of course would represent water. All the green arrows are going down to the earth. That would completely make sense. X, Y, Z, water, level, earth, all that. The second one just shows a level line with vertical, essentially like plumb bobs coming off it with a curved surface. Now, I think a lot of people would understand that that's not what you guys are claiming, like the third one, the spherical earth. However, there are cases where that is the case. For example, in the photos that Soundly was showing earlier, he was claiming that it is that hump, essentially, that's the that's blocking the vision. Therefore, you would kind of have to draw those green lines like that in the middle one. You'd have to draw them vertical because you're vertical and you're looking out eye level, and then you're seeing this water in the way. So in that way, it is that on a spherical Earth.
No, we're saying the picture is like the bottom one.
Yeah, no. Soundly was specifically using the bottom one for his descriptions of what's going on. He was not using the middle one.
But the middle one would be essentially what it is. If you were to put a little building over there and imagine Soundly with a camera looking out level, and then you imagine a city skyline or whatever it is, or a building on the other side of it, if he's claiming that's Earth curve there, then that means that you are essentially creating a vertical viewing point from a horizontal line to even be able to see something obstructing like that.
That's right.
The blue line does not represent a line of sight. The blue line represents water.
There's no way that you can have obstruction if you don't have a vertical rise of your water. And you say it's water as well, but you say there's no rise. So that's
it is at
right there.
Fixed elevation from a reference surface.
Yeah,
what does that mean?
Yeah, SE, because if you were to do like a plumb line on a sphere, that like creates like a vertical right into a radius, that's fine. But if you were to do that and that was your feet, then it would be curving away from you at all angles. Everywhere it would only curve away. But instead, they got to put you at an angle and tell you it's curved, and then tell you that your eye is creating a chord line.
That's right.
Because it's
crazy.
If the surface of the Earth
it's insane.
If the surface of the Earth is supposedly the way that you guys want to say supposedly, if the surface of the Earth is curving away from you in all directions, then the distant object that you're looking at, necessarily, if it's at the same altitude as you, necessarily you have to look a little bit down below a horizontal reference. So in that case, the surface of the Earth has the opportunity to be in the way.
How? You heard soundly. Our feet were both on the sand, both at the same elevation.
Altitude. Yes, at the same elevation from a reference surface. In that case, the reference surface is in that case, that reference surface is curved.
How could it be curved, bro? If it's the same freaking elevation.
That's our whole point, is that the same elevation is curved. That's the whole thing about the globe.
Right.
Wow, man, I see. That's it, man. You guys are just model afflicted. There's no other way to we can't reach you. There's nothing I can tell you. If you believe that, then
if you don't know the model, then why are you trying to argue against
elevation change? It's like you're gone, bro.
If you don't know the model, then why are you trying to argue against it then?
Bro, if I'm here in Montreal and you're wherever you are in the States, right? And if there's a mountain between me and you, blocking our view, is that elevation change? Yes or no?
Well, yeah, the mountain is elevated above a reference surface. Yes.
Exactly. Okay. So you're telling me now the same thing could happen with the ground, which is blocking your view without having that. Yes. How could that be?
Right, because the reference surface is curved.
The reference surface is curved, but
just make up.
You're saying there's a horizon there as well. You're saying it's horizontal as well.
You just make up.
No, the horizon is measurably below a horizontal reference.
I don't see how you guys could think that you can be on a beach. I can be on one side, the other guy, like soundly said, 24 miles apart. Our feet are in the same elevation, but yet the water in between us is blocking our view without an elevation change. That's some magic stuff, man.
That's exactly what you're saying, and you're right when you say you don't see how we could believe that, and that's the whole problem. You don't see how we could believe that.
No, I see how you can believe it. You have faith in your globe. Yeah.
Bacon summarized it very well. He said, "You're globers and you believe level is curved? Wow." Like, obviously, dude, the entire argument that you have, the thing that you're arguing against, you have to at least acknowledge that. Because right now you're just creating something else to argue against, which is not the thing that you think you're arguing against.
No, I'm just putting you in reality, and you can't handle it. You have to double speak, because water is it's undeniable, man. You can't
You
have
not
2
understanding
drops
it
in
is not
between you
doublespeak.
causing a block. That is physically impossible, bro.
That's your
Wait,
opinion.
are you saying it's undeniable that the surface of water makes a perfectly straight line?
No, I didn't say that.
I
Not
was
at all.
asking. Okay, I was asking.
But a water level creates a plane, a horizontal reference plane from one point to the other. There's no question about that.
Well, you just
People
said
have
the
been
thing.
using that since the Egyptians, before the Egyptians. Water level. There's no doubting that. There's no questioning that.
Yeah, and
You
the
just said
question
the
is,
thing that you got asked whether or not you said. What the fuck, dude?
What?
I think the big
Are you
question
feeling
is, does the
What's going on
surface
with
of
Doofus
water,
over there?
does the
Well,
surface
no,
of
because he
water,
got asked by Matthew whether or not he was saying water creates a straight line, necessarily, and then he said no, or like wasn't really saying that at that
Yeah.
moment, and then he said it. So I mean, fuck.
No, I said clean your ears. A water level. Water
Yeah, it
itself
makes
is a different
horizontal.
story.
So horizontal to you is straight.
On a beach,
obviously.
waving. Why do you always interrupt me when I talk, dude? Do I trigger you that much?
Yeah, he's saying
I'm
that the water
clarifying your
level
position
does it.
faster.
He's saying the water level does it.
Uh-huh.
Well, or that the water level creates a straight line. Right? Right, Essie?
Yep.
Yeah, you can create. Yeah, definitely.
That's what he was asked.
No, you said water. Does water do that? Now, water in a lake goes up and down, and that's different. But a water level, the tool, is a different story, bro.
Yeah, because it uses water, which is, the same kind of substance.
well, maybe we can ask the question without using those trigger words of level and that type of thing. What if I say this? Does the surface of water on a perfectly calm sea or lake, does the surface of the water generally conform to a perfectly straight line? That's the key question. We say no and you say yes.
Yeah, because of course you say no, because for you, the surface of water curves around a sphere.
Right.
Water to you, level is a sphere, is a circle.
Right.
Right.
Yeah, that's what we're saying.
Exactly. That's ridiculous, bro.
And your response is that
your opinion.
And you don't think that, and so your response is that what we think is ridiculous. Well,
yeah, that's
sorry,
my opinion.
Yeah, and so our opinion might be the same as what you think, but there we are.
But does it really seem ridiculous to just have a perspective that it's just level and planar, and level is actually level? Is that
actually
is that really the crazy position? Do you think?
That's an assumption. I mean, we're trying to work off of the principle that is one of the possibilities. If we're positing a scenario, I'm giving you that kind of leeway that there's a possibility that the Earth.
But it's not an
has
assumption, because
curvature.
you can create a perfectly planar, like basketball court, like Essie was saying earlier, with water.
I mean, over those small
You can
distances, you would
verify
never know the difference.
You can verify that water is level.
Absolutely.
Water is
100%.
definitely level. And here on a spherical Earth or on a flat Earth, level means different things.
See, back to the model. Back to you have to go to your sphere. You have to.
All right, I'm allowing both a spherical Earth and a flat Earth in these scenarios. You're presuming that the spherical Earth is not an option.
Doofus, do you have a flat pillow or a spherical? Do you have a globe pillow?
They're fluffy, man. They don't have a flat or spherical
Okay, that
shape.
was a joke. Allow me one joke, please. But seriously, you gotta see the ridiculousness in assuming that level is a circle.
I offered both assumptions in all scenarios.
Even more so, Essie, it's an oblate spheroid.
Yeah, I can't. But thank you, thank you, Gio. I can't.
We should create a T-shirt. Level is an oblate spheroid.
Yeah.
You can say ellipsoid if that makes you more comfortable.
They like their ellipsoid.
The geoids, the ellipsoids, the datums. Yeah, I mean, level is for if you're going to say that that's what level is on the Earth, then that means that level is not actually level in your viewpoint, but that it fits the specific oblate spheroid thing that your government has provided you.
No, level definitely follows what we say level is.
The WGS 84 given to you by your government.
I don't have to use the government to figure it out. Anyway, if you want to say level fits a definition, well, here's a definition.
So for you, water on the Earth fits a definition given to you by the WGS 84, a government agency. So your understanding of level is an authority.
No. What I observe is that the water itself is able to get in the way of things in the distance. That's not a government authority at all.
Yeah, it's just perspective.
Okay. This gets into a fun topic because I've written a 3D renderer before using the rigorous definition of perspective available. If you say that a flat surface should be able to get in the way of something in the distance while both me and that object are on that flat surface, then I need a new definition of perspective because the one already out there does not fit. It would be an added bonus if somebody who says it's just perspective could give me that rigorous definition so that I could create a 3D renderer, because I have the necessary tools in order to do that, so that I can render what they think the world looks like. It's been years, I haven't seen it.
What you have to do is explain this, which you cannot do. How can, what Soundly said before, two people standing on the beach, their feet are both at the same height, same elevation, you draw a cord, and he specifically said it has to go through the water, right? Now you have to explain how this, you can have obstruction without having a hump of water there. That's what you got to explain. Anything else you say is just, doesn't matter.
All right, so as was explained at that time, hump implies a change in elevation from a reference surface. In this case, we could either, depending on how we want to say the word hump in this case, we could say hump not following Soundly's more rigorous and better definition of hump. We could use your definition of hump. Well, the chord drawn from you to that object, the amount over that is typically called a sagitta, but just for you, we can call it a hump if you really want to.
Well, I could understand sagitta, but that starts from your feet, right?
It's the amount over the chord. It doesn't have.
Yeah, I mean, sorry, the chord starts from your. Yeah, exactly, and then it goes up. Correct. Okay, go on.
That's it.
Okay, but the sagitta is a hump. There's a rise from the chord, right, to the top, to the apex of the sagitta. That is a change in elevation, correct?
No.
It's not a change in elevation.
No, it is a distance from the chord to the surface.
So we're at the same elevation. Our feet are at the same elevation, correct?
Right.
So what causes the obstruction if we're at the same elevation?
The chord is a straight line between you two observers. The surface is curved between you and your distant observer. The amount, that the distance between that straight line chord and that curved surface is a sagitta. That's what's in the way.
So the apex of the sagitta, what is the apex of the sagitta in relation to the chord, to your feet? Is it the same elevation?
I mean, if you're standing on a body of water and your distant observer is also on that same body of water, and nothing really crazy is happening right now, like a water spout or something, some madness, but the entire surface between you and the distant observer is all at the same elevation.
So what's causing the obstruction then?
The amount over the chord, because the same elevation is a curved surface.
Oh, this is the. I hope you guys are hearing this, right? I hope the audience is hearing this.
Okay.
How could you have obstruction if there is no elevation between you and your opponent on the other side of the water?
Because the reference surface by which you're gauging your elevation is a curved surface.
Curved
The
going
answer
down,
doesn't
right?
change
Curved?
the more times you ask it, SE.
Yeah, but each time you say it, it's like it gets more and more ridiculous.
To you, that's your opinion.
Okay, let me put it to you this way then. If I was to place a floating hotel right in the center between me and you, a floating whatever, a pylon or what, a nice big box, right? We make a big box. Will that block our view between me and you?
Yes, as I already mentioned, the entire surface between the two observers is at the same elevation, and that reference surface is curved.
Yeah, but I placed so without that obstruction, without that thing in front of us, it would still be obstructed if we remove that obstacle.
Yes, because
There would still be an obstruction
way.
between me and you.
Yeah, because the curved surface is what's in the way, Essie.
The hump of water, which is level, which is at the same height as our feet, is blocking us. The thing that's in our feet is blocking our eyes, which are, I don't know, 6 feet above our feet. Right?
Yeah, that's necessarily what would happen visually if the surface, the reference surface, is curved.
Right. So the water would be obstructing then, right? The water that's at your feet, below your feet,
yes,
is
you're
obstructing
asking
the
what
view.
would necessarily happen on a globe. You keep asking it over and over again. The answer will always be the same, Essie.
Which is what? The water, which is at your feet, is somehow rising to your eyes, but not rising to your eyes and blocking it. I got it, doofus.
It's not rising because you're looking down, Essie.
You're looking down. So by me looking
your
down,
eye level, in order to shoot at the same altitude in the distance, necessarily on a spherical Earth, would be slightly below eye level.
So what would be below my eye level? What would be causing that blockage?
The surface.
The water.
Yes, if you're looking down to see your distant object, the surface has the opportunity to get in the way.
Yeah, but if I look down, I'm gonna see my feet. Then I'm gonna look a little bit more. Oh, there's more water,
dude.
but the
Come
water
on.
is down. The water is always down below me.
It's below eye level for sure.
So how is it gonna block what's between me and you?
Right, the surface is curving, right?
Curving down.
And the chord,
right?
and the chord is not. So the curving surface has an opportunity to be in the way. This really isn't that hard, man.
This is so fun. I mean, I don't know what to tell you, man. I mean, any normal person listening to this will be saying, is he saying that the water is blocking because it's higher? But no, it's not higher. It's lower. It's at your feet. Like, people must be thinking, what is this guy talking about?
Most normal people can have a basic grasp of geometry, which apparently you do not.
Well, we'll let the audience be the judge of how water can block, but could be below your feet, but can actually block another person when the water is below his feet as well, and nothing in between us, but yet there's water in between us. Let the audience judge. Yes.
Yeah, nobody said there was nothing in between you.
But you just said the water drops. So it drops from me, drops from you, but somehow it blocks our vision.
Yeah, you don't have the same direction of down, you and the distant observer.
So I'm one side of the lake, you're on the other side of the lake. We both drops from your feet, creating like a well in between us. But somehow that manages to rise up and block our vision between us. That's what you're saying.
It's not rising up. Jesus Christ, dude. You're looking down.
You're looking down, yeah. Both of us are looking down. Both of us are looking down at water, right? Down, like a waterfall. When we look down a waterfall, going
Not
down.
a waterfall. Jesus Christ, dude.
Are we getting into the same thing where we're mixing orthographic with
Well, no, he thinks
other-
the direction of
Yeah.
down is universal. And he
Yeah,
just keeps
I-
going back to that.
Yeah, you can't mix orthographic viewing of something to the other viewing, whatever it's called.
Right,
So
here,
please
Terry, have
explain
you
it to
seen
me,
this one
Terry.
yet?
How does that work? We're on a canal, right? We're on a 5-mile canal. I'm on one end of the canal. He's on the other. He's telling me that the water goes down from my feet and down from his feet. Picture this now.
Separate observations, separate perspectives. Yeah.
Right. Both of ours, from our feet, the water's going down, right?
Yeah.
So how is it then that the water that's going down is blocking our view?
I posted an image that explains.
Yeah, because
this.
you're mixing up you're mixing up orthographic with the individual's perspectives.
So say, look at
please
at
explain
9
it to
past
me
the
then.
hour. If you look past at 9 past the hour, A and B are both the same elevation, the same height. That's the green arrows. But when they look at each other, the curvature of the Earth blocks their view, even though they're at the same elevation.
So there's a hump of water clearly there. There's a hump of water between. Don't tell me that. Are you saying that their feet, they're at the same elevation?
Yes, they're both at the top of the green arrow.
Okay, and that red line?
The red line is the line of sight.
The line of sight. So not the Sajida.
No, the Sagitta would be over a chord, man. It's a different direction.
Excuse me. I mean, not a chord. That red line. Excuse me, I mixed that up. Not a chord. That line, the red line, is a chord. What is that?
Well, it goes above the circle, so I don't know if it'd be exactly a chord, but it's just a straight line between the two people.
It's above the circle? Did you say it's above the circle? Because it doesn't look above the circle to me.
Yeah, each endpoint is elevated from the surface. It's above.
It's just a straight line. I mean, I'm not trying to use fancy words, just drawing pictures here.
Hold on. Hold on.
That would be a secant,
Are you
right?
saying that there's not a hump of water? That
Okay,
line
so
doesn't go through water?
I guess I would
Which in
prefer
turn causes a hump on top of it?
I would prefer to call it something different, but I think that when you say hump of water, then my answer would be yes, using your definition of hump of water. Yes, there's
So
a
there
hump
is a hump of water
There
causing
is.
obstruction between both of you.
There is.
But you're at the same elevation.
Right. We're same elevation. Those green arrows are the same for both A and B.
So you're saying now there's a hump. So you're saying you're on a canal. There's a hump of water between you, but your feet are in the same level, like the same chord.
The same elevation. That's exactly
The
what
same
I'm saying.
elevation.
Again,
But yet it's level.
Some people would use a different definition for hump and would not like that term, but we can use that term. And my answer to your question is yes, there is a hump between A and B.
So you're double speaking now. You're saying that the water is level to our feet.
Right.
Then you're saying there's a hump between. And when I say so, there's a hump of water obstruct. Then you say no. Then you say yes. I mean, which is it?
There is
the
a
problem
hump.
is the usage of the word hump. It's not technical. It's not specific. It's arbitrary.
We can use your definition for now, say, and if using your definition, the answer is yes, there is a hump of water in between A and B.
So from the apex of the hump of water to the chord, is there a difference in elevation?
Yes. The chord.
Oh, now yes.
That red line, the red line that it goes below the sea level, so to speak. That red line.
That doofus said no before, right?
But he was talking about the curve all the way across. I'm talking about the line of sight. So we're talking about different things.
No, he was talking about the water.
Yeah, that's not the line of sight either.
Oh man, you guys gotta do a huddle. Gotta get your stuff together.
We've
no,
been
we got to
speaking
figure it out, man.
consistently
The
and
water's
clearly the whole
surface
time.
is not the line of sight.
Dude, make up your mind. Is there a sajada from our feet? Is there a line of sight that's a sajada? What? I mean, a cord, excuse me, a cord. Make up your mind. Is the cord at our feet? Is the cord in our eyes? Where are you drawing this cord?
The rigorous definition for cord would be such that the line segment only touches, does not extend beyond the circle that it's passing through. If we wanted to look at that line of sight, we could say that's a secant,
right?
if I remember my terminology correctly, maybe. But in either case, we already defined what we were saying these things were.
Yeah, but it's either on top or it's through. You can't have it both ways, bro.
It's not what? Yes, you can. That line of sight is elevated at each end from the reference surface, but crosses that surface.
Oh, this is very painful, man. This is like pulling
You
teeth.
can see it in the goddamn picture, dude. The red line is at either end, elevated above the reference surface, and crosses through that surface. It's visibly doing that.
Right. So you got a cord going through the surface. Your eyeball to eyeball is through the water, not over the water. Correct?
Right. The water's in the way.
Right. But before you're saying that, no, we're at the same elevation. Right?
The people are at the same elevation.
So how can you be at the same elevation and have water blocking you, sir?
Because the line of sight goes through the curved surface.
Oh man. I've had it with these guys. I think I made my point. I'm not going to do this all
You
night.
made your point very well.
The people that are listening
geometry.
will decide, sir.
Mm-hmm.
Yep. And the truth will be gleaned from
Not from SE. Failed hard.
From those communicating it.
Okay,
Yeah,
yeah,
people
I
make up their
added
minds.
some more. I added some more to the picture to answer your question. If you look at 15 past the hour, the green line is the on the globe model, again, assuming the globe, the green line is the line of consistent elevation. The red line is the straight line of sight, and those green arrows are, so A, B, and X are all at the same elevation on the globe.
Around an oblate spheroid.
Yeah, again,
Right,
exactly.
right.
They have to go to the ball.
That's what we're
Yeah.
talking about. We're talking about how this would work on a globe.
No,
Yeah,
I
you
wasn't
asked
talking
how
about
it
a
would work on a
ball.
globe, SE.
Yeah, you asked how it worked.
No, 2 basketball courts, I said. 2 basketball courts.
Oh,
One
Jesus Christ.
we came was level and horizontal, and the other one was curved.
Hold on, SE, real quick. No, the entire past conversation for the past 10 minutes was not about basketball courts. The conversation over the past 10 minutes was about the Lake Pontchartrain looking at 2 observers on the same body of water looking across it. Don't come in here and say
That
for the
in a
past 10
canal,
minutes we
yes.
have been talking.
That in a canal, yes.
Don't say for the past 10 minutes that we've been talking about the basketball courts when, for fuck's sake, no, we have not.
Yeah, okay. That, I said that and a canal. No problem. Take whichever one you want. It doesn't matter. We can do this any way you want. On
Okay,
a basketball court or on a canal.
Yeah, let me answer your question then, because I think you said, and correct me if I'm wrong, that if 2 people are standing with their feet at the water level, looking across some body of water, a canal or a lake or something, and so I drew that picture A and B. You asked, does the water make a hump in between? And although we don't like that term, we can use that term, and my answer is yes. There would be a hump of water in between, blocking A's vision from B and vice versa, even though they're at the same elevation. The elevation in my picture is that green circle above the brown circle. Maybe I should have made it blue.
Call it whatever you want. There's a hump of water in the canal blocking me that I'm 5 miles from you. I'm looking in the canal straight, right? It's a calm day. It's in the canal, and there's a hump of water causing obstruction between me and you.
Yes.
Okay. All right. You guys heard it. A canal level, 5 miles. These guys think that the water humps in the middle.
Right, we do.
Okay, respect as long as you admit it.
I admit it.
And that's been the model's position for however long you've been in this conversation, SE. It hasn't changed any time recently. It's been the same.
All right. Fair enough. Now, the people listening, I mean, we can go back and forth all night. You're not going to change my mind. I'm not going to change your mind, right? Now, the people that are listening, you have clarified your position, and they understand now.
You know, I missed the whole conversation with
Yeah, great. SE, thank you for reiterating that the conversation is between a spherical Earth and a flat Earth. Congratulations, you've changed none of the conversation.
No, I showed that any sensible person, anybody that's been on a lock, right, knows that that's not true, right? Knows that that water does not hump in the middle. Now, you can believe it does, and I'll, what can I say?
I believe it does.
Yeah, we visibly see the water getting in the way of things, so I'll go with what I see.
Fair enough.
Yeah.
What's up, Kosho? You just getting here?
Yeah, I missed the conversation with Soundly.
Oh, you
but
did?
I was just going to say.
that was good.
Hold on.
Yeah, Jose was here briefly.
Yeah, I was just going to say one thing, that Jesse Klosowski's data represents that picture that Matthew Learns had posted perfectly.
What data? The data that says there's a 90-foot hump?
Yes.
That one?
Yes.
Okay.
He took all the positions of the bridge, 5,000 points or 3,000 points along the bridge, and it represented, as I said, that AXB picture Matthew posted, where a straight line connecting two endpoints of that data would be like that red line, and the bridge, all the points along it, were like that green line.
I don't know, Kosha, man. The things you guys gotta believe, man. I mean, I can't do it. I can't. I have to stay in reality.
I guess I would say the same thing about what you guys believe. It's just too bitter of a pill to believe all the stuff that you'd have to believe for the flat Earth to be true.
Yeah, it's fair enough.
So, Kosho, you don't really have to actually believe anything. It would just be your reality. It's just basic geometry. You actually
I'd have to reify this idea that there's a magical dome holding pressure in. I would have to believe that somehow there's magical balloons streaming satellite TV signals and GPS signals that nobody's ever seen. I'd have to believe all kinds of crazy stuff.
Okay, there's some reason that you feel like you were necessitated to believe whatever you just said there just by having the understanding that the Earth isn't moving and that there's an XYZ geometry matrix to reality?
Yes. If you say all that, then you're going to have to explain how satellite TV and GPS satellites work.
Right. And then the other one, you said a dome. I mean, I guess that's a whole nother question, but I mean, there would definitely be like a field above us that we can see. Just like there's a ceiling in your house or, something like that.
Yeah, and I don't mean to bring up, all these rabbit hole ideas. I was just pointing out that we also have the same feeling about that. Like, oh my gosh, it's a bit too much to swallow to believe all those things.
Right.
Well, if you only had the conclusion that
Matthew,
the Earth, if you only had the conclusion that the down is down, up is up, the Earth is the Earth, water is level, just the basics of that, then you could just have that in and of itself of just understanding that geometry just on that level.
Sure, with
whatever's
zero
going on in the sky is like a whole nother thing because that's something you're like observing with your eyes, but it's kind of like not directly related to the ground per se. In this,
sure. No, you're right. We could have just the belief that the Earth is flat and motionless and nothing else, and then have zero explanation for how any of these GPS technologies and satellite TV technologies work, have zero explanation for the super accurate predictions of eclipses and moon phases and sunrise.
Yeah, I mean, when it goes back to the dawn of time, since the beginning of time, before this globe idea was even being pushed as a thing, certainly people, looked up at the heavens with wonder and so on, but they were not all like deeply somehow conflicted that they had to believe in magic or anything. They just, well, I think in a way it was more of what's called like an ensouled cosmos, where like the soul of the creator and soul and spirit itself is actually bound within the entire thing. So like the whole thing is actually a sacred realm in that sense.
Yeah, fair enough. I mean, I would agree that that's what they thought.
Versus this like ensouled versus disenchanted, where the soul is removed and then it's replaced with like materialism and authorities and then get into even the darker parts of deception and so on.
So yeah, I would agree that there has been some disenchantment the more we understand about the science and reality and that type of stuff. However, I actually think that enhances our understanding of all of creation. It enhances. In fact, I think there's probably more mysteries now than there were 2,000 years ago. Like we the more we learn, the more we understand how much more there might be to learn.
Yeah, there could be pockets of enchantment within a disenchanted cosmology, but the core foundations of the current model does seem to have disenchantment, atheism, and meaninglessness somehow built into it, like at its core, even though, yeah, there are different sidetracks and like side pools of things that have people that have different ideas as well.
Sure. I think you could draw some parallels, but there are plenty of believers in religion on both sides, I guess. Well, yeah, I think those are not directly related.
And then you had brought up GPSs before. Yeah, I mean, what's the challenge with that? The idea that there would be communication devices on balloons, electrostatic tethers, and drones, all kinds of equipment, because we can only see so far. So at a particular altitude, they can have anything up there and it's going to be beyond the layer for us to be able to visually see it. So yeah, they can have all kinds of stuff up there.
Whatever it is that they have up there must be moving at thousands of miles per hour.
Right. I posted a picture at 26 past the hour of satellite TV dishes from the 80s and 90s. You guys remember those ginormous things? Those are parabolic antennas, receivers pointing straight up, and they received a consistent signal. And so they must be pointing at something. And the question is, what on earth could they be pointing at that would be broadcasting a signal? And I think
something directly above it.
Right. And so what do you think it is?
Well, they have all kinds of high altitude flotation equipment and devices.
But how would they stay in exactly the right position? Because if you remember, those satellite TV dishes had to be properly aimed by a technician. You don't want to bump them. They have to be really precisely aimed. And once they're aimed, don't touch them and you'll keep getting a signal.
You know how drones have that thing where if you get a drone, calibrated and centered, and if you push it, it'll recenter itself.
Yeah, I've seen those.
Yeah, so they can have these devices at very high altitudes where essentially it's very likely they use electrostatic tethers because the military uses the tether technology. And so that helps it maintain its actual altitude. And then it just uses the readings from, just like the same way the drone does, it uses the readings of the wind and how it's moving to either stay in a particular location. So it just counteracts all of the, jet streams and weather and things that would throw it off, and it holds its position, or they can make it to where they'll track at a particular speed.
Yeah, and that's possible now. I think that technology has been invented within the past 5 or 10 years. I'm talking about this picture from satellite TV receivers from the 1980s. We didn't have anything that could stay in the atmosphere, no balloon, no tethers, nothing like that. They could stay in a single spot in the atmosphere for days, weeks, years on end.
Right. Well, now we're getting into a whole nother category, because where I would have to go with that is like history. And do you believe the history you're told that we didn't have these things before? because I definitely think there was a massive reset. So I don't think the history we're told, meaning that they've had advanced equipment for much longer than they let us, like between basically World War I and World War II is when, and even really like before World War I, but there was a whole process of kind of breaking down the entire system and then building a knowledge base that was not connected with what was previous. And then the people who kind of hijacked that essentially usurped that technology, and they've been using it, to control us since then. So anyway,
I'm talking about the 1980s. This is history that I myself remember. I remember seeing these satellite receivers. Have you ever seen them? Like, I'm talking about your own experience. Have you seen satellite receivers?
But your point was that in the 80s, they wouldn't have a balloon system or some kind of a technology up there to hold it in place?
Yes.
And that's why I was saying, like, why do you, because it was, I mean, actually, if you're talking the 80s, I mean, that's not even something that, I mean, you'd have to go further back to start to claim that you think the technology wasn't there. Because of course, in the 80s, they would have had all kinds of tech.
Have you heard of Picard?
I know the fictional captain of Star Trek named Picard. I don't know.
Not that Picard. It was named after him, the other guy, actually.
August Picard?
Yes, sir. Why don't you tell him about him, Joe? And his balloon. You know what year that was?
Yeah, balloons are in the atmosphere.
I like how they called those guys aeronauts. Like before they turn into the astronaut, it was aeronaut. That's cool.
Just sorry to cut in, but that technology was around for a while. That's all I want to say.
They weren't keeping station in Auguste Picard's example. Not even close.
Yeah, they're in the balloons are in the atmosphere. The atmosphere moves quite a bit, especially way up high in the jet stream. You can't keep a balloon in the same spot.
Well, yeah, I mean, you also don't need one balloon to stay stationary. I mean, we were just talking about that as a possibility of a way of doing that, because we're talking about, but there's other ways to do it. Even if you want to have signals that are coming straight down, you can also have an entire network of devices that are sending signals, equally.
Wait, so you believe
have to be directly overhead is the problem.
Like they can be moving, and they're just creating. They can be moving, but they're just creating a web of signals that are being sent down evenly to the Earth.
Wait, so
right, as I was about to respond with before you said that, you can't have two devices on either side of where the dish is pointing in order to receive that signal. There has to be a device directly overhead.
Yeah, even if it moves just half a degree, like a tiny little bit, then it stops receiving the signal. And you accuse us of believing crazy things. And here you are positing a whole network of magical balloons keeping station with zero evidence in 1980. They didn't have that type of technology back then.
Yes, they did.
I didn't say those things. You're pinning something on me. I didn't actually say. You're just inferring something, but I didn't say that.
You didn't say a network of balloons?
I'm talking about another way to do it. If you want to have objects up there, there's two main options. One of them is that it's stationary. The other one is that it's moving. So if it's stationary, then it would just have to counteract the jet streams and the weather and the wind and all that to stay in a particular position and at a particular altitude. They can actually, all they have to do is change the altitude, because the jet streams are all going in different directions. So they can literally just change the altitude and keep it in place by just going into the jet streams. Granted, there might be some movement with that method, but I'm saying that's one way to do it. But if you have devices that are moving, then that is its own thing too. Is it being propelled in a particular path, or is it just kind of floating wherever it floats? So yeah, it's just all ways of setting up networks like that.
Yeah, I find both of those implausible explanations, is what I would say.
But GPS also uses a lot of ground tower technology as well. Especially, I mean, it depends on what year you're talking about, but like the LORAN systems originally, so it's definitely changed throughout the years.
Yeah, LORAN's not GPS.
I didn't say it was. I said that's the part of the historical roots of the technology.
Right. But they have totally different transponder frequencies and all that.
So Matthew, you're saying that other than the idea that they have communication, they have devices, whether it's balloons, planes, helicopters, drones. Now, anything you can have up there. You're saying that is less likely to you than the idea that we live on a sphere with this gravity thing and everything's stuck to the sphere, even though it seems like we're not moving, all that stuff. And that they have satellites, quote unquote, that if you throw something up there, it just starts circling a sphere. That to you is a more believable explanation, just in terms of like just the basics of it.
Exactly. It's more believable, more likely, 100% internally consistent. You don't have to believe in any of this magical technology that didn't exist. So yes, it's way more believable.
Why would it be magical technology? What you're calling satellites, hold on, what you're calling satellites in 1980, the other idea is that they are just communication devices at high altitude. What is the difference if they already had the technology to create satellites in the 1980s, in your belief, and that's why GPS worked? Why do you not think, if they can create the satellites, that they can't create a way to keep them up there? I mean, balloons is the simplest way in the world to keep something up there.
The answer is because we have a plausible story about how a geostationary satellite can keep station and never move relative to the ground. And we have zero plausible explanation of how any balloon could be in the jet stream and never move a single inch.
It's well, I wouldn't say a single inch, but all you have to do is
a single degree.
You just have a balloon with thrusters on it, and the thrusters just counteract the movement. Just like
I don't find that plausible. Jet streams can
fueled
go
by
hundreds of
what?
miles an hour. Exactly, with no fuel. That's a good point.
Well,
I'm just saying it's not plausible.
They can be refueled in the sky if there's fuel that's needed, but that's a whole nother question.
Wait, so now we have these magical balloons being refueled in the sky that can counteract a 200-mile-an-hour jet stream and stay right above that satellite dish in Quito, Ecuador for decades at a time. I just don't find that believable.
Well, you have no clue what you're talking about. That's why. Look what I just posted here.
You keep saying a magical balloon. I'm not talking about a magical balloon. If you're talking about that means it's fictitious. I'm talking about a balloon, a physical device that can stay stationary. That's not very difficult. That's been done way before the 80s even.
I'm talking about a balloon. Okay, so yeah, a regular balloon would be a balloon that goes in the atmosphere, floats along with the wind, that type of stuff. By magical balloon, I mean something that could counteract a 100-mile-an-hour jet stream.
That has thrusters on it? Why is that hard to believe?
Because thrusters take fuel and take a lot of energy.
How about if we have solar panels?
There's all kinds of balloons that do this already. I mean, they don't.
I just posted one.
It's not really a tremendous amount. It's not as much. Hold on. It's not as much as an airplane. All it needs to do is stay stationary. It doesn't need to thrust itself at hundreds of miles an hour. So you don't have to have huge jets or anything. But yeah, you just have the appropriate. They're like like on a boat, they have the thrusters, like the side thrusters, and it's similar to that. It's just it keeps it in place.
What balloons do we have that have station keeping for extended periods of time? What are those?
Like 20 years at a time, by the way.
There's all kinds of them. The military uses.
It doesn't have to be 20 years at a time.
Do you have evidence of them?
Sure, Google. Check out Google Loon.
Yeah.
Right. Google Loon didn't use station keeping balloons. Those were always in motion.
Yeah, but they were able to go up and down. They don't have to necessarily be stationary to achieve what you're saying. You can have a whole range of them.
Yeah, a C-band dish.
Same goal. Yeah.
No, a C-band dish, they have to be stationary.
And remember, Google Loon started in 2011?
Right.
So this is but the point is, this is a private enterprise. You don't think that there's a drone. You don't think that you can have a combination helium balloon with cells on it. And I'll show you. I'm trying to find them now. That's a couple of them that I posted now. There's a whole bunch of these. You don't think that the military has technology figured out to do stuff like that? Seriously?
Right. But now we have to go into the land of magic because we don't have evidence for the
you're in magic.
A second. Hold on a second, Essie. Because we don't have evidence of a balloon that for 20 years at a time can maintain station. We don't have that.
I didn't say that a balloon can maintain station for 20 years. I'm telling you there's different platforms. Research high altitude platforms. I'm trying to do that. It's a little late now. But I assure you that there is technologies that can do exactly what you're saying. Okay?
Right. I have to just go on your assurance.
With solar power that can stay stationary and do exactly what you think is being done in space, in a vacuum. Now, which is more magical?
Right. I have to go on your assurance for your position, SE, not evidence. That's a problem.
I'm trying to find them right now. Trust me. Research high altitude platforms.
Great.
There's a couple of them right now. Who's posting these? Nice. New perspectives on the case. There's a whole slew of them. Now imagine what the military has. Imagine the drones that you can buy right now and hover, go up and down, go a mile away or whatever, right? Now imagine what the military has. Why can't you imagine?
I have to imagine. In my case, I don't have to imagine because I have evidence for the things that I'm talking about. The things that you're talking about, you have to imagine, for instance, that those things are there and that they can maintain station for extended periods of time.
If you can't imagine that, after what I told you, there's something wrong with you. Now, you can easily imagine.
But I have to imagine it. That's the problem, not evidence.
You can easily imagine a contraption being in a vacuum of space, right? But you can't imagine a platform that uses gas, metal frames that could go to 120,000 feet, which is 99 point something of the atmosphere gone. You can do anything you want with that thing. You can make it go fast. You can make it hover. There's nothing up there. Do you understand that?
But the problem is the evidence part, SE. What I have is direct evidence of objects over my head are moving at thousands of miles per hour. I have direct evidence of that, SE.
No, you don't. You have pretty pictures from NASA and your imagination. Those, what you think are satellites, could be military drones. That's what I'm trying to tell you.
So you're saying that...
hold on, just 1 second. You made a claim that I don't have evidence for the thing I said I have evidence for.
Show me evidence of a satellite. Yes, go on.
All right.
Show me.
So
evidence.
This is the fun part. So you
Proof
remember
of a satellite.
this is the fun part, SE. Hold on.
No, it's not.
This is where the fun begins, SE.
Do it, buddy. I'm in a good
as
mood.
I've mentioned, SE Montreal.
Show me.
As I've mentioned several, motherfucker. Are you just gonna keep fucking talking?
Hold on, doofus. Don't start screaming, dude.
Yeah, okay. If he did it 6 or 7 times, somebody's gonna step in, right?
He is kind of interrupting you. All right, SE, let's let him speak.
Yeah.
Jesus.
Go ahead.
All right, let's try this again. Now, as I've mentioned to you before, or at least to this room several times, if you have 2 observers along the ground track of the ISS, and you record the time that passes between a zenith observation of the ISS between those 2 observers, you can, without question, get the ground track speed of the ISS. And it is always, every single time, greater than 16,000 miles per hour.
Okay, are you done now?
Well, you said I didn't have evidence for that, and I gave it to you. Thank you.
No, you gave me what you think is a speed of something given to you. Where is your evidence, sir?
Right, the timing, listen very fucking carefully, SE. The timing that it took for the object past zenith for both of those observers gave me a ground track speed of over 16,000 miles per hour. Did you catch it this time?
Beautiful. You got a ground speed of 16,000 miles an hour of something in the sky. Now give me proof that that is a satellite. Go.
Whatever that object is that we can predict its position in the sky, which we call the ISS, that thing that we call the ISS is the thing that I tracked the ground speed of.
Right. Now you show me proof that there's people in there traveling at that speed. Go.
I don't have to for the claim that I was addressing. The claim that I was addressing was whether or not I have evidence that there are satellites moving at thousands of miles per hour, and I provided it. Thank you.
And you went from a satellite to the ISS. I want to see a satellite.
ISS is a satellite.
Satellites, right?
Yeah, the
Why
ISS
did you
is a
change it to
satellite.
the ISS? Why did you change it to the ISS?
Because the ISS is a satellite.
And it's
No,
the
we were
brightest one, the easiest
specifically
to see.
talking about satellites pointing radar dishes
Okay,
at them,
the
sir. So
ISS
show
is
me
a
evidence.
satellite.
Why are you interrupting me? Are you triggered?
No, because you keep saying
Show
we're
me.
talking about
Why are you
satellites.
interrupting
Of
me
course,
again?
we are talking
You're
about satellites
interrupting me
because
again.
the ISS is indeed a satellite.
Hold
No,
on,
but we were
Doofus. You are
talking
just
about
kind
that.
of
We were talking.
yeah. You're kind of just shouting over him, like without letting him actually say, finish. It's kind of like a tactic to throw him off,
Right, because he keeps saying the ISS is not a satellite, but
Well,
it
just let
is.
him say his thing and hold it in, and then you can respond. Because then we can all hear what's being said. If you just like holler in the middle of what he's saying, then kind of we can't hear anything, and then you just throw whatever he's saying off.
And I posted specific numbers at 43 past the hour for anybody interested.
That's beautiful. You got pretty numbers. That's all you got too, as well, Doofus. Now, prove to me that there's a satellite there in space. Go.
Okay. So the thing that we predict the path of, and the reason why I can place two observers along its ground track in the first place, the object known as the ISS, the thing that fits every definition of the word satellite, that is the thing that I timed the ground speed of to be over 16,000 miles per hour.
No, you assume. You assume. First of all, we were not talking about the ISS. Again, I
Well, it's a
remind you
satellite.
once again, sir, we were talking about pointing dishes at satellites. So I presume we were talking about communication satellites. Now, show
Well, the
me
ISS
proof.
is a satellite,
You
though.
said you had proof of a satellite. Please show me proof of that.
Okay, but the ISS is a satellite. Do you want to make the claim that the ISS is not a satellite?
No, you're changing the subject again, sir. We were
No.
talking about
No, because the original subject was, do I have evidence for satellites moving at thousands of miles per hour? And the answer was,
No, we were
the
talking
ISS
about
is a
satellites
satellite,
and
and I
pointing
do have
dishes to
direct
them.
evidence that I've
And you
collected
were
myself that the satellite in question is moving over 16,000 miles per hour.
Were you or were you not grilling Geo about geostationary satellites over a dish? Were you or were
No,
you
I
not
wasn't the one
grilling
that brought
Geo
up
over that?
geostationary satellites. Actually, that was Matthew. But I mean, we can talk about satellites, right?
We were talking about satellites, and you said you had proof of a satellite. And I'm asking to see this proof of a satellite.
Well, the ISS is a satellite.
Oh, I'm done with that. It's too late. Whatever, doofus, man. Yeah.
Okay, if it's
whatever.
not a satellite, what do you call it? Or what is your definition of a satellite?
Well,
I'm done with you, man.
I think kind of the vibe I was getting from what he was asking for is, I mean, the ISS is a whole nother, thing. It's like a propaganda piece, whatever. But in terms
You can
of
see it. It's not a propaganda piece.
How about this? Like, look at it this way. If you were just on the ground and you're with someone else and you're in the woods or whatever, and you see some lights up there, you're getting a signal on your phone or whatever, and you both have theories as to what's going on. If you were to say, I think that these things are out in outer space, when you go up high enough, you start floating around this huge sphere and all that. So what he's asking for is like, what have you found that proved it to you? Because you're saying it's true. So what have you found that proved it to you that, and therefore you should be able to then prove it to someone else because apparently it was proved to you. So what did you find that absolutely verified that there are devices that are floating in a vacuum around a sphere up there?
After hiking
Well,
the
you
woods, I went
can't have an object that is verifiably moving more than 16,000 miles per hour within the Earth's atmosphere. That won't happen.
The other way you could do it is after you're done with your hike in the woods, go home and turn on your satellite TV and watch it for 20 years in a row.
Hold on, I have an answer to doofus. At 120,000 feet, how much of the Earth's atmosphere is there, doofus?
I don't know off the top of my head. I'll have to look at that
Less
again.
than 5%, we could say.
Yeah. It's not much.
Mm-hmm.
But it's enough.
A little bit higher. It's like less than 1%, correct?
Yeah. You can get enough altitude to be less than 1% easy enough. Yeah.
So what's stopping a military grade structure, balloon, half metal? What's preventing that from going tremendous speeds?
In 1970, lack of technology.
Yeah, and
now it's 1970, not 1980.
1980.
Keep in mind that it has to be.
I'm just giving you some ideas, gentlemen, to think about.
Keep in mind that it has to be at an altitude where a balloon no longer is a suitable means of getting something up there.
You didn't hear what I told you, right? I told you a reinforced, not a balloon that'll pop, not the one that you can go and buy like that. That guy, what's his name, who sent up
No, the
7
buoyancy
of them.
wouldn't be enough, SE.
Oh, really?
Yeah, you have to be at an altitude that's higher than what can support a balloon.
You're not understanding. Balloons can go to 120,000 feet right now. I can go buy a balloon right now, and I can bring it up to 120,000 feet. Now, the atmosphere up there is like 5%. Now, listen carefully to what I'm telling you. With a little stronger material, easily done, you can get that balloon to go up higher without bursting, just a little bit, right? Or any other mechanical thing. And you're in almost no atmo. So you can go as fast as you want, bro. Doesn't have to be the ISS in space that you're thinking. I'm giving you an alternative.
Okay, so basically you're putting it into orbit.
No, not really. Not really. No.
Is there any possibility that we can get away from the fictional cartoon? I mean, apparently Matthew Learns thinks balloons are advanced technology, and we didn't have that back in the 80s. I'm really worried about this group right now.
Specifically, in
not station
1980,
keep for 20
we
years.
didn't have a balloon that could station keep in the jet stream.
Why not?
Yeah, but right. Go ahead and tell us more about it.
Those type of balloons we've been seeing pictures of in the text stream are more recent things. They don't stay up there for 10 years at a time, and they weren't around in 1980.
There's nothing's been up there at all. There is no receiving of signals from anything in the magical outer space sky that you believe in anyway. There's no such thing. That's why we have AWACS. So there's still no claim. No one's ever no. You don't even have a claim. Let me know when you have information coming from the magical sky daddy of outer space. Flying spaghetti monsters. Can't wait for it.
It's where the satellite dishes are pointed.
Yeah, what's an AWAC?
Oh, yeah, and when are you using them? Yes, can't wait to see you use them. Just let us know when you get a signal from them.
Sure,
Best of luck.
There's a
that's where they're pointed.
The
in order to work the direction they're pointed at.
Yeah, let me know when you can. Yeah, as soon as you have that information, let us know. Everything is controlled by ground-based cell tower systems. There are no signals coming from the air anyway. They're coming from the ground.
Yeah, except for the satellite dishes pointed directly upward.
At 50.
Oh, I'm sorry that you have nothing to. Oh, where's your satellite dish right now in your backyard, or is it somebody told you this? Yeah, it's somebody on the internet. Oh yeah, you saw pictures on the internet. Cool.
Pointing straight up. Yeah.
Cool. You got pictures on the internet. Oh, that's funny. The military doesn't. You might want to call the military and ask them why they use air warning and control systems if there's magical satellites. Maybe you should let them know they're doing it wrong.
AWACS played a different role in the military than what you're thinking.
Can I
yeah, there is no signal coming from magical outer space. You don't even have a claim. They come from cell towers and air warning and control aircraft. There's no claim otherwise. That's what the world depends on.
Yes, because the satellite dishes are pointing straight up, and the things that they're pointing to are not moving.
Mm-hmm. Yeah, I know that you think that's advanced technology for the weather balloon systems that we've had since the 50s. You guys didn't know about that? We have
weather balloons don't
that go pretty high up
like that.
Yeah, I know. That's what I'm showing. Yeah, we already had. Yeah, you said we didn't have the technology in the 80s.
Yeah, but weather balloons don't do that. The thing that you're claiming does it.
I know you don't have a claim.
Do it.
Can I get in now?
There is no signal. Notice there's no signals being received from magical outer space. There's no claim. So as soon as you have an example, let us know, guys. Thanks.
Right, except for the ones that have been posted in the chat.
Yeah, nothing. Yeah, I'm sorry. I'm sorry.
I understand that your opinion is that nothing has been posted.
I know pictures on the internet. You don't even have a claim. You don't even have any data.
Of course,
nothing
people
there.
live there.
You can't even give me. There's no information. Yes, there's no such thing. I'm sorry.
Straight up, and
there's no information.
That cannot be moving out of.
I'm sorry that's not why you believe it.
If it had been moving out of position,
you guys, please talk one at a
time.
Talk one at a time. And actually, Terry, go ahead. Terry,
I mean, it's really him.
Just hold on, Doofus.
Yeah, I wait for the gap, but you just keep talking over each other, and I don't think you can hear me when I'm trying to say excuse me or something. And then by the time I get to say something, I'll nearly forget what's being said. And plus, this conversation people move the conversation too quickly and don't actually communicate the conversation as what they're saying. Anyway, somebody mentioned something about an AWAC or something to do with communication. Can I get an explanation or description of what that is?
Yeah, that's called AWACS, Air Warning and Control Systems. The U.S. Air Force has to use them so they can relay radar data systems between waypoints and other vehicles and aircraft from the ground to the air. So JSTARS would be the air-to-ground version of that.
Have you actually seen where the radar signaling or receiving component is on that airplane?
Yes, it's on top of the aircraft for the AWACS, and for the JSTARS, it's on the bottom of the aircraft.
So why would the one be on top receiving or relaying signals from?
Yes, because it's on top of the aircraft, because the higher you go, the more expanded your radar cross sections are and your beams and the ability to see farther, just like your eyes. When I get on top of my rooftop, I can see much farther than I can on the ground. Amazing.
So they don't go to satellite dishes and relay signals from satellite.
Well, that's not what reality shows us. We require air warning and control systems, not satellites. That's the point.
Well, that's not true
There's
anymore.
no claim. I'm sorry, you don't have a claim. That's why we have the United States military. It's $1 billion air warning and control system. There's literally hundreds of aircraft involved with these things. There's no satellites. If we had one satellite, we would probably be using it instead of the $1 billion aircraft system known as JSTARS and AWACS. There's no claim. It's just that easy.
Because the satellites, to be where they are, wouldn't be capable of producing the kind of radar coverage that an aircraft at a much lower altitude would be capable of doing.
It's already been done. I'm sorry your imagination doesn't agree with reality. It already works only one way. Sorry.
Right. That's projection of the highest order.
You don't even have a claim. You live in a fairy tale cartoon. This is just so you can hide from morality. You guys need this outer space religion. There's no evidence for it, so you just make stuff up and lie.
No, because there is actually evidence, because as I mentioned before you clobbered into this conversation, that the object that we colloquially know as the ISS, if you want to, whatever you want to define words to mean, that object can be independently tracked to be at a ground track speed of greater than 16,000 miles per hour.
Yep, just more lies to protect your other lies. You still have no claim. Yeah, ooh, magical Superman in the sky, and I swear he's there. He's just too far away to see. And except for
Right, and you claim that it's a lie without ever having actually verified it.
Yes, the whole world depends on no satellites. There are no signals going from or to outer space. I'm sorry, guys. It's a fairy tale.
Except for the examples posted in chat.
I'm sorry, those aren't examples. You don't have anything. I just looked in chat. There's no evidence of any of the system working. Examples. Yeah, you don't even have a claim. Oh, okay. Who's the operator systems manager?
The operator systems manager.
Yes.
Thank you.
Yes. Who's the operating system manager for this satellite, and what satellite is it? And let's track it right now and see where it is right now. Show me where it is right now in reality.
Right. You know Echo Star. You know those satellites, right?
Yeah. Who's the operating system manager? Who monitors
operating
it? Who monitors
system
it?
manager?
Yeah, where's
Jesus
the call
fucking
center?
Christ, dude. Can you come back when you're
there you
sober,
go.
please?
Excuse me. No, I'm sorry that you're just perving to protect your weirdo
sober,
lifestyle. I'm sorry you're scared to death of reality. AWACS is real. That's why we use them in the military. You don't even have a claim. You live in a fantasy, Cupcake. I'm sorry it has to be this way for you.
So Echo Star.
You have nothing.
Dish
yeah,
Network.
I know. Yeah, Satan
Network,
Star.
you
You don't
might
have
be
a
more
claim.
familiar
Yes,
with
you
it.
have no data.
Dish
You're
Network
just keeping
is
making stuff up.
In a
you saw it on TV.
geostationary position.
Okay.
Over the equator, and all of the satellite dishes that people use to point at that thing are all pointing that way and have been pointing that way for decades.
Yeah, I'm sorry. They're pointing towards a cell tower station or a communication station. There's no information
No, they're
going to
pointed to the
magical
sky
outer space.
directly.
I'm sorry, there's no such thing as magical
but they're not
signals
pointed at
because I
cell
watched. I
towers.
know you can't
Since
let me
that
talk.
was
Why
a
are you
lie
interrupting me? Can I
introduced by
talk?
you.
Listen,
Yeah, I
Satanist, can I
understand.
talk? Hey,
If
pervert.
you're just going
Pervert,
to
can
lie
I
and
talk,
say they're pointing
retard?
at cell
Hey,
towers,
Satanist,
you're going to
pervert.
get
Yeah,
called out on
retard. I'm trying to.
Calm down.
Right, but they're
Jeez.
not pointing at cell towers. That was a lie that you made up.
The other thing I was going to bring up, Doofus, is when you're out in the middle of the outback or somewhere where you don't have mobile phone coverage, you can have a certain phone that relies on a certain thing that's in space for communication. Yeah, I wonder how that one works.
Oh, I have a question for Exo. Who's the manager of the Flat Earth? Oh, there isn't a manager? Okay, therefore it's false. Thank you very much
Being
for
muted.
playing. I claim victory.
Hello?
Yeah, well, you're talking over people. Oh, okay, jumped out now. Oh, well.
They're
Go
all
ahead,
pointing
Exo.
at cell towers, he says. Jesus fucking Christ.
Yeah, I know when he brought up cell towers, that's what made me think straight away of what if there's no cell tower coverage in that area?
I've heard him say, or someone say, I think, when in response to my picture of TV receiver, satellite TV receivers in Quito, Ecuador, pointing straight up, that they're not pointing straight up. They must be receiving signals from the ground. But
Why was I muted when I was interrupted? Who muted me? Can I just get an answer? Why was I muted when I was interrupted?
Because you
I was
were
speaking
yelling
and I was interrupted.
repeatedly.
I was being interrupted. Why is Matthew Lawrence speaking right now when you're not a moderator? Can I just know you muted me when I was speaking? I was interrupted and then I was just talked all over, then muted. Can I just know?
Hey, Dickhead, shut up for a second.
Yeah. Why am I being muted? I was talking. I was being interrupted. I was being interrupted. I was being interrupted. Okay, yes, this is okay. Yeah, I was being interrupted. Right. You guys are scared to death of your own shadows. You guys want someone to talk that actually has life experience?
Act like a child.
Yes, bro. Do you want someone to actually talk that has life experience, or should we just talk to internet minions?
A question.
Yes, you interrupted me. Yes, I was interrupted. Yeah, so the rules only apply for retards and perverts. The rules don't apply for people that live in reality.
Perverts. Oh, let's go there.
Oh,
Can we
no,
start
no,
talking
don't go
about
there.
perverts now because you brought it up, Exo?
We did.
He wonders why he
jumped out before.
He just did the same thing a couple minutes ago.
No.
He just starts screaming insults and starts doing so.
I know Doofus can get a little bit emotional sometimes, but
No, that guy, that's like goes into like full troll mode when someone just starts screaming insults like that. Yeah, just to try to take over the live stream. It's pretty bad.
Woke me up.
it's just the talking over that annoys me so much because I like other people to at least join in some of these conversations, but I don't know how much delay I actually have between you guys and me, so it is hard for me to find that gap. I suppose
think it makes a
Bandy has
difference
the same
depending on
problem
where the
too.
room is hosted.
Sorry, I talked over you, Diff.
I don't know. Maybe we started at the same time. It makes a difference where the room is hosted to, because you can have the room hosted in, say, Japan, for example, and it might reduce the lag for you and increase the lag for anybody in the UK.
Mm. Well, we've got another Aussie dropped in.
Oh, no. Not two Aussies.
Yes, SC.
Oh, God. And then my buddy's going to come. We're going to have three Aussies. But that's a cool Aussie, that one. Well, you too, Terry, I got to say.
Oh, thank you, SC.
The only thing separating you guys is one huge hump. Humpty Dump. Oh, man.
And water, too.
You guys are far. Yeah, that's a big hump. How big is that hump?
I'd have to get me tape measure out and measure it.
Like Eastern Canada to Australia? That's pretty far.
Well, if I was to tell you the hump they say is at the equator, you wouldn't believe it.
Well, there's only a hump at the equator.
Yeah, because your spinning ball rotates.
That's not really a hump though. That's not the
It's
same.
45-mile hump. You know that,
No,
Coach.
no, that's not what it's stated to be.
I think I can find the quote.
I think it's like 22.
22? Well, last time I checked was either 35 or 45. Anyways, that's a pretty big hump though, huh? Either one of those?
It's not the same.
Yeah, it's not located precisely at the equator. It's like it's not a hump that appears 1 degree south and 1 degree north on either side of the equator. It's gradual over the entire 90 degrees.
I could even find a bigger one for you. The hump between the North Pole and the South Pole is 4,000 miles high.
Yeah.
See the difference there?
Well, if two people are standing at the North Pole facing away from each other, there's a big hump in between them.
Yeah.
8,000 miles. There you go.
So, Matthew, what do you currently think, like percentage-wise, that in this lifetime you're going to see absolute physical verification and measurements that can be visited in person that show no curvature? And along with that, everybody essentially realizes it's not a globe. What percentage in your mind right now do you think that will be a reality for you?
I would say there's at least a 90% chance that within the next 20 years, humans will return at least into the moon's orbit, and those people who get sufficiently out of low Earth orbit will see the Earth as a sphere. And so for those people, it'll be 100%. But no matter how many, even if there are thousands of people that go, I think that there will still be some people who love the idea of flat Earth so much they won't believe that eyewitness testimony and pictures and live video.
Wait, so I brought up measurements. You're bringing up space travel.
Yeah, exactly.
Civilian space travel.
Eyewitness testimony, yeah,
will be a reality. So you're saying, so you didn't really answer of it being measured to not be a globe in that sense, but you just said you feel like there's a 90% chance that we're going to see civilian space travel, which will prove it that way.
Within 20 years, yeah, that was my answer.
Within 20 years. That gets you through Agenda 2030, I guess.
Right. I mean, as long as we get through the Agenda 2030, where we have the Illuminati trying to take over all of you guys, then I'm good to go.
They're not going to get it, so we're good. They're not going to get their new world order. I mean, they'll cause a ruckus for sure.
I don't know. My controllers
invasion, and that's going to be brutal.
My controllers at the shill organization I work for, the NASA shill organization, the boss shills we call them, they tell us it's really going to happen. We're almost there.
So would you believe an alien invasion event?
No, I don't think I would.
You don't think so? How were you on the not to take it into this topic, but on the pandemic thing? Were you
yeah, so the pandemic response was kind of bungled, but
you believe that one, but you're not. You believe that one, but you're not going to believe the alien invasion one.
I believe terrain theory is false. I think viruses are real.
That's fine, but I'm saying the way that, like, what they claim it is and how it was carried out. Like, you bought it. Like, okay, that's at the end of the day. Did you? I know there's a lot of like in betweens, but would you say overall that you bought it or didn't buy it?
I bought most of it. Yes, I think they didn't have the best response, but I think that the virus killed more than 1 million people worldwide. Yes.
Okay, but
right, the people communicating the issues.
Fake alien invasion. You don't think that one would get you? You're not going to buy that one.
I don't think so. I doubt that they will use that because I don't.
Yeah,
think
it's too much without precedent is the issue.
Yeah, that's a good point. Yeah, we've had other viruses. In fact, 100 years ago, the Spanish flu, but we haven't ever had alien invasions.
But the alien invasion would not be to kill people. That's not the issue. It would be because they can do war. They can do all kinds of stuff to do that. I mean, there's probably as part of it, but is that what you were thinking it is? I mean, it's not necessarily about that, my understanding of it. It's not just that they need to kill off a bunch of people. Is that why you were relating it to like a pandemic and they could just do that instead?
No, you were asking if I would believe in alien invasions, and I said no. And then you said, well, you believe in this pandemic. And I said yes, because we've had a history of that, like 1915, 1918 or whatever. We had another pandemic.
Right, but I
Right,
mean, in
and
my viewpoint, these are like psyop events that are being rolled out. So what I'm saying is that the pandemic one, this last one, however that one, just in turn because it was all in the news and the whole thing, right? It was just so, and then the actual jab deal, you had to get this new thing, and so it was a huge litmus test for in that sense. So
so
what I'm just saying is that in my mind, these are events that are being played out. And there's other factors too. There are biological toxins in the environment that are affecting people's hearts and stuff as well. So I mean, I'm not saying it's all just, but anyways, it's a whole topic. I wasn't even trying to go into that. I was just saying that, but the idea of these same people that's planned that would also be planning a fake alien invasion. So that, in a lineage of moon landing, 9/11, the whole 9 yards. So what I was just saying to you is that from where you're at right now, if there was what seemed like this alien, invasion thing, and there's, things you could see in the sky and all this stuff is happening, what's the likelihood that you'll believe that one, that you'll buy that one?
not very high. It sounds like you're talking about from the top level, some scripted trying to take over the populace type of thing, and I don't think there is that kind of coordination possible.
So you don't even think it's possible that the clandestine parts of the government, military, etc., would be able to pull off an event like that? I mean, even though they've pulled off so many other things, you don't think they could do that one?
What have they pulled off?
Enormous! I mean, World War I, World War II, all wars really, massive things. They've pulled off events, full-blown media correlated, media timed and synced up events on multiple levels. But I was just saying that if the mainstream news and all that was saying that there's an alien invasion, I'm just saying, will you buy that, or would you? You won't. Okay, so you'll call them out and say it's bullshit.
Right.
Is there anything they could do to convince you that it actually is the real aliens, which of course would be the reason that you would believe in the globe, because that for you aliens are actually possible now, right? In that
philosophically, I think I'm pretty much opposed to the idea that aliens are possible. That's a philosophical argument, though. And to answer your question about when I would believe it, I guess I would have to see it with my own eyes, have credible evidence that, like, oh gosh, here's these things that don't look human, that are acting intelligent, that don't look like any other animals. All right, fine, they're aliens.
Well, I mean, that like Werner von Braun, the director of NASA, after World War II, et cetera, I mean, I'm sure you know who he is and all that. So, I mean, that he stated that the final event was going to be a fake alien invasion to bring in the New World Order.
And he was wrong. He died before any of that happened.
But he didn't say it would happen at a particular time. So it's not like that. It's not like he made a date prediction.
So it's not falsifiable, his prediction.
Well, if it's going to happen in the future, then yeah, it wouldn't be.
Right.
Or it would be. Wait, I forget. What did you say?
It's not falsifiable.
Oh. Well, I guess anything of some level of prediction in the future, you could say, is not falsifiable.
Right. That's why I don't pay a lot of attention to those type of predictions. Even though I just made one saying there's a 90% chance that we'll go to the moon. But oh well.
Well, I mean, I guess I'm just like, I'm trying to like, I know you don't think there is sort of a global cabal, as it were, global, that word, cabal, globalist cabal doing all this stuff. But if there is, what is it going to take for you to realize it? Like, is it that they're going to have to overstep a boundary, or is it that you're going to do certain research to discover it yourself? Or do you think that like the entire human race would be going through something that you would be a part of as well, if that was the case?
The broad
or are they just going to keep getting away with it?
The broad answer would
legit.
be...
Sorry, or it's legit. It's like those are your options.
Yeah, the broad answer would be that I would have to see convincing evidence. And I know that's a really broad answer, but convincing to me, given my preconceived notions and biases and all that type of stuff. So that's what it would take.
Yeah, I mean, but in terms of the alien invasion thing, doesn't it just make sense in a logical way? Like, let's say the Earth not being a globe and all the space stuff not being real. Like, would it make sense in your mind that like that all was like a huge, like basically 100-year indoctrination process to get enough people to believe that aliens are possible to the point to where they could do some huge military type undertaking and try to pull off some huge reset type event?
That's a possibility, sure. I mean, I suppose anything's possible. I just don't buy that. I don't think they would be able to coordinate that well. I mean, look at how much all the different countries and leaderships fight amongst themselves. I don't think they'd be able to pull off some kind of worldwide deception like that.
Yeah, but is that fighting actually real, or is it just propagandized and put in the media?
It's real, and it's not just, but it is also subject to some level of propaganda.
Because the way I see that is that there's different layers of it. There's, there's like the kind of, let's call them the higher layers of the actual control, people that are actually in control. And then there's all the media and all the kind of, quote unquote, lower level, like your congressmen and senates and all, those guys are all just sort of in a boat in a huge ocean, just trying to slosh their way around. I mean, so in terms of the fighting and, this country did this today and this, law was passed. I mean, that's all at a much lower level, and they can create all kinds of media hype around countries fighting and tensions between this country and that country. It's like a whole soap opera that they're carrying out, and all the tensions, and they're trying to get these different people in countries, and then manipulating the finances between them all, of course, through the central bank system. Man, it's just so clear to me it's what's going down. But yeah, I know, like you're saying, you just don't think any of that's even there.
I guess I'd say I don't think it's that likely. I mean, of course, we don't know for sure any of these types of things. I just find it's more likely that it's not true than it is true. That's all.
Yeah. Likelihood. I have to think about that. That it's more or less likely. What does that mean exactly? It's less likely that there's people that are controlling things?
In general, when I look at the evidence, I think the evidence points to global leaders sort of being at each other's throats and fighting amongst themselves. And I think it's less likely that they're actually all part of this secret conspiracy with zero evidence, and that they've all been coordinating and writing scripts about pandemics and wars and all that type of stuff. I think that's less likely than the more generally acceptable idea that, hey, people fight and disagree, and the world is complicated and messy.
Even though they're all part of the United Nations and they're all friends when it comes to that, Antarctica?
Yes, even then.
So you think they're fighting, but they're all on the same team as well through the United Nations?
Sending ambassadors to the United Nations doesn't mean they don't fight.
Yeah, I'm sure. What were we? How did this start? What was the original thing we were talking about? Oh, the alien invasion thing. But what was kind of the core of this? Because I feel like we were. It's not a bad thing, but we are kind of in the weeds at the moment. I feel like. Well, I guess yeah. It was the idea of would you go with an alien invasion event? Because I mean, what they could do with that, if they've already got enough people believing in the globe, they could use basically war stuff, different technology to show crafts in the sky and laser beams or directed energy weapons or whatever, so they could create certain war type scenarios, and then claim that they basically have to all sort of come together under one structure to combat the aliens. It's a galactic thing, we have to, and it'll look like it's all humanity all coming together, and it'll deceive people that already believe in this. But in the end, it's actually trying to just get people under a more control, that idea of a new world order.
Sure. Well, maybe they could have a fake pandemic, and then they would have to have the whole world come together to solve it and make a vaccine and have a world government. Well, that didn't work out very well, did it?
Well, they did it. They already tried pulling that one off.
And how much togetherness is there in the world now?
Well, I think it kind of backfired on them, actually. I mean, but I don't think the goal of this last couple of years pandemic thing, I don't think the goal was necessarily to bring people together. It was to fracture people. This was like a fracturing one, trying to separate people and keep them more separate and muzzled, you know, with the mouth being blocked and less human and dehumanizing. It's all part of like, these are like psychopaths that are kind of like entraining humans, basically. It's kind of dark. It's kind of sick.
And so you think a fake story of alien invasion wouldn't have the same effect? Some people would be saying they're fake. Some people say they're real. We should have different responses to this. We should make friends with them. No, we should fight them. I think it would be very fracturing. I don't think that would work either.
Well, it would be a combination of fracturing and, I mean, they'd be trying to bring people together under their, like, have you heard this idea that in the future, like the way that the world's going to go is that there's going to be like, basically whoever these entities are that are doing their thing, they're going to start going more towards smart cities. Now, maybe eventually, I mean, they'll be they'll be taken out of power entirely, but I'm not really talking about that far out. I'm just talking about in the immediate future where they're going to start trying to kind of really concentrate their control in their cities, like the smart cities in that sense. So if that's the sense, then it's like they're looking to bring the people that are most willing to obey them and most are, you know, sort of indoctrinated, if you will, and believing the whole thing to control them even more because they know they can't control us all. So the rest of us will be out on other lands, other, you know, I don't mean like other continents, although that could be possible at some point as well. But I'm just saying like living outside of those kind of city control areas, which is already happening, like in China and Hong Kong. And you have to have like a special pass to get in, and it's like timed, and you can't stay in, you know, all that stuff. So they're already kind of doing that in terms of the boundaries and the, you know, the mandates for the jab and all that kind of stuff, the medical. So they're already kind of trying to hyper control certain regions, which, yeah, in China, of course, is, and like Korea and whatnot. Yeah, there's places where they're carrying that out.
Sure, governments try to control people, and it's always been true. Probably will be true in the future. I just don't think that they're going to have an easy time uniting the whole world on any cause.
Right. Well, all they would need is, I mean, I guess like it's down to who they are and what they're doing. But I mean, yeah. They're obviously trying to, in my mind, trying to control as many people as they can. But
so I hear what you're saying, but I, in general, think that the main motivation is not controlling people, but making money. I think Putin and oligarchs and even governments in other countries, in the end, it's all about, it's more about money, is my suspicion. I think money is more powerful than power, but I don't have anything to back that up. That's just my suspicion.
No, I hear you on that. The only thing is that from my perspective, I mean, they print the money. So like they literally own the Federal Reserve and the whole deal. So they basically print the money that controls the central banks and the world banks. So I don't think it's actually about the money itself. They have as much of it as they want, literally infinite. They're like the monopoly man that has as much as they want, especially when it's all digital these days. I mean, they can make a bank account that just has infinite money. And then you could just go buy anything as many times as you wanted. You could just buy like 5 yachts that all cost $50 million each and just, you know, you have a bank account that's literally infinite. So I don't think they actually are doing it for money in that way. But what I do agree with in a sense of what you were saying, which is that they have to keep the charade going. So that's where the inflation comes in and all that stuff. The inflation is caused by them having free money. They make the system so that they have free money and we all have to work for it. And the inflation is the result of that. Then they just keep doing the stranglehold more and more. But so they're keeping the charade going in my viewpoint, but they don't actually need the money itself. They just need us to have as least of it as possible for the amount of value we're willing to put on it. They just have to keep that going. And then that trying to keep as least as possible out of the hands of most keeps the inflation rate and then keeps that whole system. So yeah, so they are doing a lot for money in that sense, but it's more just to kind of keep the balance and keep the charade going rather than them needing the actual cash. They're not like hard up for cash, you know. When you print the money, they could just, you own Chase Bank or whatever, you can make an account with anything you want in it.
Absolutely. I want to say good night, guys, and good night, Doofus. I hope I didn't trigger you too much, bro.
All right, I see. Take
it easy, guys.
Yeah, bro. You too, man.
Nice chatting with you. Take it easy.
Yeah, I was typing. Sorry. Cheers.
You too, Matthew. Thanks for the convo.
But yeah, I mean, so all this stuff, I mean, it sounds like you think it might exist. Like you have, I don't know, you said 90% before. So It sounds like there's a part of you that's like, yeah, there actually could be a group of people that are doing that. Now, to what extent, is or isn't happening. But I mean, sounds like you're not like 100% believer in what they're giving is what it sounds to me. But I mean, you could correct me if I'm wrong, but
Yeah, no, that's a good characterization. Sure.
and you're skeptical,
Right.
but also willing to stay open-minded to
Right.
a convincing set of evidence that is what you're seeking when it comes to whatever topic.
Sure. Yep.
But you're kind of opting. If you were taking a multiple choice test, you would click on the globe Earth category.
Yeah, I generally stick with what seems most reasonable, has the most evidence, and kind of sounds least crazy, I guess. All right, I'm gonna say goodnight to you. Nice chatting with you.
Yeah, man. Yeah, you too, Matthew. Have a good one.
Doofus, it's fun tag teaming with you.
Doofus he's like a Energizer Bunny. He just definitely does get wound up. You guys were you keep it pretty cool, pretty chill.
I try.
Well, yeah, man. Good stuff. What's up, Kosho?
Yo, yo, yo. Yo, 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 yo. Who's around?
Yo, yo, what's up, Fundy?
Hey, Geo. Man, how you doing this morning, perhaps? Where you're, I don't know. It's pretty late where I'm at. How about you?
It's about midnight here.
Midnight. Oh, that's not bad. You on the West Coast, America?
Yep.
Man, I got something deep to drop on you. You ready for it?
Yeah, I'm kind of mostly just listening right now, so I might not be able to say too much, but I will be listening. So yeah, man, let's hear it.
Okay. Ah, man, it's not gonna feel right without feedback. Maybe we should save it for another time.
I can give some for a few minutes, but I do need to step away in a few minutes. But I can definitely
Okay.
I'll respond. Let's hear
Okay.
it.
I'll try to be hasty about it. So, so you know the idea of baptism, right? So someone is filthy, impure, and then the baptism process is a cleansing process. It's also a death and rebirth process, and in that death, everything about you dies, including the bad and the good. But then only the good is allowed to be reborn. That's the whole idea of you being purified through it and washed of your sins, right? That everything about you dies, and then only the good parts about you come back to life, leaving behind all that was filthy, as in how a shower or a bath will like cleanse you of the filth, right? It's very similar to a shower. So, to me, I grew up in a church where 10 people in a row would line up, and all their family would gather, and then the guy on stage, call it a priest, call it a minister, whatever you want, would take them to this like glass pool, sort of the size of like a large hot tub, and he'd dunk them underwater, and everyone would clap. Woo! Oh man, this person was addicted to drugs and beat their wife and was a horrible person and has been arrested. He's a felon, but he's been baptized and he's been reborn and purified, and as if getting someone wet actually changed any of those parts about them, right? Like it doesn't. That's just the honest truth. That person is the same exact person they were a couple seconds ago. Now their hair is wet. That's the only difference. But
all right. Well, but I mean, of course, if they would see it as a symbolic thing and so on. But I do hear what you're saying. Yep, I'm with you in terms of what you're
right.
Basics of that. Yeah, like the physicality of it.
Right. So here's the problem, right? Someone can improve themselves. Someone can let go of those evil, addicted, gluttonous, sinful aspects of themselves, and really, abandon those negative aspects of themselves. No, it doesn't take back the things that they've done. What you did, you've done, sure, but you can move on. You can let go of things, and you can, be a more pure being in your actions and your mind state, and all of that. But it's it may need some work, some like inner work, like people in the spiritual community sometimes call it like shadow work, right? Like meditating and reflecting, contemplating about yourself, and like really like dealing with these things and like defeating your inner demons, right? But doing this actual hard spiritual and mental work isn't just done as easily as just like getting dunked in some water. This is not a substitute for the actual work that would have the result of what they're saying this thing does, this ritual, this water dunking ritual. There is an actual work you can do to accomplish it legitimately. This is like a bullshit version or a symbolic version. But for that person to really become the better person that they're pretending that they are now once they've gotten their hair wet, like that involves maybe some physical works, some meditation, some reflection. What's that what's that biblical term or Christian term where you like kind of like reflect on your negative sides to improve upon them? It's not just reflect, it's what do they call that? I'm sorry if I'm not.
When you talk to the dude through the little gate? Or
No, not that. When you're just alone, when you're just alone and you reflect on your sins or whatever. I think there's like a specific Christian word that they use for doing that. Oh, jeez. What is it? Repent. Oh, there it is. When you repent.
Yeah.
Right? There it is. So why would they say you ever need to repent, in order to better yourself, if just getting your hair wet is so easy and repenting is hard? Repenting is hard. Looking yourself in the mirror, really, really addressing the issues. When you really take a good hard look at yourself and address those issues. Well, why repent when I can just get dunked underwater and now I'm purified? You know what I'm saying? So it's like imagine someone gets put underwater, right? But they have gills. Like they're not going to drown. But a proper baptism, in my opinion, would be someone who has issues that they know about, and this has to involve some sort of fantasy technology or something like that, or magical device. But a person is put underwater who is impure, like we all are, or whatever, and they're only allowed, or more. Let me put it this way: someone is outside in the real world, but then there's a room, and they're put inside of a room, and the door is locked. But the lock is on their side, and they're like, okay, let me out of this room. But then the door tells them this lock will only open and let you out of this room once you've defeated your inner demons and dealt with yourself and gotten over yourself and come to terms with yourself and slain your inner demons and found resolve and purify yourself through the actual work necessary. And then once you've done that, then the door's like, oh, good job. You're allowed out now. This was your baptism. And it took actual hard work in order to accomplish this task, of being purified and reborn. And so I was thinking, about writing a story that kind of, like, someone gets baptized, but it's more like an initiation process where, say, someone's elected to be king of a nation, but it's part of the culture that the person who's elected king is like taken to a very deep underground into a cave system, and at the bottom of it is like these magical waters, and they're thrown into the water, and their whole body gets like dissolved into the water, like a cube of sugar or whatever, or some salt would dissolve into the water. Their body is thrown into the water. Their body is salt, and it dissolves, and then they experience their consciousness enters in like an imaginary pocket dimension where they enter into a world, but it turns out that the world that they like are born into, this like this brand new created world, is actually based on that person's like spiritual and mental state, and they have to go live in a world that's like a world that's a reflection of who they are. They kind of have to they're forced to live in their own mind without being able to like use drugs or escapism or anything to like not like look at like to not take that hard look at themselves. They're like force fed like a very clear image of like this is who you are, but they don't know it. They're born as a baby into a world that is a reflection of who they are, but put external to them instead of inside of them, and then they have to live in that world. And of course, they're going to have issues with this world. They're like, oh, that's wrong. That's stupid. Oh, these people are fighting with each other. But it's really just like reflections of the real life version of their mental state. And then they go try to like fix these issues in the world that they have, problem with, that they're calling out. And at the end of the story, they've gone around the world, living a life in this experience, and helping these people in front of them, like kind of like that are disputing or warring. Like there's like two countries at war over some sort of dispute. They hold different perspectives, but then the main character comes along and kind of like helps them find some middle ground and resolve their differences. And like and then at the end of the story, once that's happened enough, they've made the world the best world that they can, then that's when they're finally allowed to like re-solidify and crystallize out of the water that they were dissolved into as like a more purified, aligned, and like cohesive person in harmony with themselves, and not so disharmonious in their spiritual and mental nature. And maybe they're even like healthier physically too, but mostly the focus would be that they're they've faced their inner demons, they've solved their cognitive dissonance, they've looked at themselves hard in the mirror.
Yeah, it's like a real rite of passage versus kind of like an artificially ordained like imitation rite of passage that's just given under this kind of authority rather than the actual person going through their own like individuation process and
and in that
actual death and rebirth.
Yeah, and in that sense, I think I've come to realize that a person's life as a whole, like the life that you and I are living right now, is, if you do it correctly, like some sort of baptism process. Like you and I are in the middle of being baptized right now. You know what I mean? Like we have the opportunity right now to perform, say, some sort of cleansing process of of our issues and kind of like slay those demons. Like this is, I don't know, it seems like the story I want to make is some sort of fractal level of baptism and like life itself. And it ended up like I didn't even mean for it to be I started writing a story and I didn't even realize until after I had written all the details down that subconsciously, I was like just describing a baptism process. I looked at all the details I had written down on paper like a couple days later after I kind of came to like an overall story plot, and I was like, oh shit, some dude is flawed, gets put into water, is cleansed of his sins through and then is reborn out of the water as a more pure being. Like, oh no, I thought this was an original idea. Turns out, then I realized just looking at it at the end, right? I'm like, oh, this is literally just someone getting baptized, but legitimately, it's like a legit baptism in a sense. I was like, oh man, I like subconsciously channeled like that like lesson I learned as a kid, those experiences of someone getting cleansed in their water, and like accidentally just made a story based around it, I didn't even realize until later. But this happened really recently. And it's made me like really ponder on the significance of this thing that I used to mock, as a churchgoer. I would just be like, what a bunch of crap, that's what I would think of this baptism ritual I'd see being done in front of me. I'm like, what a bunch of crap. Like, what are these people doing? Like, who cares? Like, people would tell me all the time, like, oh, all you gotta do is sign your name on the sheet and like sign up for your baptism. That guy that you barely know on stage that everyone loves in this organization, oh, he'll get your hair wet. He'll dunk you underwater and say your name over the loudspeaker system, right? Oh, you'll be the center of attention. It'll be so good. I'm like, I don't care. No thanks. Right? I just thought it was the silliest thing in the world that people were doing up there. I would go. It was like good for you. Like what is different now? Some dude you don't know barely, dunked your head underwater. Wow, this is supposed to mean something. But then recently thinking about this, I'm like, oh, you know what? Like the message behind it, regardless of the bullshit ritual people do at my church every Sunday, the message behind it is actually extremely profound, which is probably why they're doing it in the first place, where this whole thing started. Despite the lame version that I witnessed in my childhood, the essence behind the meaning behind the ritual is actually extremely significant. I come to like respect and acknowledge now in my older age, thinking about it. It's like, oh yeah, baptism it's a pretty wonderful thing, but I couldn't realize like it isn't like baptism can never be just a moment. It's like, oh, yep, there you go. I got your hair wet. Now you're purified. Purification means a purification process of death and rebirth. It's not as simple as they want to tell you. There's effort that needs to be involved in order to do it properly, in my opinion. But that's where I kind of think that like this is your baptism. Your life that you're living right now is your baptism process, and you're going to be cleansed as much as you're willing to cleanse yourself of. It's up to you to clean your own house. It's up to you to pick up the trash in your bedroom, and make your bed and vacuum the carpet and sweep the floor and put your stuff in order. Like, that's on you. The guy dunking you underwater, he's not the one baptizing you. You're the one who is responsible for baptizing yourself. You're the only one who can clean up your mess. People can help you. Sure, people can help you. I'm not saying you're on your own or anything. But it's crazy. And people will say, "Oh, I'm baptized through the grace of God," but the way it really comes across, in my childhood, is that this guy in the white robe on stage, right? He has magical powers, and he has a magic pool of water. And if you go to him and you allow him to dunk you with his magical powers in his magical water, he has the ability. It's not on you. It's on him. He's the one able to wash you. He's gonna give you a spiritual bath, and he's gonna give you a sponge bath, and he's gonna wipe all the sins away from him, because he's the one with the power to do that. But of course, he can try his best to he can give some sort of murderer a baptism, right? But it's not on him. The guy who he baptized, he's just gonna go murder someone else or steal or cheat or whatever the next day. He has no ability to change that person. That person is the only one with the ability to change themselves. I don't even know what the idea is behind having some guy baptize you as symbolic. Is he some sort of representation of God, like, which just in a whole nother sense seems very inappropriate. You know, I think that the whole idea of say the rituals I was told from like whatever, like third world country tribes on deserted islands of like walking across hot coals, like that, you have to do that yourself. That seems way more like hitting the nail on the head there. And that's sort of like a baptism through fire in a sense, or trial by fire. But it seems way more appropriate to me to be like, yeah, you're the one who's going to go through this ordeal, and if you're not strong enough, you're not going to make it all the way across. So why don't you show us that you're willing to do the work that only you can do by walking across these hot coals, you know? Because it's on you. No guy in a white robe is going to fix you. You need to fix you.
Right, I hear you on that. Well, I mean, the idea of baptism, it's interesting, like, because when we're born, we're actually born in liquids, you know, and so there's that connection to it, and then there's also like the kind of themes of like death and rebirth, which they're using like the physical water to kind of replay that, but like you said, it's more kind of ordained by an authority rather than an actual death and rebirth process spiritually, where, like you said, like someone faces their demons, they go through some layer of themselves and then get a greater understanding, have some healing process. So a part of them dies, like a part of them that was
worth abandoning.
Yeah, in a sense, like sort of in the dark in a sense, or it was just sort of in like a pattern of like ego satisfaction rather than more of like an integrated process. And so when that kind of death of the old self, then a rebirth of the new self, is a very real thing that occurs. And it seems like perhaps baptism is trying to kind of play, you know, use that with the kind of almost like cleansing your karma, as it were, like the way they say cleansing your sins, but I kind of see it more like in the roots of where that came from. It may have been more of a cleansing karma, because if you face some part of yourself and then change your ways, then it's like that is a part of you dies and a part of is reborn by the greater understanding.
Mm-hmm. So let me ask you, Gio, if you had to make a short story of someone who has to learn a lesson about themselves, but of course it's externalized, right? So like you take yourself and whatever issue you may have, right? I'm not going to tell you what issues you have, but you know, right? And you're put in a scenario where your internal issues are then externalized, and you're put through some sort of process where like it's an obstacle in your path that you must overcome to physically move forward. And it's like, how would I feel like this is literally all that's ever done in storytelling. Like I feel like this is literally the core of it all. But I have a hard time really formulating my question to you. But because I don't even know what you tell me, but besides, that's literally every story ever told. I'm not trying to ask you like come up with a story off the top of your head, but I don't really know how to formulate this besides just asking if you're vibing with me, that like any story where some character like faces a bad guy, that bad guy could be seen as like a manifestation of part of themselves that they're trying to address. You know, defeating the bad guy could be a metaphor for, you know, defeating a part of yourself that's one of the impurities of who you are, you know. Is that making sense to you?
Yeah, and even exactly, and even kind of categorizing it like with like the concept of the ego, which I know some of that comes from kind of Freud and some of that stuff, but just the basic, well, the roots of it, at least that concept in a way, but just the roots of it of like, I guess the idea of it in terms of like The ego is the part of our identity that identifies with, in some cases, like an impure part of ourselves or something connected to perhaps like traumas or different situations like that. Then the ego gets kind of locked with it. And then usually when the trauma is confronted and like the demons are confronted, as it were, it's as if that additional energy is cleansed from the person, the ego death occurs, and then they move forward not impacted by that impurity as kind of moving that part of it through.
Right. They're not being misled in that way anymore. It has no control over the trajectory of their intentions anymore, where they're trying to go. It's one less devil on your shoulder whispering in your ear that you've finally said, I'm not listening anymore. Shut up. Like, I'm not taking your bad advice anymore. I'm going to make the right decision and not let you influence my decisions anymore. You know what I mean? They really should, I've never seen a story like this, but they really should make a story, someone, maybe me, that like the 7 deadly sins, right? That there's one devil on your shoulder for every 7 deadly sin. And they're all in specific situations and scenarios, like whispering in your ear, telling you what to do, what decisions to make. And like throughout the story, one by one, you kind of like get them to like leave you alone, or I don't know, put a muzzle on their mouth or something, where you stop, where you stop listening to the advice of, one by one, these 7 demons on your shoulder. You know what I'm talking about, right? The old school cartoon stuff with the one demon, one angel on both shoulders telling you advice into your ear.
Right. Yeah.
And I'm thinking for my story that I really want to tell, that, it isn't necessarily like that, but that's just like one way of talking about it for now. That you could have 7 different demons on your shoulder that all like represent one of the archetypes of the type of lies you tell yourself. Like one of them is always saying, "Oh yeah," like giving you greedy advice. One's always giving you lustful advice. One's always giving you wrathful advice. He's saying, "Oh, that person cut you off in line or whatever, or was rude on the road. Oh, fuck that, honk your horn. Let's get out of your car and bust his window. Let's be wrathful. He's saying, yeah, goat," and stuff like that. And that's not necessarily the story I want to tell, but that's like one sort of version that would kind of communicate the same lessons. Where it's like, oh, there's like 7. There's 7 demons on your shoulder, each personifying one of the 7 deadly sins, giving you advice and encouraging you to make decisions aligned with, succumbing to that type of sin, of behavior. And I think you heard about this before, but I mean, you're pretty familiar with the 7 deadly sins, I assume. But do you think that there's like a very clear counterpart to them? I know there's definitely a Wikipedia page on this, and I haven't researched it too strongly, but like, do you have a good understanding of like the vice versa sort, or like, you know what I mean, the counterpart to the 7 deadly sins, like the 7 holy virtues or whatever they might call it? Is that something that you have a good understanding of? Because I've never met anyone who like talks about this or ever even brings it up. Like people discuss the 7 deadly sins, but no one talks about like the counterparts on the positive side. But are you the type of person who like knows about that that flip side of it? hopefully you're listening. And I'm sure you'll respond when you can. But I was talking about the 7 deadly sins earlier with someone, and they're pretty fresh in my mind about like lust, gluttony, greed, wrath, sloth, envy, pride, and I think that really nails it. Honestly, like it comes in a set of 7 for some reason. Just like there's 5 platonic solids. Some things just come in certain amounts, and there are no more fundamental options to it. These are just like the 5, 7, 3, whatever pure expressions that deserve a rank above all other things as pure examples, such as like there is no such thing as a polygon with less than 3 sides. It's just set in stone that way. It's just the way it works out. The smallest amount, the least amount of sides you can have to a polygon is 3. Sorry, there's no 2-sided polygons. You gotta have 3 sides. You gotta have a triangle. That's where we start. You can't have a 1-sided polygon. It's just not how it works. In that same sense, it's like how many fundamental sides are there to the polygon of sin? Are there 7 fundamental sins before we start, twisting and distorting them into different variations? It's like lust, greed, sloth, envy, gluttony, wrath, pride. Similar to the 7 hermetic principles and just the number amount, it's well, in another sense, I think they nailed it. Honestly, I think there really is something to this whole 7 number, and when it comes to principles, in a sense, it seems like a lot of principles come in sets of 7. Maybe with the flip side. Go ahead.
Yeah, because 6 is kind of recursive, whereas 7 is like a new step forward. Like there's something about 6 where you have like 3, 3, 2, 2, 2, like to get to 6, but then it's like 7. It's like a completion point, and yeah, there does seem to be something to that. Like the number 7 is very interesting.
Yeah, I think about numbers in this sense. I'm not a numerologist. I'm not someone very interested in gematria to the extent that other people are, and anything like that. But
what about even kind of doing like 7, like the actual way it's drawn? It's like a line, and then it shoots off in a new direction. Whereas 6 kind of like curls around and kind of cycles in on itself.
Oh, well, that's fair. Yeah, that's very fair to bring that up in its design, for sure. But of course, then that kind of begs the question: who invented, these designs, these symbolic designs referring to these amounts? Because there's lots of ways to refer to an amount. Like some people would use tallies, like instead of using the symbol 7, they just make 7 lines in a row, right? And that also means 7 strokes. But we've inherited this system where each of these amounts have this symbol attached to them, which is such a weird thing that no one really thinks about, right? And I've heard that like it comes down to like an Arabic historic nature to the design of the symbols we use to refer to quantities. It's really hard to talk about because you have to say like the symbol that we use that's similar contemporarily to refer to the quantity. Like it's such a mouthful of a sentence to say what that that shape that we draw to refer to an amount. None of the symbols we use have any like significant, like obvious reference to the amount they refer to, except for maybe 1 and 3. 1 is 1 is 1 mark, and 3 has like 3 like peaks to its line. So,
yeah, well, 3 kind of has like 3 points that make a plane. Is kind of how I see that.
Mm-hmm.
The 3
and
points.
1 is one thing if you just like consider 1 just like a line, right?
Yeah. 2 is interesting.
But
it's kind of a half curl and then goes off to the side there.
yeah, but other than 1 and 3, there isn't any sort of obvious like symbolism.
Well, like,
the
4, they all have like 4 has 4 corners to it, for example.
Well, I've seen the
3
image.
3 has the 3 of them, and then 2 has like the 1. It's the loop and then the line.
Well, not the way I draw 3, but I have seen that. I've seen that image where the numbers are drawn and they're like 1 is almost like a 7 in its design, and it has 1 angle to it where the lines connect, and then 2 is like a a Z, which has 2 angles where the lines converge, and 3 is like a W kind of, where it has 3 angles, and the 4 is drawn as through. Like, that is a very beautiful system. I'm not sure I believe in it, but it is very clever. It gets a little funny when it comes to the number 9, where it has to have like an extra curly tail in order to like justify that. Do you know the angle thing I'm talking about? I think you do, right?
Yeah, I think so. The stylization.
Yeah, where there's like right angles, or like the amount of angles in the design of the symbols kind of matches up. It's pretty cool. I just don't know if I buy that that's the origin of the symbols themselves. However, it's very convincing to the point where I just want to say like, screw my skepticism. It's such a sexy idea that I don't even care if it's right or wrong. I'm just gonna believe it anyways. I'm sort of like in that position, just out of ignorance. It's like, oh man, that's one answer to a question I have, and I could believe that's the answer to my question, is the truth, or I could say, it's a really good idea and it makes a ton of sense, but I'm just not, to be honest, I'm just not sure. But it is very compelling at the end of the day. I just don't want to ever spread the word that this is the truth if I don't have like a really good reason to believe it's truth, despite how compelling an idea is. I don't want to spread misinformation, It does work out pretty well though, that whole angle system when it comes to work. Do you want me to post that? Like, are you like, do you have like a really clear image in your head of what I'm talking about, or would you like to see exactly what I'm referring to?
Yeah, if you want to. I mean, if you're just talking about calligraphy or a particular type of stylization, but yeah, if there's a particular one, post it. It'd be cool to check out. Yeah, there are different interesting ways of writing the numbers. It does seem they're kind of connected rhythmically to the number. Like 5 kind of has the 1 line and then the other line, and then it has like 1, 2, the 2 lines, and then 1, 2, 3 in the whole curve, because that curve, like, it's like part of the number 3 as well. So it's sort of like 1, line at the top, line coming down, and then 3 in terms of that like half circle makes 5, and then 6 is just like 1, 2, 3, 4, 5, 6, like curling all the way down. It's just kind of interesting how like the points on the numbers. So I think that's how I was like told, in school and stuff. That's how they taught us to do it. Did you do that, where you kind of counted using the point?
No, I was never taught that. But I found the image that I think does it best as a visual example. So I'll post that in Livestream one text. Oh shoot, it didn't save. Give me 1 sec. I'll try to save this one time. Okay, here we go. Still downloading, unfortunately. All right, it looks like it's having a hard time. I'm gonna try to just take a screenshot because the download function isn't working properly. Okay, screenshot. I'll crop it.
Yeah, I also just posted one that was what I was referring to. It's just how if you number them out like this, you can actually count. You can use these points to decipher. Oh yeah, it is actually pretty similar to what you posted as well. Yeah, we actually posted a very similar thing. That's cool. Yeah, so basically it's just counting. Well, yours is a little different though, actually. Yeah, there's some different points
Yeah,
there.
it's a little bit different of a philosophy going on there with the design.
Yeah, that is.
Yeah.
Yeah, you'd have to explain that. I'm not sure I've seen that with the arrows like that. I'd have to, because the one I posted just shows how you can count the number within the actual structure of it and just have little dots on it.
Mm-hmm.
Like the 8, because the 8 has the top circle and the bottom circle. So you can go 1, 2, 3, 4, 5, 6, 7, 8. You just do like 2 sets of 4 on each one.
I'm not sure I understand. We're talking about this picture you posted.
Yeah, like see, like the number 1 has just like 1 red dot on it. Number 2 has 1 dot at the top of the 2, 1 at the end of the 2. The 3 has them all on the tips. The 4 has like 1 at the top, left, right, down. 5.
That one's bullshit. That one. See, the 4 is bullshit in this picture because the central pillar line of that 4 if it were like following its own rules, it seems would have a red dot at the bottom of the 4. I don't know.
Yeah,
it doesn't.
Like it should. Yeah, I would agree. That one's not quite. Yeah, I
although
think it's at the ones at the ground. I would agree.
Although the 1 seems like bullshit too, where it seems like the 1 should have first of all, the 1 shouldn't be like it's sort of like a 7, the 1 in this image is sort of like a 7 in a sense. But following the system, regardless, the 1 should either have 3 dots or 2 dots minimum. It seems like they're kind of lying in the sense that it doesn't seem like the same standard is being applied to each of the numbers in the system. Like one should just be a dot in this sense in order to be 1. Just like 1 dot, because even a line has 2 ends, whereas like the 2, it has a mark at one end and a mark at the other end. But the 2 makes that sort of like a crease where it stops being like a curved line at the bottom and like take a sharp turn to the right. It seems like there should be a red dot where it makes that like sharp turn at the base. I don't know, man. This image seems to have like a lot of flaws to it, but maybe I don't understand it too well either.
How about that one I just posted? The one I just posted is actually similar to kind of the one you did in a way. Shows the stylized 7 to have that like almost looks like a Z.
Mm-hmm. Right, and no one makes a 7 like that.
Yeah, that's a
but yeah
7.
And there's some weird stuff going on with the 9 as well.
There is. Look at how it curls up around. Look at what they did there. Yeah, that's they put like the 2 dots in the upper right hand part of the 9. It's just ridiculous looking for some reason.
Have you taken a hard look at the one I posted?
Yeah, it's actually similar in some ways.
To me, this one does the best. So it's talking about where angles occur. That's all it's referring to. Is like where did the angles occur? And the only one that seems a bit contrived is the 9, in my opinion. It just seems like, and the 8 and the 7. There's 3 that I have an issue with. And there's also other ways to draw 4. I don't know. It really does beg the question, like, what was the intention behind the design of the number symbols that we all know? Who invented these, and why did they choose these designs? The same goes for the alphabet, who designed the letters of the alphabet? Because when you do research into that, you don't really get a clear answer, but you do get taught some very interesting concepts that are involved in it, like how the letter A in so many different languages refers to a bull, which is kind of strange to me that in all these different languages the first letter is worshiping a bull. I mean, if it comes first, that's one way of saying you consider it most important, right? It's all these cultures consider bulls as something to worship as the first most important thing, and that's led me down a whole. That's something I kind of found while I was researching all this bull worship stuff, which is not something I have a mastery of. It's just a curiosity of mine. This whole line that I've detected, a through line. That's a recent word I learned. You know what I mean by a through line? It's a through line throughout different cultures of bull worship, and it kind of shows itself in the alphabet in a lot of cultures too. The word alpha means bull. The word aleph means bull. Apis.
They're really into their bulls.
They're really. I mean, that's all I'm saying. That's literally all I'm saying. People were really into their bulls. Even when the story goes that Moses goes up, talks to God, gets the 10 Commandments, he comes down, and people made a bull statue and started worshiping it as literally God, right? They were worshiping a bull as God, and no one ever said why the bull? Why would he come down and find a bunch of people worshiping a bull as their God? It could be anything. It doesn't even have to be an animal, It could be a shell. It could be a brick. It could be a chair. Why is a bull their representation of God? And then we say, and then we have the expression "holy cow," we have the expression "sacred bull," and we got the red heifer as as an omen of the end of times, and got India just literally having giant statues of bulls all around, just people go there and give donations and rub it with oil every week and just worship cows. And it seems like there's lots of animals that in different cultures have spiritual significance, but it seems like whenever there's a bull involved, it's I don't know, just put it on a pedestal above any other animal. It's always highest ranked or something. I could go. I don't want to go on a rant about all these ideas of things I've learned about bulls and their occult esoteric significance, but I'm sure you're already with me, man. Like you said, yeah, bitches be crazy about their bulls, man. And it's a riddle I'd like to get to the bottom of, but I'm not sure I ever will.
Yeah, and that gets into the genetic lineage of that as well. Yeah, how that all plays out. Cows and just the genetic infiltration, essentially.
What do you mean by that? What genetic infiltration?
Well, there is an idea that they have modified cows with human genetics and then are torturing the cows and thus torturing us, like through the ether and through the spirit world in that sense.
Oh, jeez. Wow.
Yeah.
Wow, that's really something there. That's some next level stuff I wasn't ready for. Holy cow.
Holy cow.
Wow.
Yeah. And the cows
Yeah,
are
holy
also,
cow.
they're also holy. And so they've been like defiled in a sense, deholified.
Say, you know how we call cow bull meat steak?
Yep.
You know, you like etymology, or right? Like you're a fan of etymology, right?
Yeah.
So you'd be interested maybe in thinking about, you know, if I ask you like, why in the world, like how in the world could you justify, you know, saying I'll take the steak, and somehow that refers to bull flesh, you know, like how did that word ever come to refer to cow meat? I think I can tell you, you know, but it's something that you might want to ask yourself, like what's going on there? Like that's kind of strange, right? I'll take the steak. Well, steak also means, like, etymologically, steak and stick, you know, are like they're the same thing. Like a stake you drive through a vampire's heart, right? It's a stick.
Yeah, or a steak
Yes.
that you would hunt a bull with.
Or nail your tent down with, or a stake. You know, stake your tent into the ground with a stick. You know, a stake is a stick, and so.
Right, but did that come from what they were using to take them down? Because I mean, that's how they would often do it. I mean, they didn't have shotguns necessarily in this kind of. Because you know, if we're talking about a similar type idea in that sense, to where they would, yeah. So because you kind of put
I
it
see
on,
what you're saying there.
you put it on a stake, like a, you know, when you do like a skewer, you put the stake through it, and then
Yeah, well,
steak.
that's where that's exactly where my research took me, actually. So, what I was told in my research was that because I'm just a weirdo who looks into cow stuff, the occult nature of cows throughout history. Yeah, I'm just one of those guys. Anyways, so you know, so similarly to how like gay. I just realized this. I'm gonna tangent away, but I'll get right back to the cows. I was talking about gay the other day, the word itself with someone, and two of my rules when studying etymology to always keep in mind are that all vowels are interchangeable. So when you're trying to like find words that are related to each other, go ahead and like in your mind swap the A for an O or an I or a U or whatever or an E, and think about words that are like the same, but you just like replace the vowels, like blood and bleed. I mean, we all know those are related, right? Blood and bleed, we all know that. But if you didn't know that, you'd be like, oh, hey, you know, blood is like two O's and everything else is the same as bleed, but it's two E's. It's like, there might be something in common between these two words, blood and bleed. And then you're researching, like you're justified, and you're like, oh yeah, I got it right. And so, you know, you can do that with words you're unsure about, and it like, gives you a hint. It's like just play around with the vowels, swap them out, and see if it makes sense. But then also there's the consonants and the consonants are most interchangeable in a whole nother system. They kind of come in pairs of twos, where it's like F and V are very interchangeable, and T and D, and P and B, and G and C and K, and L and R. And I realized recently that the word gay meant happy before its recent connotation, right? You've heard that as well? I think we've all heard that, right? Gay means happy. It's even like one like Christmas song.
Yeah.
That
Oh
we
yeah.
would sing or something,
Yeah.
right?
Yeah. I mean, that's what it originally meant, was like joyous, kind of happy. Yeah.
Well, perfect choice of words right there, because I just realized the other day that gay is etymologically, that in a sense, the same word as joy, right? Joy is goy, right? Joy, goy. Joy and gay are like just two different pronunciations of the same word, in a sense. And I haven't looked it up officially, but I think that's one of these things that I recently just like caught on to, that like the word goy, or the word joy and gay are like the same thing, because they definitely have the same meaning originally, I think. And so that was one of my recent developments. But about the steak, from my research, I've found out that up until recently, steak had a particular meaning, and it wasn't the meaning we use nowadays. Like gay had a meaning until it meant homosexual. But that's like a recent development, but it meant something different before. And so steak, when you went to a restaurant and you said, "I want a steak," I want a steak of meat, it didn't actually refer to cows specifically. A steak of meat meant, like you said, all it meant beforehand was I want a stick with meat stuck on it. I want a shish kebab. I want a skewer of meat or something like that. And it could be any meat. You just go to the restaurant. You're like, give me a steak, and they give you a stick with meat on it. But it could be chicken, turkey, whatever. Fish. It doesn't matter. All I ordered was a steak, and all that means is I want a stick with meat on it. But eventually, it somehow the word steak came to refer only to cow, which is interesting. And so I think I might have a little bit of an explanation for this. It's just my idea. But so cows are these holy creatures, and they came to be known as like the namesake of meat on a stick. So the holy cow means the holy cow is steak, and it's meat on a stick. And it's funny that we say holy cow as an expression, right? Like I've already said it today, like, oh, holy cow is like shock and awe. And it's funny that we say the same thing when it comes to using the name Jesus as an expression like that. It means shock and awe. Oh, Jesus Christ. I'm shocked. I'm in awe. Holy cow, Jesus Christ. Wow. And I realized that the holy cow being called steak as being like famously referred to as being meat on a stick. I realized that Jesus, in his most prominent role, the symbol that we wear around our neck, Jesus is also most famous for being meat on a stick, like the crucifixion. You know what I mean? He's the holy cow. He's the steak, staked on the cross, meat on a stick. The holy cow. It lines up in that way, where it's like maybe the reason when we say steak, we refer to the holy cow and we have the same expression of "Holy cow," meaning Jesus Christ in that same way, is because Jesus and steak are the two things that are similar in so many ways as being famous for being dead meat on a stick, which is kind of brutal, but dark humor does exist in the world. I feel like there's some dark humor going on there. Because I mean, just being honest, you know, Jesus is most famous for being dead meat on a stick. As brutal as that is. It's kind of clever in my opinion. And I would feel bad if I like thought there was this dude who was like literally like a perfect being who was killed unfortunately. But I mean, people die unfairly every day. And I'm not quite sold on this movie that my parents exposed me to when I was a kid by whatchamacallit. What's the guy? Who's that Jewish actor who made The Passion of Christ? Mel Gibson. Right. And I think that's a fucked up movie to put in front of anyone to watch. I think it like sells you on a whole fictional tale that kind of relates to real things that do happen. I mean, people were crucified probably as a whole like death ritual. It does seem a bit excessive. Like there's much easier ways to kill someone than just like nailing their hands and feet to a cross and just like leaving them there until they die, or like stabbing them sides. Like you can just like let me ask you, anyone in the room, have you ever tried driving wood into the ground sturdy enough to hang an entire person off of? Like it's not easy, you know, like driving a post like a telephone pole deep into the ground, say like 10 feet or something. Like it's actually rather difficult. It doesn't seem like some sort of easy or common way anyone would actually be sentenced to death. To me, it either has to have like symbolic meaning to it, or just like for fun because we have a bunch of free time and we're just going to be like masochists, I guess, like just doing this like incredibly brutal thing despite the cost of labor that it's going to involve. Like there's a reason we were told that, you know, they would use like poisonous gas rooms in World War II rather than killing everyone across. It's a lot of like excess work. To me, it's probably just a symbolic gesture towards the holy cow and the zodiac references, and maybe even like the age of Taurus or something. I don't know. I pose the question to anyone is like, how do you think there was ever a conversation or a boardroom meeting where they're like, all right, so some people committed some crimes and we're going to sentence them to death. How should we sentence them to death in a common manner? Just like just the typical way we do it. You know, nothing special. Just anyone who does. Let's dig a hole in the rock and get these really big pieces of lumber and make it into the shape of a cross instead of just a post. I mean, you can easily nail someone to a single post. Like it doesn't even need to be in the shape of a cross. That already seems like more work than like necessary. It's kind of excessive. We gotta have a cross. We gotta hang a person from it. It's gotta be driven into the ground so it's sturdy. And this is just how we take care of our people who were sentenced to death. You know, what do they say about Jesus? He had 2 thieves on each side of him. Oh, that's not symbolic. He's, you know, someone's a thief, so we drill a 4-foot hole into bedrock. Which It's a lot of work. And it's like, well, we'd love to sentence you to death, but it's going to have to wait about a week until we get these guys to make a deep enough hole. And we got to resource some lumber. Can we recycle that cross that we used last time? Hey Bob, do we have any good crosses left over from last time we can reuse this Jesus guy? No? Ah, shit. Okay, go get Jim to go chop down some timber, dry it out or something. So we need a new cross. Someone get on that stat.